पहले हम दोनों टकरा जाए।
जनगण मन अधिनायक जय हे भारत भाग्य विधाता। पंजाब सिंध गुजरात मराठा द्राविड उत्कल बंगा। विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा। तव शुभ नामे जागे तव शुभ आशीष मांगे। गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता। जय हे जय हे जय हे जय 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 हे।
Hi guys, welcome back to Android Stream Day 2, and it's going to be so much fun today as well, like how we did yesterday. And it was pretty good to see the response which we got and the support which we got yesterday. We got so many viewership for our first season for Android Stream Day, and now we are back with day 2, and this is the last day. So yesterday also we covered so many things. There were a lot of speakers from around the world. We talked about starting from states, then we talked about different things like performant layouts, then we talked about Kotlin as well, and then there were some other specific things related to saw about Android privacy, which is gonna change in Android 11, and all the other things which you might have already checked. And the stream is already available, so you can check it out again if you want that. And I'll also add timeline to that, so that it will become easy for you to actually go through all the content. And today also it's gonna be very interesting. We have Googler, we have GDEs, and we have other amazing devs who are gonna talk about different stuff, starting from let's say designing in motion. Then we have app subscription, then flow, and a couple of Kotlin talks as well, whether it can be Kotlin Multiplatform, Kotlin Actors. So all these talks are there, as well as we have 2 exciting quizzes also, which we have planned. Yesterday also we did one quiz, and it was kind of really good. 40 plus around 30-40 people joined that quiz, and it was so much fun. Today we have 2 quizzes which will be happening, one after the second talk, and second I'll tell you when we will do the first one. And apart from that, guys, if you want to support this channel, if you enjoyed the content of Android Stream Day and Flutter Stream Day, I have something amazing to tell you, that we are also planning to do Web Stream Day. You might have seen the poster already here, that's coming soon. So Web Stream Day is the next thing which we want to do. So if you are already excited for that, let me know in the comments. And in Web Stream Day we'll talk about Flutter for Web, we will talk about React.js, Vue.js, Angular, and many more stuff specific to web. So maybe that will happen somewhere around October or November, so that's the plan. But yeah, it depends on the kind of feedback which we get. And also let us know what else you want to see, so please do that. And also if you want to support us, then you can do it via super chat. You can also join our channel, or you can go to patreon.com/mtechviral, and your support is gonna definitely help our channel in doing all these kind of events, as well as publishing more content here. So that's about it. And moving ahead, we have our first speaker joining shortly. So this is a duo, Gaurav and Udhay, and they are gonna talk about designing in motion. I think that's pretty interesting if you are looking to learn Android app development, of even if you are already a developer. So looking forward to that. And he will be joining soon, and I'll be back soon with him. And my colleague Rivu, who is also the co-organizer of Android Stream Day, will be joining with us very shortly. So that's gonna happen. And also shout out to all the volunteers who are helping us to making this event possible, starting from Prachi Jha, Praful Mishra, Carlo Lucera, and Jyoti Johari. So shout out to them. You can check the full schedule at stream.mtechviral.com, and you can also get all the links of social media accounts of all the speakers, like me and Rivuda, and also the volunteers. So check them out and motivate them by following them and talking about Android Stream Day with the hashtag ASD. So ASD, or you can use hashtag Android Stream Day. So it's totally your call, and I'll just come back very soon. So thanks for watching, and I'll come back with the first speaker of the day. Thank you.
Live streaming is on.
Hi everyone, welcome back to Stream Day. Today is day 2 of Stream Day, and we are happy to bring you our first two speakers, Udhay Kumar and Gaurav Rai. So, Udhay is a professional mobile developer with expertise on Android and Flutter, and Gaurav is a recent graduate and he lives in Chennai. So they will be talking about designing in motion, mostly motion layout and how to use motion layout as a part of constraint layout. So yeah, over to you, Gaurav and Udhay.
Hello everyone.
Thank you, sir.
Thank you.
Hi, guys. So, as I said, as sir said, my name is Gaurav Rai and Udhay. We are going to talk about motion layout and how it can be used in our day-to-day life and in many ways. Before jumping into motion layout, we just want to quickly give you an introduction of what were the previous ways to animate things and make transitions. So, Udhay, just can you give a quick brief about it?
Yeah, I'll just share the PPT right away.
Yes.
So is the PPT visible? The screen visible?
Yeah, all good, all good.
Yeah, okay. Okay. So we will start with we'll start the talk with the constraint layout 2.0. I believe everyone here would have experience with the constraint layout, which is the new layout released by Google to replace the old linear layouts and the frame layouts which came along caused us the nested issues. So here the constraint layout is a flat hierarchy layout where the UI will be placed according to with relations with the parents and the nearby views. And the constraint layout 2.0 has came up with a lot of additional advantage on top of it. So the first one was the virtual helper classes. So virtual helper classes, I do believe that you know about the guidelines is the groups which can where you can tag multiple views together and then apply a particular attribute to every one of them. And the decorator class, the flow view, which was supposed to replace the linear layout for the vertical and the horizontal linear layout by using chains in constraint layout. So, but the major level we had above the constraint layout was the introduction of motion layout along with the constraint layout 2.0. So how the motion layout is actually, the motion layout was introduced in order to make the transition and the animation in Android mobile apps much more easier compared to the previous existing solutions. So before jumping into the motion layout, I would like to see what are the options we had before the motion layout and how the developers were using them. So the options we had before was the animated vector drawable and the property animation, which was really popular, and I believe one of you had worked with it. And we had the layout transitions, which was nothing but the small layout Boolean flag, which you switch, and the Android will take care of the animation by itself. And we also have the layout transition elements, which enables you to provide transition when switching between different activities and the fragment manager. And we also had the coordinator layout, which was really powerful for various collapsible toolbars and the movable fab button, where you can the movement of one UI element was able to interact and affect the movement of another UI element. Want to give you a basic working of the property animation and the animated drawable because they make the fundamental for the motion layout. So property animation, it is just a very basic low-level API framework where any property of a view can be animated when you are provided with the initial value and the final value. So here in the example, I'll just have a 3-line snippet of code where we are trying to do is we are taking the radius property of a circle and then changing the radius value from 0 to a particular value. So here you can see all you have to do is create an object animator of type float, since the radius value is float. And once the animator object has been created, you just set the start delay and the duration for the animation, pass it to the view, and the Android will take care of applying this animator to the view object. So animation here, this is a very basic fundamental concept. So they come with a few properties. First one is the duration, which defines how long the animation is going to take place. And another one was the time interpolation, so which actually represents how fast or how slow the animation is going to work at a given interval of time. So usually we'll be following linear animation, linear interpolation, but we can also use asymptotes, circular, or any kind of interpolation as we wanted. And animator set is a really powerful set of API which can let you to combine different animations and make them into a linear animation. So let's say we have one particular set of animation, and you want that another animation to start after the end of the first animation. You just create an animator set, add all the animation into it, and then pass it to the view, and Android will take care of it. So this was the first animation every developer we came across it. And this is another concept was the animated drawable graphics, where you pass on different images. So 5 different images or 6 different images all combined into an animation list, and the Android will play one image one after the other, and it will provide you a visual sensation of an animation being played out, but it's actually just an image being changed over time. So these are the very basic fundamentals of how the animation were being performed before the introduction of motion layout. So here with the introduction of motion layout, the animation has been made much simpler and easier. So Gaurav here will give you a glimpse of what the animation framework has to offer for us developers.
Yes. So motion layouts, first of all, it is a subclass of constraint layout, which means that whatever you're using right now will be very much will be compatible with motion layout. You just have to make a very small change. Then it has also additional ways to animate things. So Udhay has given you some 5 different methods, and there are many other ways to animate different or achieve different animations. But constraint layout, due to its simplicity and other various attributes and features added to it, there are many additional ways to animate the same thing. Apart from that, there are many apps that are right now using it, and since even if it is in beta phase, but you can still achieve complex interactions, which means that there must be 2 elements animating at the same time at a different state, and you can do it very easily. Okay, and it's much more what is simpler to perform it as well, or what is code it as well. Then you are also given an option for midway seeking. Okay, so before the previous methods, most of them were fire and wait for it. So when you start an animation, you have to wait until it ends. You cannot know the state, which is again solved. And now we can have a midway seeking. That is, if you have triggered an animation, you can change the state in between. You can know the state and change the state in between. For example, if a view was expanding from 100 dp to 200 dp, you can change the state when it is 50% and do something with it. Okay, anything that you want. And another one of the best part of it is that it has a backward compatibility till API 14. Okay, which covers almost all the devices and most of the devices servered. If you are working below API 14, then we can't help it. Anyways, over to you. There, you can show them the components of motion layout.
Right. So here, before jumping into the demo of showing you how the motion layout works, I want to give you what are the fundamental building blocks for the motion layout. So motion layout has 3 fundamental building blocks. The first one is the constraint set. So the constraint set is nothing but the set of rules and regulations which are all encapsulated into a particular attribute, and they are all responsible for defining where the image or what image or any particular UI should be placed at the given time of the animation. So you can have any UI can have multiple constraint sets for different frames of different time of the animation. So let's say you have an image, you want the image to be placed on the left side corner during the start of the animation, and you want to at the end of the animation you want the image to be moved on to the right hand side corner. So in this case, you have two different constraint set. One saying the image at the left side and one defining the image at the right side. So this was the constraint set is all about, and the motion scene. So whenever we're working with the constraint layout, you would have come across a scenario as you have the Java activity or a Kotlin activity or a fragment class, and you also have an XML defining the UI for the how the UI will be looking like for the particular activity or fragment. But in case of motion layout, we have one more XML case, which is called the motion scene. So for every motion layout is attached with a particular motion scene, which will describe how the view is going to animate depending on the user touch or depending on the time interval. So, so this is a this is how the motion scene is going to look like. We have a constraint set, or we have a constraint set defining where the anime UIs and views should be placed, and we have a transition defining how the UI should animate from one point to another point. So we are going to show you a demo of implementing a very basic animation flow here, so we can have a better grasp of how the motion layout works in Android.
Yes. What better way to make let's a hand get dirty and see how it works. So, Udhay, can you just fire up a Android Studio and let's see how?
Is my screen visible?
Yes, it is. Yes. So I told you that motion layout is a part of constraint layout. So make sure you have the latest version of layout added to your Gradle file. Maybe it is beta 2 or beta 3 or beta 4. Any of the three version works. Better, latest one is better. Also, motion layout in last December has decided, and the developers have decided that they will roll out a GUI, so it has made it very much easier. It is still in beta, so might be skeptical about using it in production, but yeah, it is good to get started and understand it. So we'll use GUI and see how it works because it is a good starter. First of all, integrate the latest library. Then open a small activity, start a new activity. There, by default, Android Studio opens up a constraint layout. So what you need to do is you need to convert this constraint layout into, or make sure it is motion layout. You can do it using GUI. Go to the design tab, go to the component tree and double click and convert it into motion layout. So when you do that, this IDE will all create a different file or scene file, okay, as Udhay told, wherein all the what we say animations, transitions, constraints that are stored, okay. And can you go to that file, Udhay?
Yeah.
The file that. Yeah. So what this file does is that it shows it is where all your animation state are. Okay. So for making an animation, you need to tell them what will be the start state, what will be the end state, and it will tell you have to define all your start state and end state here. Okay. Now one more thing, since it is again a part of a constraint layout, so you have to define constraints of your animation states. Okay. So what are animation state presented here are constraint state. The tag that you see at the bottom, the two tag start and end IDs that are called constraint set. Okay, here you defined exact state of your different views at that particular point. Okay, now coming to transition, this is where you define what are the state of animation. So in a transition, you have to define two things. One is the start state and the end state. Okay, so that is also done over, and the duration for how long you want to run the animation. So let's quickly jump into making a small animation. Okay, we'll just move the animation from top to bottom so that we understand some, understand what we say working of this motion layout.
Right. So the aim of the demo will be to move the image from the top of the screen to the bottom of the screen when the user is going to, depending on the user gesture, right? And so we'll be starting off.
So the start animation is what you define in your XML file that you created for the activity. That is the start animation. You don't have to do any kind of a different file. You don't have to create a different file. That will be a start animation by default. And whatever the constraints that you write inside your scene file will be overridden by. Okay, so whatever you write over there, whatever the constraint what you write over there will be always overridden. That will be final ones.
So I will take it here. So during the start of the animation, you want the image to be placed on top of the screen. So we are placing the constraints for that here. And for the end of the animation, you want to move the image to the bottom of the screen. So you place the constraints to the bottom of the screen.
Just click on the end transition that you see on the GUI,
Right.
and then set all the constraints. That will save that for only for the end transition. Okay. And if you want to see the how the transition is working, just click on that arrow that is coming from start to end, and then at the bottom UI there will be a play button. Click on it, and then you will see live how it is happening.
So once the constraints have been set, we have to create the transition which will combine both the constraint sets. So we can have the icon here for creating the transition. So let's name it as an image transition. And the start of the constraint set, we have placed the image on top of the UI, and for the end of the animation, we have placed the end constraint. So we are adding it here. So here the transition has been created, which will start the image at the top of the screen and ends at the bottom of the screen. So here you can see when I give on the play button, here you can give on the play button, you can see the image being moved from the start constraint to the end constraint. So these are the basic fundamentals for working of the motion layout. So I will just revise it once again for you guys. So what happens is we have a layout here. Oops. So we have a layout here. It's just nothing but the motion layout with one child, which is nothing, which is the image filter view. And once the layout has been, the motion layout contains a motion scene, the motion scene which represents the constraint set. So this here the start constraint set represents the image to be placed on top of the UI, top of the screen, and the end constraint requires the image to be placed on the bottom of the screen. And once both the constraints have been set, we can combine the constraints using the transition tag, where the start tag is start and the end tag both are mentioned, and the duration of the animation is also mentioned here. So this is the very basic working of the motion layout here. I hope you guys understand the basics. We will be moving on to the advanced motion layout code here thereafter.
So this dealt with only making going from one place to another place, but you can have more and more attributes. That is, if you want to intercept something, if you want to change, if you want to do something in midway, you can also use key attributes. That too you can add it using a GUI. So Uday, can you show a key attribute like alpha or something, width or something,
Okay. Okay.
and
So,
limitations to use custom attributes?
yeah, just a minute. So I will provide you the aim for going advanced with the motion layout here. So what happens is, until now you got a basic idea of how the motion layout works, what are the constraints it's available, and what is the transition in the motion layout. So in the next example, I'll be walking you through the usage of the constraint set, the transition, and also the key attributes. What are key attributes in motion layout, and how they can be used to change your attributes during the runtime of animation. So we'll be using the same XML file once again. We'll be using the same XML file. And here the aim of the flow, again, the example will be to change the, if there is an image filter view, we can change the saturation of the image from the start and the end of the animation. During the start of the animation, the saturation level will be 1, and as it moves down, the saturation level can be 0. So this is what we are going to demonstrate here. So how we can do that one is, so we can have this icon, key attribute icon here. So go to key attributes. So in key attributes, you have to first mention what ID of the UI are we wishing to change. Are we, so since in our layout we have only the image view, we have selected the image view. And the position. So position represents the percentage of the animation completion. So 0 represents the start of the animation and 100 represents the end of the animation. So we'll change it to 50, which represents at the middle of the animation. We can change the alpha value first. We'll try out with the alpha value first of all. Yes, get added it. So here, the custom attributes. So how the custom attributes works is every viewer comes up with a getter and a setter function for a particular field variable. So saturation is actually a field variable for the image filter class. So whatever we are asking the motion layout to go to this particular field variable and change its value from 0 to 1 during the time of animation. So we can, so that since it is not predefined with the Android view classes and it's written as a custom view, we have to write a custom attribute for that. So saturation in our class will be 1 initially. Okay. So So here you can see the key attribute which are just set for the image filter view. So what it's actually saying is at the frame position of 50, that is at the middle of the animation, you can have the scale X and the scale Y, which says the reduce the image X value and the Y value by 50%. That's a zero point 0.5 value. And once that one has been set, here we have another custom attribute which says is keep the saturation value of the image view at 1 during the start of the animation, and during the end of the animation make the saturation value to 0. So we are setting up three different attributes to the filter view here, that is the saturation value at 1 and 0 during the start and end of the animation. And we also have a scale attribute which changes the width and height of the image value, the image view during the frame of animation. So we are, after setting all these different key attributes, we are going to run the animation. So what happens is you can see the image starts at the start constraints we have already mentioned, but as it goes down, the saturation value first changes to 1 to 0. And also during the at the middle of the animation, you can see the scale changing from to 50%. That is, the width has been reduced by 50%, and the height is also reduced by 50%. So this is an example using the key attributes in motion layer, which I wanted to demonstrate here.
Uday, can you increase the font size a bit of the XML file?
Okay, is it visible? Is it visible?
In the ID. Yeah.
Yeah,
Yes.
this is yeah.
Yes. Yes. It is visible.
Okay. So here I will just go through it. Yeah, well, you go through it again. That was not visible. We have a custom attribute and saying the saturation value should be 0 during the end of the animation. And we have a saturation. We have another custom attribute saying the saturation value should be 1 at the start of the animation. Once a custom attribute has been set, so all you have to do is, since the transition has already been set, the UI respects this and then animates the view accordingly here. So the UI, the IDE do has some problems. You might have to refresh the IDE a couple of times not to get the UI working.
It is still in a beta phase, so there
Yeah.
is some issue with the GUI. You have to always close the XML file and open it. This must be some issues with the beta, but hope it must be fixed soon.
Right. So I hope you understand the basics of this working of the motion layout. So here I would like to go in detail with the theory of the motion layout. First, I will start out all the motion layout components in theory and how the motion layout works as an architecture here. So the very basic fundamental working of the motion layout is something called as linear solver. So what the linear solver does is at every particular point in time of animation, a linear solver will tell you how the value of a particular UI element or an attribute should change time of the uh, at this time of the animation. In our case, we had image filter view changing the saturation value from 0 to 1. So linear solver will tell the UI framework what is should be the saturation value of the UI at the 58th frame or the 75th frame. So that is the work of the linear solver. So linear solver is not directly exposed to us. It is covered up through a layer of called constraints models, which is nothing but the XML files we are just working on. And the advantage of using this kind of architecture is we have something called as optimizer in between the linear solver and the constraint model. Not all the equations need to go to the linear solver in order to get the final result. So they directly be bypassed and the results can be provided in much optimized way through the optimizer. So here the constraint models, which is exposed to us through the XML files, contains three different classes. As I told you that before, that we had a virtual layout, which is nothing but the flows and everything, decorators, and the helper, and the last one is the motion layout, which we're currently working on. So motion layout scene. So this is how the motion layout scene is. So here we have this XML file. So XML file has the views and helper classes, and every XML layout XML file will in turn refer the scene XML, which I just showed you there. So the scene XML has something called as constraint set. So every scene will have at least two constraint set mentioning how the UI should be placed during the start of the animation and how the UI will be changed after the end of the animation. So what the use of constraint set is, if you remember during the layout transitions, we were supposed to provide two different kinds of XML to the layout transmission for the fragment transition or the activity transition. So the Android framework will see the difference between both the different XMLs and try to find out which XML should be, how the UI should be animated to the end user. So instead of maintaining different kinds of XML to final the XML to display, we have considered a constraint set where all the different sets of UI rules and regulations will be placed on a single big file and encapsulated for better management. And so this was the example of how a constraint set will look like. So we have an ID for each constraint set, and each constraint in turn will have an ID referencing to which view the constraint actually apply to. It can't apply to the entire view, so it should say which UI or which view in the current UI should applicable to. So we have a start constraint and the end constraint in the demo here. And interpolated data. So if you remember the object animation framework, I told you how we have a linear interpolation which will calculate the value of the attributes at every point of time. So that's how the interpolated attributes does the same purpose here. So it calculates the positions and the dimension of the view at each and every point of the animation. It can change the visibility and the alpha through it at any point of the animation. It can also perform other operations such as the translations or rotating an image during the middle of the animation, scaling it, which you like just now did it, or in case of a card view, we can change the elevation of the view, and we can also, as we did with the saturation, if you remember, we can also add a custom attributes as long as it has the helper methods in the view Java class or class. We can add a custom attributes to the elements for animation. So we are going to add a custom attribute to the animation. What you have to do is first the UI, the Android Studio will ask you what data type is the attribute is of. Is it a string, a float, or a color attribute? Define the attribute and then tell the attribute name and what is the initial value for the attribute is. What is the value of the attributes? Once all the three fields are combined, the custom attribute can be added to the constraint set here. So we went through the constraint set flow. So right now in our case, we have two different constraint sets: the start animation constraint set and the end animation constraint set. In order to combine the both of these constraint set, we have the concept of transitions. So transitions is responsible for joining two different constraint sets and enabling the animation between them. So the transition will define how long the animation should take, what kind of animation should happen between the two constraint sets. So all the such kind of rules will be taken care by the transition layout, transition attributes. So here, this is how it looks like. So the start is nothing but the start attribute, and end is nothing but the end constraint set. And in between the transition, just join these two constraint sets. Here you can see the example. So what is happening is we are first defining the ID for the constraint. For the transition, we are saying for the start of the transition, use the start constraint. During the end of the transition, use the end constraint. And it also defines when the transition to happen. Should the transition should happen when the user is going to press on a button, or is going to happen on the swipe. So if you remember the collapsible toolbar in Android we have, it is not going to happen through the press of the button. The animation will happen as the user is going to gesture or interact with the screen continuously. So here we have an on-swipe listener. So in the on-swipe listener, we are saying which element should be tagged in this animation, and whether the should be animated should be on whether it's a drag down or a up or left movement or the right movement. So that will be defined in the transition tag. Once we have the transition tab, the final thing that is remaining will be the keyframe set. So keyframe set, if you remember, if you follow along all the examples we have been going through, right now the only two approaches are we have a start animation and the end animation. We did not have the power to say what can happen in between through the middle of the animation, right? So that can be filled up by using the keyframe set. So keyframe set, as I told you in the example, that it has values from 0 to 100, where 0 represents the start of the animation and 100 represents the end of the animation. So by introducing a key frame set into the transition, you can have an additional advantage of defining how the animation should behave at a particular time limit or a particular frame set of the animation. So in this example, we are defining in the middle of the animation, we have to change the percentage X and the percentage Y, that is the X position and the Y position of the image, by 50% during the end of the animation, during the middle of the animation. So that's a key position set. Yeah, that is an example of keyframe set. So keyframe set, if you see, keyframe set has three different kinds of available options we have. So first one is the key position. So key position is something you'll be basically working along all the time with the constraint layout. For the motion layout, if you most of the time we'll be using key position. The work of the key position is to change the path of the animation. So right now in our case, the animation has been going in a straight line, either from up to the bottom. So it's a very straight line it's following. But if you feel like you want the element to move towards the left or towards the right at a particular point of the animation, you use this key position. The key position, you first mention what frame position you want the animation to take place, and by what X value and Y value should the image move at this point of animation. That's the work of the key position. And key attributes. So key attributes are another important feature which we just went through in the demo process. So the key position tells you the X and Y coordinates of the image during the animation, but the key attributes lets you to animate any attribute during the run of the animation. So yeah, in this case, if you wanted to change the length and the width of the image during the animation means, so you just define a key attribute element, mention what ID it will be using, and at a particular frame position, all you have to do is mention the scale X value and the scale Y value, which in our case it's just nothing but the 0.5. It means just reduce the width of the image by 50% and the height of the image by 50% during the middle of the image, during the middle of the animation. So that's what the key attribute is for. So you can using the key attribute, you can change any attributes during the run of the animation. So these are the predefined and already available existing attributes which Android lets you use. So visibility, the alpha, the rotation, which you already went through the previous thing. If you want to use a custom attribute, we can go through the same process which I defined before. and key cycles. So, and the another problem which we were facing with the key position was key position was a linear interpolation. So the animation was happening linearly. So the time taken for to start the animation to the end of the animation has been evenly distributed for each and every part. But in most of the scenarios, we wanted a case where the animation should start slowly, really slow during the start, and should bump up in the middle, and then during the end of the animation, we want to get it back to the slow phase. So in that kind of say scenarios, we have something called a key cycle. So key cycle is a custom-made interpolator. Instead of using a linear interpolator, we have a custom-made interpolator which can be applied to a very specific view in the layout and can be used to change the interact with the motion layout animation. So we have the same set of attributes for the key cycle. We have the frame position, which says that what particular position of the animation the particular effect should take place, and the target, which targets what ID, what view should fall under this particular animation. We also have a wave period. So wave period is nothing but since it's not a linear interpolation, the cycle can be either a sine, a cos, or a tan wave. So in that kind of phase, what should be the wave period of the particular wave amplitude? It should be, and the value. So during the interpolation, we also have to mention what particular attribute we are trying to change during the animation. It can be rotation. So if you have seen the example going when through the animation, we can either rotate the image or a text flow or a sine wave. And the state. So it is a really complex subject. So here I'll be giving a very basic example I have. So in the keyframe set, instead of using the keyframe position which we did initially, we'll be having a key cycle. The key cycle is nothing but here we have the frame position at 0. We are targeting a button and then saying it use the sine wave to start the animation here. And we are doing it the same thing for the next position events of 50, 75, and 100. And if you follow the same exact steps, you will actually end up with an animation on the top right corner if you see that graph. So that graph it represents how the object is going to animate through the path of the animation as defined by the key cycle here. So that is all actually the basics of motion layout we have. And the next 10 minutes, actually, we wanted to provide you an example of how the motion layout can be used to change the complex animations which we initially used to do, like the coordinator layout, the expandable act bar. So here in our example, we want to show you how we can change. We can use the collapsible toolbar using the motion layout instead of using the coordinator layout. So Gaurav will show you a demo on that.
Yes. Udhay, can you switch off the screen sharing? I will share mine.
Yeah.
Okay, is my screen visible? Is my screen visible?
Not yet, not yet. Can you just retry?
Just click on the share screen on the leftmost corner.
It is visible now, right?
It's all black. Sure, you want to share this. Yeah, it's visible now. It's in a video camera.
Okay. Okay, so we're talking about the collapsible toolbar. So usually it is done using coordinate layout, but we replicated the same using motion layout. Okay, so here is the whole animation. There is a small recycler view. Just a sec, I will increase the. I'll just move to design screen. So here is the recycler view, a small image and a text. If you want to see how animation will work, I will just play the animation. You can see the whole thing is replicated using motion layout. Now the advantage here over is that we have, we are used to working with the constraint layout everywhere, and you can use the same thing in here now and replicate the same thing and add more complex UI to it as well. So I'll just quickly move to what are the animations screens used over here. Yeah. So before that. So parent layout is always motion layout, and then if you have seen, here is an image view with an ID to it. Then there is a text view at the bottom. It's a text view at the bottom and a recycler view below both of them, and some space. Okay. Now if I go to the scene layout, okay, so the start constraints that you see, the only constraint here you will see is the background, okay, which will be 0, alpha will be 0, and in the end constraint set, the image that we see, which is very big, will become small. We have altered the width and height, okay, and margin some of it, and you don't have to redefine all the components, all the constraint again, all the screens again. Just tell the constraint set what are the constraints that have been changed. That's it. Okay. Actually, it adds whatever is in by default to this and then animates it. But you just have to give the difference between states. Then when I move to it, and here you can see in demo of it. Just quickly run this into an emulator and show you. Okay, I have already running into an emulator. Yeah. So you can see this action here is swipe up, right? So in order to set the swipe up action, you have to again go to the scene and set your actions, this transitions action over here. So on swipe, okay, and in what ID, in what view should that on swipe should be listening to is the recycler view. So only in recycler view it will work. Before motion layout, what used to happen is that if you set an on swipe, you have to set it throughout the screen to detect in different views, and then you have to make some actions. Now you can have a targeted end to it also, and also you can tell them like what side of the view should be clicked first or should be dragged first, and what should be the direction of the drag. So it is drag up. So whenever you move your if you slide up, if you drag up, then only this animation will work in that direction, or else it will go to the down direction. Okay, so this is one way. Also you can if you want to see how on click works, so there's also one more animation that I want to show you with the drag down. That is this. So this is drag down, and I have rotated into minus y direction, so that you can see the whole view of it. Similarly, one more animation that I can see, that is now this time I have used on click over here, so it goes up. This might be the latest one. I will just run it. So this is here you can see I have added 3 transition screens. One is the fast. So if I run the fast, show you what happens. Okay. Yeah. So this is fast. It will just go to the top quickly in 1 second, and then the slow is it will slowly again come from there. Okay. So like 2 transitions, one from top to middle, and then middle to slow. Now this was the first when I was trying the animation, this was the first thing I knew. But then I quickly knew that I can use key attributes to do the same thing. In order to add a key attribute, just click on this icon, and then you have all the key positions, attributes, triggers, cycles, time cycles. And if you want to have a key attribute, just add any. If you want to change the alpha, if you want to change the images, alpha, just do this, add, and it comes from 0 again. So final value is 1. Okay. Also, one more use case of this is what I thought was a progress bar. Okay, we already have a progress bar, but if you want to make a custom one, so I just made a small animation of it. So if I click on this, it will just start from here, from 0 to 3 seconds. And when I click back on it, it will just come back to the end state to start state again. So this is one of the another implementation of using motion layout in day-to-day examples. There are tons of many examples. I tried it on the recycler view as well. So if I swipe up, it will go, and if I swipe down, it will come back. So it works on recycler view well. I didn't get much time to implement it in a good UI, but yeah, now it is working. I tried it like 2 months ago, but it was very unstable at that time. But yeah, it is working great with the beta 4 release. So summing up the whole thing, just before that, the only consideration using motion layout here will be that it is still in beta. So using it in production might not be the good time right now, but give it a try. Use some animations to it. There are many great animations like locomotion animation example given by in the DroidCon last year, which gives you all the basic idea of all the different key attributes and transitions that you can use with shadows as well. Also, one more thing before jumping into conclusion, that motion layouts, you can only apply it on its child views. You cannot apply it inside the child views, but there are key transitions, or there are callbacks that you can use, which can tell you what is happening in the animation, and you trigger something or trigger some function based upon the animation state. Udhay, would you like to sum up the motion layout once?
Hello, Udhay. You are on mute.
Ah, okay. So guys, I hope you guys understood the basic working of motion layout and how it can be implemented. So just to sum it up, I'll just say how it works and everything. So all you have to do is, first of all, take the constraint layout and change it into the motion layout. Just replace it the motion layout, and by default, the IDE will create a motion scene file for you. And the motion scene contains two important attributes. That is the uh, constraint set attribute and the transition attribute. Constraint set represents the position of the view at a particular time of the animation, and the transition represents how the UI is going to behave during the time of the animation. So these are the very basic concepts you need to understand to get started working with the motion layout. I hope you guys understood the concept, and I will be great. Too many examples, great examples out there. You can give it a try. So yeah, if you guys have any questions, just do drop it in so you can answer it right now.
Yeah, we have a few questions here. First question is by Shivesh. He asks that how to animate view from left to right using a condition to stop in the midway, and then after fulfilling the condition, move to the right end.
Okay. So here, so it's actually very simple. So here we follow the same approach which we are doing with the motion layout. So in the motion layout, you did have a constraint set, and you also had a start constraint set, end constraint set, and you also had a key position. If the decision you are taking, or if you just want to change the attribute, means you can use the key position or key attribute for it. But in your case, since you wanted to make a decision for it, you have to take the reference of the motion layout in the Kotlin file, take a reference of it, and add attach listener to it for the animation update listener, and it will provide you the listener called every time the frame, a keyframe has been updated. At the center of the animation, just take a check, and then after the check has been validated, you can either end the animation there or let it continue. So you might have to open the Kotlin and integrate it through the and add a animation listener to integrate your use case.
Great. Next question is by Sri Harsha Chikalapati. He asked how to chain multiple animations of different elements together.
You have to use the same thing. Constraint set will be there. So if you want to, first will be the start constraint set. Okay, so that will be the main that you defined in your activity. The end constraint set, just add where all the positions will be of the different views, and when you play, both will have it separately. Both will move separately. So the same thing, but with multiple views.
Multiple constraints. So every constraint set will be referencing on particular view in the element. So since you want to animate multiple views, just create multiple constraint sets for them, and then you can animate it through the transition.
Great. Third question is by the same person. How to define a custom attribute with a custom data type?
So can you be more specific about the custom data type, because most of the data types has been
For
defined.
example, yeah, for example, like, I'm not sure. Probably he's asking of a custom class or something.
No, class cannot be taken because so here the custom attributes you already have are the string, integer, and float, colors, and everything. So you have to make sure, since we are creating a custom view for that, you have to have this data types between the specified limits only. I think this will most probably be enough for the animation part. The
Got it.
strings, the integer, and float.
So
Yeah.
moving on to the next question. The next question is, suppose we have a collapsing toolbar, recycle view, and bottom navigation bar. So what happened to me that bottom navigation bar always overlap the recycle view?
That I don't think so. That will have to do anything with the motion layout. Motion layout again is a part of a constraint layout. So you have to define
Yeah.
constraints in a way that it would not overlap. But apart from that, you just have to make sure that on swipe is written on recycler view.
I
Nothing will.
I think defining proper constraint will solve it.
Yes.
Yeah. Okay. Thanks, Gaurav and Udhay. It was a great session and very informative one. So yeah, that's all the questions right now. Yeah, thanks for taking your time in joining us today, and thanks for the informative session.
Thank you, Yury sir. Thank you, Pawan sir.
Live streaming is on.
Yeah, Revuda, go ahead.
Hi everyone, welcome back to Android Stream Day. Now we have with us Amrit Sanjeev, and I don't think I need to introduce him. So yeah, he's gonna be talking about improving subscriptions. So if you're an Android app developer and if you have ever worked with subscriptions in your app, then you might know that it's a very tricky thing, right? So Amrit Sanjeev will help us today to understand it and improve it in our app. So yeah, over to you, Amrit.
Thanks, Raghu. Hi, everyone. Hope everybody is doing well and you're keeping yourself safe. In today's session, I want to kind of cover some of the things that we're doing with subscriptions that will enable you to kind of go ahead and build a product that can actually make a lot more money than it is doing otherwise. So this is not, like I said, this is going to be an quick run through the features that is already available in play. But during my analysis, I've seen that many developers are not sometimes aware of this or are not using some of these features well. So I'll start off assuming that people don't know much about this, and we'll go through each feature one by one and try and help you understand some of the use cases in which these could be used, and you can actually kind of improve subscriptions in your app. So I work at Google as a staff developer advocate. I work in a team called Partner DevRel, and we work with the large partners in order to help improve their implementation on the Google platform. So that's what I do in my day job. I've been active in the community for quite some time, and that's how some people who know me. And I've been recently hearing this, that people don't introduce me anymore. They say they know. I'm not sure if everybody knows me, but still, yeah, this is my day job. Apart from this, a lot of people know me for my work in the community, in the Android community. I was one of the guys who initiated the BLR Droid community in Bangalore. So a lot of people have met. A lot of us meet together on a regular basis before this COVID happened on a regular basis in order to discuss things about Android, have sessions and network. Let me quickly run through the agenda. I want to talk to the basics of play billing so that everybody's on the same page. A little bit about subscriptions versus one-time payment, and then how do you improve the subscription revenue? This is not going to be a business talk, but this is a technical one. But I'm going to touch more from a product perspective. So from a play billing perspective, if you look at it, you have this. There are three types of products. One is the one-time product, which most people are usually using right now, where people would buy something for a certain amount of price. They would either can make it a consumable product or it can be a non-consumable product. By what I mean by consumable product is something that will exhaust over a period of time based on usage. Say something like coins in games or virtual currency, things like that, where the user can buy that product, get an X amount of this product, and then as they use it, it gets consumed off. And when they turn out, when that becomes zero, there's no longer product available for you to use. A non-consumable product is like a one-time payment that you make for a premium version of an app. So you pay a couple of dollars or a couple of ₹100 and then get a lifetime license for it, where it's non-consumable. So no matter how much you use, this particular product is not getting removed from your usage. Now there is also rewarded products, which is basically when you watch an ad and get some data, get some credits, which could be consumable or non-consumable. It's considered to be an in-app product. Games often use this quite often to kind of enable re-engage the user. So they say, okay, watch an ad and then you get X amount of coins, or watch an ad and I get you this premium feature. Basically that drives ad revenue, and user also benefits by getting a certain amount of virtual currency. It's usually coupled with consumable sort of flow, where the user gets it for a certain amount of time, or the user gets it for a certain amount of usage. Now, subscription is there where it's a recurring flow that renews automatically until it is cancelled by the system or cancelled by the user. Now, there are changes that I have brought about in billing version 3. which is right now available. There are new ways to pay. There is offline payment, off-device payment that is supported right now. There are subscription promotion capabilities that are added. There is also purchase attribution in games, which is very important. And there is also improvement in reliability and security part of things. The important timelines that you got to think about is that at August 2nd next year, all new apps are supposed to actually migrate to billing library version 3. And from November onwards, all updates to your existing apps should also use this version. Yes, it feels like you have a lot of time, but this is also an area of real importance to an app. So there's a ton of testing that you will have to do in order to be confident in rolling this out. So the earlier you do it, the better, in my opinion. Now, when you do a valid purchase, this is the confusion that I see a lot of developers have. Basically, from the perspective that how do you actually secure your payment? Now, you actually get a purchase token. When somebody makes a payment, right, your app actually gets a purchase token from the Play Billing library. You really need to send it to your backend and maintain a copy of it at your backend. That way, you can check when the next time a payment token comes, you can check whether that payment token already exists in your backend. If it exists, that means that this is a fraudulent transaction where somebody is using sharing a payment token that is already used, and multiple users are trying to share something. You verify. You can actually do this verification in the backend, your backend. You can also verify with the Google endpoint if the purchase is legitimate. You can use that purchase token, call the Google Play endpoint, and then check whether that purchase has really happened or not. If the purchase is legitimate, then you got to give the entitlement to the user. Basically, unlock features for the user. In case of a subscription, you also have one more step that you need to check, which is the linked purchase token. If the linked purchase token is set, which means that this is like there was a particular the particular entitlement the user already had, and then they canceled it, and then they're resubscribing or re-enabling it, then you want to remove the linked token so that the previous token, so that there is no fraud that can happen based on that older token there in your system. Again, don't use order IDs to check for duplicate purchase. Order IDs are not unique always. Like in case of promotion codes, for example, order IDs are not even generated. So don't use order ID as a mechanism for checking your duplicates. This is another common mistake that we see developers doing. Now, voided purchases. So when a purchase is cancelled or it is charged back, or even a developer is actually giving a refund to the user, that's considered to be a void purchase, right? In that case, you need to take some actions around it. Just don't leave it like that. You can always claw back the unused items, which means if a purchase was cancelled by the user, they don't need to continue having access to the things that they purchase. So that is where you claw back the unused items. There is also this multiple strike policy that you can implement. These are recommendations basically, where if the user is actually doing this multiple times, you might want to temporarily disable access to the app, or temporarily disable purchases to it. And that way, if you see somebody doing this quite often to game the system, then you can actually take more drastic steps like temporarily disabling purchases on the device, on that app, in your app for that particular user, or disallowing the user entirely to access the app itself. These are drastic steps, but quite needed when things go out of hand and people misuse the system a lot. There is an API called as void purchases API, which you can use to initiate corrective action. Ensure that you're always within the API quota, because there is a quota for this. You can't keep calling it too many times. So when you want to decide the frequency in which you're going to do this sort of actions, you want to ensure that you take the API quota into consideration. The next thing is, let's talk about subscription. So one-time payment is not something that we're going to deal with a lot in this talk. I've talked to you about what are the differences between both so that you have a clear understanding. Now let's talk about subscriptions now. Subscriptions basically is becoming very popular among developers because there is a strong trend of recurring revenue that is coming. And generally, globally, subscription-based apps are actually getting more revenue for the users, revenue for the developers. And that trend has actually picked up a lot. If you see more and more people are getting used to the digital environment and using digital cash and paying for services online. And we see that more and more people are using subscription services, and from a place that we're seeing more and more people actually getting success on Play with the subscription service model rather than the single time payment model. But do keep in mind the regional preferences, and there are some strong regional preferences for certain places. I wouldn't say that it works for everywhere the same way. Do keep in mind what are the modes of payment that is supported, the prevalence of cash transaction within the region, and so there are sometimes very regional apps. There are apps that are only released to a particular demography of the audience. You really need to keep some of these things in mind before deciding whether subscription or in-app one-time purchase is a better option to do. Some people, depending on some of these factors, you might want to change the product decision and decide between the two options that is available. But having said that, subscriptions really give you a lot more options to work around and work with, and we'll talk about that in the subsequent slides here. Again, another indicator is the digitization level in the market. If more people are used to consuming digital products and paying for subscriptions, then it's much easier for your app to actually survive on a subscription model. In India, there is this general trend that people talk about a lot, where subscriptions is not working very well, sort of a thing. I think it is. It is not 100% accurate where subscriptions won't work in India. No, there are apps which have got a lot of success with subscriptions in our region also. So don't make this misconception don't go with this general idea and not even try subscription model for apps if you're targeting a new audience and things like that. Just take these factors that I talked about and more data after your analysis into consideration before taking that decision. Now, why should you control the churn? If you look at this chart, right, this is a very interesting chart that I found on the internet the other day, where if you have a small churn in customers and even a single digit churn in your customer base can have real lasting impact, because churn is very expensive for your business. It has a negative impact in the growth trajectory because more people are trying and then they're leaving the app, right? A high churn rate gets compounded over a period of time. Getting a user who churned coming back to it is a very expensive. The cost of acquisition is very high. So you really will, even if you're making a lot of money, because the acquisition costs are high, you're going to have a reduced revenue model. Basically the graph talks, the first nearly linear growth is about 1% churn. But the other two are more interesting. The second one, which is basically not the darkest green, the one in between, is only 2.5% of a user's churning. And with 5% churn compounded, it is literally that you're not helping your company grow. So controlling user churn and subscription churn is very, very, very important for the business to grow continuously. Now, a subscription churn can happen in two ways. One is a voluntary churn, where the user goes ahead and cancels the subscription. And another one is an involuntary churn. Involuntary churn is where the subscription payment method fails, like your credit card has expired, or the payment model is not passing the payment instrument is not passing the risk analysis, things like that. Those are areas where these two are there. There are two reasons, and you attack these two problems in slightly different ways. And I'll talk about some of the techniques that you can use in order to help your users or help your app retain your users. Now, when it comes to voluntary churn, user goes to Play Store and cancels it. There are a couple of the common reasons: are not happy with the app anymore. This did not meet my expectations, sort of situation. Does not need the service anymore. So they tried it, maybe used it for some time, and then they feel like, oh, this is a service I'm not going to use for a long period of time, so I will cancel it off. Or they find the price being too expensive. For when the recurring part of it comes about, right? Their usage reduced. Their next time the app got renewed, they realized that they are not really using it. So value proposition started like falling apart. So that is a couple of reasons why users go and cancel the subscription. When a subscription is canceled, the subscription will still continue, which means the entitlement that is access to the premium features that you've offered, will continue as long as the plan, for the length of the plan. Which means if I bought an annual subscription, say on January 1st, which runs all the way till December 31st, and I have cancelled my subscription, say sometime in between, say in August, I've cancelled my subscription. It doesn't mean that, the only thing it means that my subscription is not gonna get renewed automatically on December 31st. What it will basically do is I will still have access to my subscription, subscribe the premium features or the premium content that I have subscribed to for that entire period of time. So there will be two states. One is a subscription cancelled and the second one is subscription expired. In the case that I was explaining, subscription cancelled is when at August, your subscription is cancelled. That is, you continue to have your entitlement till the December 31st. On December 31st, that is when your entitlement actually cancels off, which means your access is actually getting revoked and the subscription is considered to be moving to an expired state. Just keep in mind, this is important to have a distinction of understanding of these two states, basically because some of the products actually take this into account while working. Now, subscription can be restarted when it's in the cancel state, and that is important because if a user has cancelled and they can come back to taking that subscription and continuing on, which basically means that the user is actually starting from, say, January 1st, in August I cancelled and I restarted in September. From on 31st, I'll get renewed again and I'll continue on, which means I've not lost the user in that case. When the subscription expired, then the user will be like a completely new user, has to go to the current SKUs that are available and will have to purchase the item again on the current price. Now, involuntary churn is when your payment methods fail. Google Play will automatically retry for 24 hours. That's a short period. It's only for 24 hours. It will retry the payment multiple times, and if it continues to fail, it also, like Google Play also automatically notifies the user to update the mode of payment because the failure has happened. And if the failure continues, the subscription is cancelled, and the cancellation is also informed to the user. Without account hold or grace period enabled, the subscription will get cancelled within the 24 hours time, and that is a really short period of time. You really want to kind of enable some of these features and make that give the system a little bit of, give the user and the system a little bit of time to kind of retry a few more times. So these two features can be used in order to kind of extend this up further, and I'll talk about them. Now, in order to understand user flow, right? So some of these changes that I talked about, okay, the user is actually subscribed, then he has unsubscribed, his entitlement is ending, so where the user is expiring. So in order to understand this, you can actually implement something called as real-time developer notification. This is a feature that's already available in Play. When you implement real-time notification, what it happens is whenever the state of your subscriber changes, that they have cancelled it or they have put there on hold or they have restarted their subscription or paused, you get a communication, a notification, which means a developer will be notified to an endpoint which is based on pub/sub model, and you can take a corrective action based on that information. So this is also very useful in order to understand when the user is actually churning. So when the user is actually canceling, you will get the option, and then based on that state, you can react correctly to the user. The message contains a purchase token, so that way you can query the Google Play API and understand and get more details around it. Now, in order to do this, you got to set Cloud pub/sub service on Google on the Google Cloud API console. That's how you receive the notifications from Google Play. Once you receive notification, it's up to you to take an appropriate action. It could be that you send a push notification, it could be that you send an email campaign, or you change some UI in your application, or change the SKUs for the user. There are endless options that you can do from your end to kind of ensure that the user is not canceling himself, or you retain the user. And this helps you recover some of the cancelled subscribers also. So here in the diagram I've talked about different ways in which you can use push notification. Some people use CRM and make a call to the user from their customer service relationship manager might give you a call, and there is a way of getting the user back onto the platform. It could be in-app messaging. It could be where you give a completely different SKU to the user, which with free trials or something like that, or some feature, some additional benefits like that. There are different ways of kind of winning back the user here. Now, in order to reduce involuntary churn, you can use grace period. Grace period is, like I mentioned earlier, when when your payment instrument fails, then Google will retry for say 24 hours, and the user is user is informed to fix the payment method. If the user doesn't fix the payment method within that period of time, the retries will continuously fail, and the user will be cancelled. Grace period allows you to extend this retry window to up to 30 days. Now, when I say it is only in increments, it's in 3 days, 7 days, 14 days, and 30 days. There are like 4 options available for you to do this. Grace period will allow the system to retry for a longer period of time. Now, if the payment works during this grace period, subscription is just restored and the user continues on. The thing to keep in mind here is that the user during this grace period continues to have access to your content or the features that you have enabled. It is not like the subscription is stopped. The subscription continues for this grace period. So the reason the decision of keeping the length of the grace period, the decision of what is the length for the grace period is something that you got to decide based on your business case. Now, some apps will give up to 30 days. There are certain apps which cannot do that, or from business reasons perspective, they will not be able to do that. So look at this and understand what is the timeline that you want to take. Because the user retains, the user does not have any real reason why they want to kind of like they don't lose any access or they don't lose any premium features. Now, grace period can be done at an SKU level. So if you have 5 SKUs or 5 different products in your app, you can have different grace periods for different things. You can have some of them with no grace period, some of them with 3 days grace period, some of them with 7, and some of them with 14, and other options there. The second one is account hold. Account hold will again is for extending Google Pay to keep trying for the app, trying to kind of get this sorry. Let me reiterate. That's basically for Google to keep trying to get the payment completed, and you can extend it up to 30 days before the subscription gets cancelled. But here, the account goes into this hold state where the user loses access until the payment is completed. This is like more like a suspended state. So user will become like a normal user or a non-premium user, and till the payment continues, the subscription is not subscription goes into the on hold state, but is not considered cancelled. So you still have an option to keep retrying in the background, and if the subscription continues, or if the subscription is if the payment is successful, the subscription continues from then on, and automatically this can be automatically the premium features can be enabled. But there are 2 differences. There's one thing that you have to keep in mind. This involves a little more developer effort. In case of grace period, it is basically just ticking a checkbox in Google Play Console. But in account hold, there is a little more developer effort, because you might want to show the user in this when your account goes into hold, right? You might want to inform your user accordingly, because suddenly the user will start seeing a different behavior from the app. Most users will get confused if you don't do anything, because they would assume that they are paying for the content and they are not receiving it, which leads to a bad user experience. So a lot of the apps which implement account hold also show in-app messaging, where the user comes in and they get to understand that there is a problem, and they need to fix it within the UI of the app itself, and they deep link into the payment page in Play Console. There are different ways in which you can actually help the user to solve the problem faster. So this, even though this sounds like a very easy, it sounds like the more right thing to do here, it also involves developer effort. So you can use it with grace period or without grace period. That you can decide how you want to use it also. Now, you also want to reduce the voluntary churn, right? This was all about involuntary churn, where the payment system fails and you want to kind of keep using some of these features. So these 2, account hold and grace period, are 2 things that you can use in order to manage that. Now, if you want to reduce voluntary churn, Basically, couple of things that you got to do before jumping into the product base itself. One is during the early days of your app, when the user is onboarding, really look at how closely on the user's activity. Make sure that your user is engaged with the app a lot, because during the early 30, like the first 30 days is when users have a more impulsive decision of unsubscribing, or they are more impulsive during that phase, so they might just unsubscribe really quickly. Keep the user engaged, make the user feel that the service is valuable, so make steps in order to actually ensure user feels that way. And also take action if you see that there is reducing activity over a period of time. Say the first few days the user used your app, if it's a, say, taking an example, something that is used on a daily basis, sort of an app like a, say, a newsreader app. If you see that initially for the first week the user was reading X amount of minutes a day, and then you suddenly see this over the next 2 weeks reducing continuously, then you want to kind of maybe coax the user by giving a push notification, or throwing up more content, more relevant features, and you want to kind of entice the user to kind of continue using the app and take into account, so that activity churn is something that you got to measure upfront. Keep your analytics, keep a close watch on the analytics. You also use a demography of, also use a cohort of users who are like your new users, and manage them really well. Because once the user has used your app for some time, they are more their impulse decisions actually reduce, and they are more forgiving of any error or technical glitch that comes in within the app. They might tolerate it a bit more. So you want to kind of keep this activity churn data close, and make decisions based on that. Now, before the user cancels, you can always offer a free tier to the user. There are, if the user hasn't engaged enough with your app or had issues with the app. So assume that you saw that a particular user is getting a lot of crashes, or they have raised a complaint in your CSR. You might want to use the deferred billing. There is a concept called as deferred billing in play, which will allow you to defer the billing for the user from 1 day to up to a year, and use that to provide some free access to content or features. And that way the user is delighted to continue using the app, but you still don't lose. You might still lose some revenue from the user, but you still don't lose the user entirely. There is a balance between losing some revenue, and sometimes losing some revenue is better than losing the entire user, because the cost of acquisition is much higher than that in such cases. There is also options to provide downgrade and upgrade of plans. The Play API has options to do this, so you should explore that option very clearly, because sometimes users go to a particular, when your app offers multiple tiers of service, users might just opt for the most cheapest one in certain cases, and then they realize that doesn't meet their needs, or that is not enough for them. That leads to dissatisfaction. That's where you need upgrade plans, option to upgrade the plan. Sometimes in certain cases users opt for the default, which most probably would be somewhere in the middle. They realize that they don't use most of the features that they purchased for. Instead of canceling, give them an option to downgrade to the next plan, the one below, where there are certain features which are removed, and you get a smaller revenue, but you still don't lose the user. So try and use the upgrade downgrade option to prompt it accordingly based on users' needs, and not let the user churn out completely. Account pause is another feature that you could use, which provides a user to option to pause the subscription. Make sure that when you pause a subscription, you also lose access to the premium content. So if it is if the subscription allowed you access to premium content, if you pause it, you stop getting the access to the premium content. Make sure users are aware of this fact. And you want to also share when a user is in the pause state. You also want to create a UI within your app, which basically takes into account the status, and bring up an UI that will enable the user to quickly reactivate. So when the user can continue to use the app, but it will also have the option to reactivate directly, rather than going to Play Console and do things, or go to their Play Store app, Play Store and do things. You can always help the user reactivate the subscription from within the app. But the app needs to be aware of the state, and you need to let the app show the UI based on this state. You have to integrate account hold for this and enable the feature in Play Console. That's how you would do it for account pause. This is at an account level. This will be applied to all the SKUs and cannot be done with just one SKU. Unlike say for grace period. Grace period is SKU level that I mentioned. This is at an account level. Pause does not apply to free trials or annual subscription. Remember that. So if you have majority of your users on annual subscription, then this is not a feature that will work very well for you, because the feature does not exist for annual subscriptions. But for anything shorter, it does work, and it does not apply to free trial. So the user cannot say that I have. So if you are giving a free trial for a month, the user pauses it on the 10th of the month, or after 10 days. It doesn't mean that when they restore, they will get that 20 days back. It does not work that way. It gets only paused at the end of the free trial. So they'll continue to get subscriptions. They'll continue to enjoy the free access throughout till the end of it, and then the account goes into the pause state. Once the user cancels a subscription, there are a few things that you want to do quickly. One is that there is a cancellation survey that is given to the user. So you want to look at that cancellation survey and identify the causes that most users are actually telling you. Surprisingly, many teams have told that they got very different opinions from what they thought were the cancellation reasons. And when they looked at the data on the console, for the Play Console for the cancellation reasons, they were surprised that they got some of these changes, and then they changed accordingly, and that fixes really worked well for them. Sometimes you can offer a discount through deferred billing, by which what I mean is if the user cancels a subscription completely, the next time they try to resubscribe, you want to kind of give a completely different SKU there, which maybe is giving a discount or maybe giving a free trial, which entices the user to come back and subscribe all over again. You want to communicate value. This is something that they do with the marketing angle of things. You communicate value of content or features that the user has not used. So for the majority of the users who have churned, if you look at your analytics, you'll understand the features that they were using. And then you will see that certain features were not used enough, and that might be the reason for the churn. Then you want to kind of use a marketing channel and share this additional information with them. Sometimes users might have never discovered that feature in your app, and when they discover, they find value. So you want to use that as a channel to kind of bring back more users back into your subscription. And once the subscription ended, there is also a resubscribe flow that you can actually enable for the user, and the real-time notification, real-time developer notification can obviously help you with some of these things. Now, lastly, there is promotion codes. This is basically one-time codes that you generate to give users access to content or access to premium features or free trials. It's very simple to use. Basically, you go to console and you select a time frame in which the code will be valid. You also say how many codes you need. It'll generate and share in a CSV manner. You can actually mail this to, you can always share this with users via mail or push notification or different channels by which you want to give it, and then use that to kind of engage the user more. You see basically things like predictions, prediction models like Firebase prediction, for example, which is again another Google product. Basically tells you who are the most likely people who are the most likely users who would churn, and this is automatically if you're using Firebase Analytics. If you enable this product, this sort of analysis done for free, and this shares the cohort for that. Maybe you want to send a push notification to all these people with a promo code. Again, this involves a little bit of programming or a little bit of effort, because promo codes are one-time individual codes. So to every user, you will have to send a different code. So push notification is not like a mass one-time push notification with one code. Everybody has to receive a unique code with which they can actually do this. So using a combination of the things that I talked here today, there is a lot of things that you can do in order to avoid churning of users and also holding back the users and enabling subscription to be a more successful channel for revenue for you here. Like I mentioned towards the start of it, this is not a way in which This is not a way in which you want to kind of uh, just put a few SKUs out there, make a nice UI, and leave it at it. You really want to use a combination of the tools and the products that are there in Play Console to enable you to manage the situation a lot better. Things like grace period. We have seen apps actually getting 50% improvement uh, in payment retry success just by enabling grace period for a longer period of time. Likewise, there are examples of each of these features working very well for different apps. And a combination of this would be what you need to really understand and put in your app to enable you to get more success with subscriptions in the real world. I hope this session was really useful for you guys. If there are questions, you can either tweet me at Sanjeev. Twitter, I'm quite active. Ask me questions there, and I will respond very quickly. Hopefully this was helpful. I know this was a lot of theory that I talked about, but I think having an understanding of this is very important for you to kind of get the revenue part of it done right. All of us developers love technology, but we also have to pay our bills. So making money is important in this case. Thank you, guys.
Yeah, thanks, Amrit, for this awesome session. And we have a question. That is, can subscription grace period be specified per user or group? Like allow for long persistent users who usually pay on time and not for others?
No, it's basically on the SKU level, not at a user level. So you can actually say that for a particular SKU, I can enable it for a longer period of time. But this is not generally, you cannot really predict who's going to be a user who needs the grace period. Basically, because things like your payment method failing could be something as simple and totally out of your control, like a credit card expiring and the user not noticing about it. The second thing could be that your bank on that day is having a maintenance window. That is always possible. So it is not something that you can really predict based on statistical information or heuristical information. So enabling grace period should be done for all your users. And this is not like if you really don't want users to enjoy your content during the grace period, then use account hold as the option to do it. And that gives you blocking of content. Maybe that is an incentive for users to go and update it more proactively. So that is an option that you can take depending on how your users are. But it has to be done. It can only be done at a SKU level.
Got it. So we don't have any questions, any more questions now. And
Cool.
so much. And earlier I didn't give you the introduction. Sorry for that. But
No, that's perfectly fine.
I
This is
would
joking.
like to note for the audience is that Sanjeev is not only the founder of Droid and Googler. He is one of the first, the first Android TV in India. And
This was a long time back. That was way back in 2014 or 13.
He is my inspiration in communities. So yeah.
Cool. If there are more questions that you guys come up with when you think through this problem and sleep over it, please feel free to tweet me and or send a DM there. I will definitely respond back to you guys.
Yeah. Thank you so much.
Thanks for the opportunity.
Yeah.
Thanks, Amrit. hi guys, I'm back with the quiz, and I hope all of you are excited for the quiz. Please let me know how many people are here and ready for the quiz. We'll start very soon because we have our next speaker aligned. So, yes, waiting for it. Please tell me as soon as possible that yes, you are ready for the quiz. Okay, and I'll be back in just 2 minutes. Please write yes if you are already ready for the quiz. Do that in the comments, live chat section, and we will start the quiz if we'll get sufficient audience. In the meantime, I'll make Nicola ready for his talk. So I just checked, he's joining. So yes, I can see a lot of yes. I'll be back in just 2 minutes. Okay guys, so I'm back with the quiz, and this is the link which I'm sharing in the chat. Please follow the link, and we will stop the quiz in next 8 minutes or 10 minutes. So 10 minutes you got. So please go ahead and start filling the answers for this particular quiz. It's already live now, and we have around 20 people here, so expecting at least 20 people responding to the quiz. So I think it's pretty much straightforward how to fill this. So go ahead, and you have a very short time to do that, so don't waste your time and just submit the quiz. Even if you feel confident or not, it's totally fine. I think everyone should participate because it's more about participation. It's more about learning and enjoying as well. So keep yourself ready for the next talk as well. Nicola, who is working as an Android engineer in Spotify, will be joining us, and so lucky to have him here. And I think there will be so much learning opportunity, especially when the speakers, like the last session, which was kind of many people ignore subscription, and it's kind of very useful, especially if you are an individual developer. You want your app to have this feature, some pro features where you can use subscriptions as well. So we have some more people joining. So the link is in the live chat. 20 people are here, so live chat, please check out the link for the quiz and start filling the quiz. Let me see how many people are here, and let me just check. I'm still waiting for responses. Can you please submit quickly? We have just 5 to 7 minutes for the quiz to be live. So okay, so we got one response. Okay, Any more guys are joining? Please, please join fast. We have our next speaker ready, and I want you to submit the quiz as soon as possible. And we have around 5 more minutes to go. So 5 more minutes, and yeah, quiz is actually mixed, so it's not related to basically like topic of the day. It is not dependent at all on that. It's totally a normal quiz which anyone can take. And next talk is very interesting. You might have been playing with GitHub Actions, so I'm sure you have been playing with GitHub Actions. And who better can tell you than an Android engineer that how to use GitHub Actions, and especially someone from the Spotify team. So pretty much excited for that. And the time is running fast. Please go ahead, and the quiz is on. We have only 4 more minutes to go. The quiz of day 1 topics. There is no, this is not again I'm saying this, that this is not related to day 1 topic anyhow. Anyone else joining, guys? We have received around only 3 responses so far, so please be fast and fill this form as quickly as possible, because we are going to disable the responses very quickly in next 5 minutes. So please submit the form as soon as possible. And I can see who has submitted it already. I can tell you that. Okay, Shri Harsha has already submitted. Ubaid Merchant has already submitted. Hitanshu Dhawan has already submitted. So these 3 people have submitted, and I'm waiting for more people to submit it quickly in next 3 to 4 minutes. Okay, where are you guys? Like, why you're not filling the questions fast? Let it be wrong, man. Like, you don't have to be concerned about if the questions will be wrong. It's totally fine if you fill the wrong answers. That's totally perfect. And I'm waiting for you to fill all of these so that we can move for the next interesting topic, which is on GitHub Actions by Nicola Corti from Spotify. And he's all set. So I think we have to now. So have you all filled the form? Okay, we got 1 more response. We have just 2 more minutes, and in next 2 minutes I'll close this form. So just 2 minutes to go, guys. And yes, we will be declaring who won the quiz. And thank you so much for supporting the stream. Press the like button right now if you like the Android stream day. Also share with your friends, subscribe to the channel if you are not the subscriber already. And if you want to support us, you can support us via live chat, super chat. You can become the member of the channel. You can also go to patreon.com/mtechviral and you can do the donations for the channel. Thanks for joining. And now I think in next 1 minute I'll end the quiz, and I have already got 5 responses. The next 2 responses are from Abhishek Tayal and Ayush. So these 2 people have also filled this form, and I think you already have got the result, by the way. So thanks for liking the video. I see many likes here, and many more submissions are coming. There is one more quiz which is left that we will do after two more sessions around maybe 6 o'clock or 7 o'clock. We will do the last quiz at that time, and then I have some updates which I'll definitely let you know after all the sessions. So go ahead. Okay, so the time is up and I am almost ending the quiz, and yeah, we are all waiting for Nicola's sessions and he's also waiting for us to finish. So I am ending it. We got 6 responses and Saurav Khandelwal was the last one, and now I'm gonna announce who's the winner. So I'm ending this now. Okay, so not accepting any responses. So 7 people participated and the last one was Shubham Retka, and most of them gave 9 correct answers, but the one person who has like answered all the questions correctly is Hitanshu Dhawan. So congratulations to you. And there was pretty basic questions, but I'll just let you know once what were the questions and what are the answers. When did Google announce Kotlin as a first class language for Android development? It's 2017. What happens if you click at least 7 times in the build number inside the settings? Then you get a developer options. You become a developer, not technically, but you get a developer option so that you can play with some settings which should be only which developer should be concerned about. What IDE was used before Android Studio? It was Eclipse. What can you use to handle asynchronous tasks? You can use coroutines out of these options, obviously. Then which layout can be used to vertically or horizontally align child? It's linear layout. Which method can you use to persist any change on shared preferences? There's a commit method which you can use. What views permit you to make a grid of items? And that's recycler view for sure out of these options. If you want to increase the white space between widgets, you will need to use the which property. So Android padding is one of the properties which you can use. Web browser available in Android is based on Chromium, Chrome, Opera, or open source WebKit. So it's Chromium. And what are the limitations of Mockito? It cannot mock final classes. So yeah, those were the answers. And yeah, they are pretty much excited for the next talk. And thanks all for joining for the quiz. And we have one more quiz that should be very good. Yeah, looking forward for Nicola to join quickly in next 1 minute. So yes, Nicola, go ahead.
Okay, so hi everyone. Thank you very much for joining this online talk. Today we're going to talk about Devops-ify your life with Github Actions. So mandatory slide about myself. My name is Nicola Corti. I work as Android infrastructure engineer at Spotify, and this means that I develop SDK tools libraries for Android engineers. And today I'm not going to talk about specifically from Spotify, but I will share a little bit of my experience in the open source world. This is my Twitter and GitHub handle. And just to sort one things out, if you're looking for the slides, they're actually already on my Twitter. I just tweeted like 2 minutes ago with the slides. So you can find them there and follow over during the presentations. And those at the bottom are my hobbies. So I'm happy to chat about those kind of things if you want to reach out. And I'm also really passionate about open source. So I'm gonna catch the opportunity of this talk to share some of the libraries where I'm like contributing. And I want to send out the invite for you to participate. If you're looking for some open source contributions, I'm more than happy to mentor other folks that wants to join this awesome world. But yeah, let's get started. So the talk that I'm going to deliver today, it's really going to be about continuous integration and continuous delivery. And in order to set to set expectations, I want to spend some minutes talking about continuous integration and continuous delivery as a process, just to make sure that we are all aligned on the same page. So what is continuous integration? Continuous integration is basically a process. It's like a conceptual process that I invite everyone to set up when you are developing software. So it all starts from how you versionate your software. So I assume you have like some kind of versioning system, being like Git, Mercurial, or other software. And you will have your snapshot of the current status of your code base. Let's call it the main branch. So at a certain point, you or someone else want to integrate a new change. A new change can either be like a bug fix, or it can be like a new feature because you're adding a new screen to your Android app. So there is this process that is called pull request, but can be called in any other way, change request, merge request. So there is the intention of someone to introduce new code within your code base. So here is where the continuous integration process actually starts. The first thing that it's part of the continuous integration process is to build. So you want to take this new change and build it within the code base to make sure that the code base is still compiling. So building is actually the first form of testing. You want to mutate your code base from a status that is compiling to another status that is still compiling. You don't want to break your code base. So the first thing we have to do is to build our code base with these new changes. Then it's up to tests. Tests can be a variety of different things. Unit test, integration test. And they're basically a mechanism to ensure the quality of your code. So you want to write tests to make sure that your code is bug-free. And then you probably have also some analyzer of the code, static analyzer, specifically tools that read through your code and try to spot potential bugs, like a variable that might be null and might crash your app in production. And this is a loop. Sometimes, most of the times, there is also a human step within this loop. So there is like the so-called code review process. So another human will check the code, will read it, and will say if the code is correct and can be integrated or not. Once all those steps are green, the code can be integrated and merged into your main branch. If one of these steps is failing, you want to run the loop again and again and again. So this loop can run multiple times. And the idea, what's the end goal of this? As I already said, the end goal is to ensure the quality of your code base. You want to make sure that the quality doesn't drop. So this is all about continuous integration. Let's move over to continuous delivery. Continuous delivery is about delivering new version of your software. So sending out to the public. Let's say that you have your main branch again, and then at a certain point in time, you pick what is called a candidate. So you say like, at this point in time, my code is so good that I could imagine delivering it outside to the public, creating a new version. So the first thing that you have to do is creating an artifact. An artifact, in the case of Android, is nothing more than an APK or an app bundle. So you want to basically consolidate your code base in a way that others can also consume it. If it's a Java library or a Kotlin library, that will mean that you have to create like a jar. If it's a node package, you need to create the node package for it to distribute. So you need to basically transform your code base in a way that others don't have to build it, and they can just use it and integrate it into their project, or use it as a customer, like download the app and use it. Then another round of tests. Those tests could either be the one that we saw before in the continuous integration, or they can even be more refined tests that are happening only in the continuous delivery. To give you an example about this, let's say you have an Android app, and whenever you release a new version of the Android app, you want to send your APK to an external vendor, like an external team of human tester, that will actually test your app to make sure that everything works correctly. This is something that you don't want to do for every integration because it will be extremely expensive and slow, but it's something that you're okay paying it and waiting for it when you want to release a new version of your app. And then deploy. So you want to make sure that your artifact reaches like a market somehow. Like if it's an Android app, maybe you have like the internal testing track. You want to send the alpha APK or the beta APK to some of your users to give them a first try on how the new app will look like. And then again and again. And this loop, again, will also run multiple times. For example, you might have one round of this loop for the alpha, then you have the alpha 1, the alpha 2, then you go to beta, and then you do, again, another loop. And then when you're done, like you say, like, hey, the quality is correct, everyone is fine with this, then you actually create a new release. You tag a new release. You say like, oh, this is version 2.0 of my app, of my library. Those two processes, they work together. They have slightly different focuses, but they are really similar in their nature. And to implement them, you could either do manually or sometimes use like an external tool, like a so-called CI/CD tool. And there are a huge variety of them out in the market. Let's mention like some of them, like Travis CI or Circle CI. They are really famous in the open source community. If you do like development on GitHub or other platform, you will find them. They're really used. There are other CI tools like Bitrise. They are more focused on mobile, like developing and releasing Android apps, or more enterprise solution like TeamCity, or even like, I think that the open source de facto CI/CD tool is Jenkins. Jenkins is an open source tool that you can download and install on your machine and will help you setting up your pipeline. And this contains a lot of plugins and integrations that you can install to customize your CI and CD loop as you want. But today, we're going to talk about Github Actions. So Github Actions is another CI/CD tool, but it's special in a way. And today we're going to see why is like a killer product, I think, from my point of view. So the first thing, why it's a killer product, because it's integrated inside GitHub. It's just there. Like it's a tab that is in the main page of your repo. You just click on Actions and you see your CI and CD loops that are running. Also, it's free for open source repositories, for public repositories. So I do a lot of open source. So this comes really handy for me. But really, if you're on GitHub, you will find it extremely convenient to set up GitHub Actions. And if you're not yet there, I really invite you to take a look, because I think the product is amazing. I mean, I'm not working for GitHub, but I have a lot of projects over there, and I really that really streamline my process a lot. So I really suggest you take a look. And if you have private repo on GitHub, you can actually run GitHub Actions on those up to 2,000 minutes per month. This is handy, for example, if you have like some side projects that you're not yet confident open sourcing, but you still want to run a CI for that. Maybe you have your Android app and you want to send it to the Play Store. You could do it privately. No one will see your code yet. Then I really invite you to open source it at a certain point. A couple of other features of GitHub Actions that are really crucial and extremely nice are the custom actions. So developers in the open source community, they can create building blocks to help you compose your GitHub action pipeline, and you can reuse them. So far, like on the marketplace, there are more than 4,000 actions, and they're growing every day. It's really easy to create a new one, and you will be amazed by how many there are there, also for Android, and you can use them as inspiration to build your own. Then another extremely cool feature is that you can run workers for every different platform. So you can have your code running on Linux, macOS, and Windows. And this is extremely handy if you're building like a command line tool or a library, or even an Android app, and you want to make sure that all of your coworkers, independently on which operating system they're using, they are able to build your app. And this is really handy because for some open source projects in the past, I was using 2 different CIs, one for Windows and another for Linux and Mac. And sometimes one of the 2 would break for, I don't know, reasons. So that was really inconvenient. While having everything in the same place is sort of handy and really a plus of this new tool. And finally, I will focus a lot of my examples afterwards on Android. Why? Because, I mean, I'm an Android engineer, but I think that this tool is really great for Android developers because the workers, they're really designed to work well with Android. For example, this is the Ubuntu latest, and it runs Ubuntu 18.04, and it has some packages already installed, but the beauty of it is that it has all the Android SDK already installed. So you have the build tools 30 and the SDK platform 30, and you don't have to deal with licenses that are not accepted. This was like the major source of pain for me for CIs. Like you try to run and then the CI fails because SDK build tools 30, you haven't accepted the license. Okay, I mean, I just need to build, So in this case, you already have everything on board and it works just great. So for Android apps, this is really perfect. Okay, so now to introduce the concept of Github Actions, I need to talk about some building blocks. The first one is workflows. So on Github Actions is all about workflows. What is a workflow? A workflow is basically a YAML file that you put inside your repo. You can have one, for example, one for building, or you can have more. You can have one for building, one for releasing, and one for doing the cleanup, whatever. So to understand the workflow, we need to introduce 2 other concepts. First one is the triggers. So triggers are events that are firing your workflows. Let's see some of them. For example, a new pull request is opened, or a commit is pushed to some branch, or a new comment is sent to an issue or a pull request. Or you can also have a scheduled trigger, like every day at noon, trigger a workflow. And to give some more concrete examples, for example, you can say that whenever there is a pull request, you want to run the build workflow. Or whenever you push to master, you actually want to run the build workflow. Or maybe you have another branch, like release, and you want to say that whenever you push to release, you want to run another workflow, the release workflow. Then you can have this comment trigger that triggers the cleanup workflow. So whenever I comment /close, it will close the issue, or it will lock the issue, and will help me automate stuff like management of my repo that I will have to do manually. And then the schedule workflow, like every midnight, just go through all my issues and close the old one, the stale one. So every workflow inside can run one or more jobs. So, for example, we can start with a single setup where every workflow has just one job and is running that from the beginning to the end. Or we can have a setup where there is one job and the output of that job is used to run 2 other jobs in parallel. For example, the release workflow will have a Gradle job that will create the release, and then we'll upload it to Bintray and to Sonatype separately. So it's up to us to decide if those jobs internally, they can all run in parallel, or they are sequentially, or they are mixed. Like in this case, I could say first run Gradle, and those 2 depend on Gradle. So they can run in parallel, but I have to wait for this one to be executed. So now I want to give a concrete example. So let's see how our workflow will look like. And this is going to be extremely easy. This is the workflow to build your app. So we create this YAML file and we start writing it. We give it a name. So the name of this workflow will be build. Then we need to define the triggers. So when this will be run. This will be run whenever there is a push on any branch, or whenever there is a pull request on any branch. So if you open any pull request against my repo, this will be executed. So these are trigger parts. Now let's go back to the jobs. Jobs. We define one first job and we call it Gradle. I usually call them Gradle because they do Gradle work inside, but you can call it build test, however you want. We define where it should run. This should run on Ubuntu latest. And then steps. So here we define the steps that this GitHub action workflow will have. There are actually 2 steps. The first one is checking out the repo. So you want to check out the code. And you just need to have the code inside the runner to do whatsoever. And this is generally the first step that every job will have. And then you want to build everything. And you call Gradle assemble. So let's take a closer look at those 2. So there is this name that is like description, but the important part is this key that is either uses or run. So let's start from this one, run. This is easier because it's just a bash command. So what I'm doing, I'm calling the Gradle wrapper and I'm calling assemble. And this will basically assemble my app, all the flavors, and we'll create APKs for everything. That's fine, pretty easy. This one is a little bit more complicated, but not much. So this key is uses. Uses means that it should use another GitHub action. So I'm not saying the bash command to execute here, but I'm saying like use someone else. In this case, I'm using actions/checkout. So if you go on github.com/actions/checkout, you will find a repository there that contains these GitHub actions. So this is like the user actions, and this is the checkout, the name of the repo. Actions is not actually a user, is an organization. So there you will find a lot of actions. And in this case, I'm also specifying the version, like at v2. So I'm saying like I want version 2 of this. This is something that I really encourage you to do because it will make sure that you still use version 2. If you don't add this, it will always use the latest master, and that could break. And then one last thing, actions. Like the fact that that we're using actions/something else, it means that we are using a first-party action. So this is basically from GitHub. And on this case, we are sure that this will work correctly because they pay a lot of attention on this. This is like maintained, bugs are fixed, it will be fine. Okay, so now I want to move over to some real-world examples, like open source library. You can go there, like on this repo, and see what they're actually doing, and investigate the action workflow and use them maybe as an inspiration. So the first one I will present is this one, App Intro. So App Intro is a library to help you build like the introduction for your Android app, like the carousel with slides that you see when you install the app the first time. And historically, we used to use Travis. Then we migrated to GitHub Actions. And let's see how our GitHub Action workflow looks like. It's pretty trivial. Like it's not that complicated. It just it's really similar to the workflow we saw before. So we have a checkout, we run KDLint, we run detect, and we run all the other tests afterwards. And again, there is just one job that is called Gradle. So what's the problem here? I mean, we actually, this was the original way. Now we improve the performance of this. And we thought like, you know what, KTLint, detect, and all the other tests, they can actually run in parallel. Because this KTLint maybe will take 1 minute, detect will take another minute, and run all the tests will take 2 minutes. And so the total will be 4 minutes. And it's like, yeah, okay, we can do better. So what you can actually do is have 3 separate jobs, like one that will run KTLint, one that will run detect, and one that will run tests. And this is also convenient in the way that now they can run in parallel. And if previously you had a failure with KTLint, the build will just fail. and will not run detect and the test. So maybe you fix KDLint, and then, oh, now also detect is broken. Annoying. Then you fix detect, and now the tests are broken. Yeah, even. So it's really annoying for our contributors. While this setup instead will show on the run, will show all the separate job and their status. So basically, we run the test even if KDLint is broken. Like they're completely independent. This is really a plus. Like if you do open source, think about the time to first feedback. Like how much slow your CI is. Like if your CI takes half an hour, your contributor will be super annoyed and they will just say like, oh, come on, it's like half an hour. And then I got like, I don't know, on empty, I missed like a new line at the bottom of the file. So this is just super annoying. So let's try to pay attention to your contributors and make sure that everything works smoothly and as fast as possible. Also here, you see on the right, we have these three, KDLint, detect, and test, but we have also another one, build debug APK. And so this build debug APK actually is another job and will allow you to have debug APK. So developers can actually download the sample app. So there is a sample app inside the repo that tries this library. And I mean, previously you would have to check out the repo and run the sample app on an emulator. It's annoying. Well, here we can offer this already. So let's see how the code for this job will look like. This is pretty trivial again. So you build the debug APK, you first check out the repo, then you build the debug APK with assemble debug, like you call the assemble debug Gradle task, and then you call this other action. This is again from Actions, so this is from GitHub. It's called upload artifact, and it wants two parameters, the name and the path. So in this case, we are calling it appintro simple app.apk, and we are telling him where to find it. Example bit outputs apk debug, example debug apk. So GitHub action will just check if the file is there and will upload it and add it to the report of the job. Okay, so now let's move over to something a little bit more complicated, but still really interesting to see. So detect. I don't know if you know detect, but if you do Kotlin development, you probably know it. So detect is a static analyzer for Kotlin. It's pretty famous. And historically, it used to use two CI system, both Travis and Appweier. And now we migrated over to GitHub Actions. And this is just way smoother and easier to maintain for us. So let's see how the workflow will look like. So we have a job, it's called Gradle. And here we see that there is a if. So the if is a key that can be used to define a condition that will skip the workflow. So in this case, we say that if it doesn't, so here it sounds like a bit complicated, but it's not. Like if not contains GitHub event head commit message, CI skip. So if the commit message doesn't contain CI skip, then you can run this job. What's the rationale behind this? The rationale is that you can commit and add CI skip to your commit message to say like, hey, don't run the CI. For example, if you're changing the README, or if you're changing the documentation, like super small change, you don't want the CI to run because the CI maybe will take 20 minutes and you need to like, it's worthless. It's pointless even, like you don't really want to run the CI in that case. So you can do that. And then here we have like a really another interesting feature of GitHub Actions. There are like build matrices. So with strategy and metrics, we define which is our build matrix. In this case, we want to run our library on Ubuntu, macOS, and Windows. And we want to try it on Java version 8, 11, and 14. So this matrix means that we will basically have all the possible combination of those two keys. So in total, there will be 9. So I will have like Ubuntu latest with 8, with 11, with 14, macOS with 8, 11, 14, and so on. And so how do I use this? I can use it like, I can use it like here, runs on. Instead of specifying Ubuntu latest, I can use the value metrics.os. So basically 9 jobs will be created, and for every job, metrics.os and metrics.jdk will have the value that is defined in these metrics. And so the other, so we saw metrics.os, metrics.jdk, for example, I can have an environment variable. I have an environment variable called JDK version because I need to use it inside my build, and I assign it the value that I have from the matrix. So we'll have matrix.jdk for that environment variable. And how the job will look like, that's pretty similar to the others. So again, I have a checkout repo that in this case, GitHub Actions offers me like a special action called setup Java. So I can call this actions/setup Java v1. I can specify the Java version. And in this case, this will be matrix.jdk. So I will have Java set it up in my worker are the correct version that I want, 8, 11, or 14. This is really convenient because then when developers open a pull request on our repo, they would see this. They would see like the primer checks, job Gradle run like 9 times, and Ubuntu latest 8, Ubuntu latest 11, and blah, blah, blah. So you will have all the various configuration of my build matrices. And it's really easy to say like, hey, you know what? The macOS build failed because those 3 are red, or it's not working on Java 14 because these, and these are red. So it's really helpful to test all the possible combinations. So now I want to give another example. And we saw a lot of examples related to continuous integration, while I want to shift a little bit on the continuous delivery. So how we can actually use GitHub Actions to deliver some of our product. In this case, how we can release an app to the Play Store. So again, we're going to create a new workflow. We're going to set the name to release to Play Store. And we're going to say that this will run on push to branches, and on the branches called release. And then we're going to, again, have a job called Gradle. And then inside, we're going to say what we do. The first one is actions checkout. So we're going to do the checkout. Then we're going to build a Gradle. In this case, we want to create an app bundle. So we're going to call Gradle bundle release. We're going to create a release APK, a release app bundle. And then there are 2 steps that we need to do before we can actually hit the Play Store. The first one is signing. So our app bundle needs to be signed. So we use, in this case, this external GitHub Actions called sign and release. And as you see now, this is not from Actions, it's from another user. And it has some parameters like release directory, or where is the key store password and the key password. And as you can see, you can use this other feature called secrets. So secrets is a feature of GitHub Action that allows you to share like secrets, like password, keys, GPG keys, whatsoever. And they will be available inside the build. So the worker can have access to those and can use them to sign your APK. And again, if you go on roadkill/sign Android release on GitHub, you will find the repo, and you can actually see what the GitHub action is doing over there. And then the next step is like, once you have everything signed, you actually need to upload it to the Play Store. And so to upload it to the Play Store, again, we use another action, and then we need to specify things like the package name or on which track, like you want to upload it to beta, internal track, alpha, or to production. And where is the release file? And this is really easy. It's like 40 lines of code to release to the Play Store. Like, you will be amazed of how short your workflows has to be, because it's really compact and it allows you really powerful things. So I really invite you to take a look. Now, so I've added this part because I noticed that there is a lot of confusion in the open source community related to caching. So how caching works on GitHub Actions. So I added this section recently, and I think it's worth, because caching is something that you can use to speed up your builds. And when you're working with Gradle, you have to download a lot of stuff. Like if you do Android, you probably have tons of dependencies, and your dependencies have other dependencies. So they all need to be downloaded. And you don't want to re-download them every time. You want to cache them. So to give you an example of how caching works on GitHub Actions, I will use this other open source library. It's called Chucker. Is on Chucker team/Chucker, and it's basically on the debug tool for Android, and is on a HTTP analyzer. So you can basically see the traffic of your HTTP instance on Android. So you have like a list view, like a recycle view with all the entries. And it's really handy because it's helpful for debugging to see what's going on. So here we use caching because we are really like keen to have a fast CI. So caching will look like this. Again, we have a job. This is a job for detect, but the interesting part is this one. So we have a step called cache Gradle folders. It uses actions cache v2. So again, we are using the one from GitHub. And then we need to provide some parameters. And this is the critical part. So first we need to say which path we are interested in caching. For Gradle, we're interested in these two. Like in the home of the worker, Gradle caches and .gradle wrapper. So we want to cache these two folders. And then we need to specify a key. So how we identify this blob of file that we're caching. In this case, here we use cache-gradle -hash file build.gradle. So these will compute the hash of build.gradle, and we will have like a hash over there. And then here we need to define also these restore keys. Okay, so this is maybe not obvious what is actually happening over here. So to fully understand this, I will actually complicate the workflow a little bit, and I have some real world examples. So let's take this other job. So this is the test job, and as a strategy. So in this case, we are testing Kotlin, 2 versions of Kotlin. So we're testing the latest released version is 1.3.72, and we are also running 1.4.m3. So on the third milestone on Kotlin 1.4, because we want to make sure that our library works fine on the latest version of Kotlin, but also on the upcoming version. So we will have 2 jobs, and we set an environment variable. And yeah, here's the caching. So let's zoom in and let's see how this is working. So again, cache Gradle folders uses actions cache v2. We want to cache these 2 folders. Now the cache key is a little bit more complicated. It's like cache-gradle -matrix.kotlin version. So it will be one of these 2 values. And then we're going to do the hash of build.gradle. Okay. Then inside the restore keys, we provide 2 restore keys. The first one, that is cache-gradle matrix version, and the second one that is just cache-gradle. So let's try to actually run. Like, let's see how a run of this workflow will populate this key. It will look something like this. Will be cache-gradle -1372 -dd. This is the hash of this file, build.gradle. And now maybe you're also wondering, why is he hashing build.gradle? Like, what's the point behind that? I mean, we will see. So let's assume that now inside the cache of GitHub Action, you have these 4 entries. So it means that in the past, there were run of GitHub Actions, and those run, they succeeded, and those 2 folders, they were stored in the GitHub Actions cache, and those are like the keys that were stored. So we run once for 1.3.72, and one for M3. And we have two different hashes, DDEA and FEB. So it means that basically between those two runs, the build.gradle file changed. Like I don't know, changed something, added a new dependency, I don't know, something changed over there. So they are different. What happens? Now we run our job. The first thing that we will do the repo. We will check out the repo. And then there will be this step. So this step will compute this key, that in this case is cache Gradle 1372 with the hash. We'll go inside the cache and we'll select, hey, I'm about to run this. Do you, by any chance, do you already have it? And GitHub Action would say like, yes, I already have it, because this same job with the same build.gradle with the same Kotlin version was run, I don't know, 1 hour ago. So I already stored those two folders. You don't need to re-download all the Gradle dependencies. I already have it. So just restore that folder, and you don't need to go like on JCenter or Muffin Central to download everything. It's just there, and that will save you a lot of time. Like, can save you 1 minute. That is a lot, or even more. It depends on how many dependencies you have. But yeah, this is really convenient. So we have this job, and this will just rerun and will be really fast. So what happens actually if I change the build.gradle file because I maybe add a new dependency? So I added a new library. So the hash will change. The hash now is 017. And so when I run my job, again, I do the checkout, the key is computed, Kotlin version is the same, 1372, and then the hash is different. And so the GitHub action doesn't have this stored. So it will use the restore keys. So now the restore keys are like a list of basically pattern that will be used to match the keys that are stored, the caches that are stored inside GitHub Actions. In this case, we have cache Gradle matrix version. This should be Kotlin version, sorry. That will be 1372 or 14M3, or we have just cache -Gradle. So in this case, GitHub Actions will say like, hey, I don't have this exact match, but I have something that is a partial match from your restore keys. So you have these two, 1372 run there with different hashes, DD or FE. Which one would you pick? So of these two, GitHub Action will pick the most recent. So the most recent will be one of these two will be restored, and then at the end of the job, a new entry will be added for this one. If you also run on a new version of Kotlin, because you have a new job and you run it on 140, that is not here and is also not here, then GitHub Action will use the last restore key. So we'll just say like, hey, I have cache-Gradle stored. Which one should I use? They all match the latest. So the latest stored cache will be restored, and then a new cache entry will be added at the end. This is how caching works on GitHub Action. I hope I clarified a bit. And if your job is slow, consider using it, because this will really speed up your workflow a lot. So that being said, now I want to take like some minutes, if I still have time. Guys, I think I have, but feel free to stop me if I'm going too long, because I have a repository, a sample repository, and I want to set up a GitHub action with you, like step by step, like live coding, sort of. So this is the repo. It's on GDG Pisa. That is one of my GDG that, by the way, I catch the opportunity to send greetings live. And this is the repo. It's called GitHub-Actions-sample. So you can actually go there and see what I do step by step. So this is really trivial. It's just like an empty Android app. I used one template to generate it. It's this Kotlin Android template. And it's an Hello World app. It's doing nothing. but we're going to use these to set up GitHub Actions. In the template, by the way, GitHub Actions is already set up. So for the sake of this example, I just removed it, and I will set it up now with you. So again, it's trivial. There is an app folder inside that contains the app project, and you can run check to run all the checks. It's a simple setup. Like really, there is nothing really weird. And how we set up a new action? Well, as I said before, there is a tab called Actions. So we just click here, and we see where we go. So here we arrive to the landing page, and GitHub welcomes us with get started with GitHub Action, and it also tries to identify language. It says like, oh, these are like the workflow made for your Kotlin repository suggested, but this is like sort of really stupid. So this is like they offer us a workflow to do echo hello world. It's not exactly what we need, so probably we need to customize it. But if you would have like, I don't know, Terraform configuration, or even like if GitHub Action recognizes that you have Rust or Ruby or, I don't know, Go project, it will actually offer you a more specified sample. The Kotlin one, unfortunately, is not there yet. I really hope they will add it soon. And in this landing page, by the way, there is also this thing at the bottom that I really invite you to take a look. Those are like management, repository management workflows. And they contain like sample actions that are not necessarily related to the building of your app. But for example, like you can send greetings. Like you can send a message whenever some people like open a pull request, or you can label automatically things based on the folder. Like this is related to core, this is related to UI, if it touches XML, whatever. And then stale action is actually really helpful to close issue and pull requests are old. So those are like, again, starting point that you can use to get inspiration. But in our case, we start from the first. So we get a simple workflow and we say, set up this workflow. We click here. So we're going to set up a build workflow. So we create a new file inside GitHub, .github workflows, and we call it build. And then here we're going to do it step by step. So we give it a name, we call it build. It's really commented out a lot, so this will help you if you need support on, like, you know, filling in your workflow. And then we go to the job section. So the trigger is just on push to branch master and on pull request to branch master. That's fine. But let's see what we actually do inside the job. So the job is called build. We'll run on Linux, and we'll have some steps. The first one is the checkout. And then there are two steps, like echo hello world and echo multiline. Okay, so we don't really need this. So the first one is like checking out the repo. That's fine. And the second one is running a one-line script. So we don't really want to do this. We want to, like, you know, like run all the checks. And what we do here, we call the Gradle wrapper. So Gradle. So one little note, this environment is sort of like, has some sort of auto-completion. So you see, like, it suggests you things. So if I write name, like, it will tell you, like, hey, this is the name to display on GitHub. So you can do, like, check out the repo. And then I can, actually create a new pull request. So set up the build. Create a new pull request. Yeah, I don't have much time to write much here, but like just setting up the build workflow. Okay, and click create. So now GitHub Actions sort of starts, and GitHub realizes, like, hey, this PR contains a workflow. So let's actually start running it. And you see that it appeared here. So I'm running build on pull request. And if you click on details, you will actually see that it's running. Like now it's doing the run all the checks step. So while this runs, let's go back and let's add another action. So another action here. So we reuse the sample one. I want to use. I want to give you an example of the action that use the comment. So I'm going to create the rebase, and I will actually use one that is already written by someone else. This one. So on this side, you have like the marketplace. So you can access all the other actions that are written by others, or you can go to documentation and have some like help on how to set up things. So this one is the one that I'm interested in, automatic rebase. I really invite you to take a look at the marketplace listing, because sometimes there are useful things. For example, here there is a GIF that explains how things should work. And yeah, there is also a sample. So I will actually just steal it and copy it completely, and I will put it, here. Just to walk you through quickly, this will run on issue command. Issue command is a misleading name, but it's basically running every time that a comment is added, either to a pull request or to an issue. So it's not only for issues, but also for pull requests. It's called automatic rebase. And we'll check out the code and we'll run this rebase 131. There is an external action. So let's create a new pull request. Base. Base workflow. So in this case, GitHub will not show anything here because I'm not adding anything that has a trigger on pull request. This has a trigger on issue comment. So we'll just not run, and I can just merge it. Okay. So this is still running. In the meanwhile, I want to show the last one. So the last workflow that I want to show is a little bit more focused on continuous deployment, continuous delivery. So this will be the release workflow, and will basically offer the APK. So how about the trigger? We want to run it when something push to, ideally here I would love to write release, but it's a bit annoying to create a new branch on the GitHub UI. So I will just say that whenever it goes to master, it will actually run. But I want to disable pull request. So whenever a new commit is pushed to master, this workflow will run. Again, there is a job called build, will run on Linux. We'll have some steps. The first one is to check out, then we need to build APK. So in the README, I added some information. So if you call assemble release, the APK will be available here. So let's do it. So if I do the build the release APK, and here I do like Gradle assemble release, then here I can use the upload artifact action. So if I go here and I select upload artifact, it's this one. By the way, you see that this is by actions and has this verified badge here because this is basically by GitHub. And so we are safe that we can use it. So we can just copy. So we just copy the code here and we go here. This is not well indented. Okay. So this will run upload the release APK. We call actions upload artifact 210. The name will be release APK, and the path is the one that I have here. Okay. So now I can create a new pull request. And then I think I'm running short on time. So okay. So let's go back to my 2 pull requests. Set up the build, finished. It's green now, I think. Yeah. This was green. It took 3 minutes, so I can just merge it. So this was the first one. So now let's go back to my release workflow, this one. So now since I merged the other, I can actually show you what happens if I write rebase here. So let's try it. So what is happening under the hood is that now a GitHub action for the issue comment trigger will be started. And this /rebase will fire. And then this takes some, generally 1 minute. But you will see that then at a certain point, GitHub action here will appear and will say, hey, I rebased your branch from this commit to this other commit. The reason is because, yeah, here we go. GitHub actions bot force push the release branch from this commit to this other commit. So they did the release, the rebase. Yeah, and it just works. So now I can just merge it. And if I go inside actions, and I see that I have 3 workflows, sorry. One is the build, and this is the one that was running before. Then I have the rebase. This is the rebase action, and then I have the release. So this one is the one that will produce the APK. So now it's running. I can actually go here and see what is doing is building a release APK, and then we'll upload it afterwards. So I think I'm super short. I have 1 minute left probably, but I have already example that was doing exactly the same thing. It's a private repo, but yeah, in the actions I have this one called prepare APK, and it at the end, like this took 5 minutes, but at the end there will be like an artifact here called release APK, and you can just download it or delete it. And it's really convenient because people can just like get your APK from there. Yeah, so now this guy will keep on running, and I will be back here because I think I'm off with the time.
Thanks,
So
Nicola.
yeah.
Awesome session, and it was very informative. So we have a lot of questions. We don't have time for all the questions, but I will pass on a few questions. So first one is that can we use instrumentation test with GitHub Actions?
Yeah, okay. So there are some custom actions that are running on emulator on the, I think the Mac or the Linux instance. I haven't really played with them. It's on my to-do list. So it seems doable. So you will have to look into that. But if you have like a lot of tests, I really recommend you go like on a cloud service like Firebase Test Lab or Genymotion Cloud, and you use them because yeah, you're like still sort of, I don't want to say abusing of the workflow, but you know, running an emulator inside a workflow, it's something like really intensive. So yeah, also for example, Firebase Test Lab offers you the possibility to see the video of your tests, while I don't think GitHub Action has any video. Like you can't really see what the emulator is doing. So I remember in the past I had scenarios where like, oh, the tests are failing because there is, I don't know, a Google Play service notification that is sticky, and my tests are clicking the notification instead of actually clicking the burger button. So yeah, those are like really painful to debug.
Yeah.
So yeah, I think if you have a small library and you have some espresso test or like a sample app, you can start with that. But then I really suggest you move to, like, if you have a big app, you definitely need to move to something more like enterprise.
Yeah, makes sense. So rest of the questions you can ask to Nicola directly in Twitter. He is active in Twitter. And yeah, thanks for
Yeah.
taking time and joining here. We really appreciate that. And our next speaker is already online, and we'll take up.
Yeah, thanks, Nicola.
It was a pleasure.
Uh,
Thank you very much for having me.
awesome talk, and I think a lot of people are gonna reach you because
Nice.
there might be so many doubts.
Yeah, more than happy
There are
to
a lot
to
of questions,
support really.
and we don't have time, so we skip
Yeah,
those.
so we will move ahead, and we will welcome our next speaker, Monika, and Monika will be talking about unit testing. So pretty excited for that. No, Monica, all set?
Yeah,
Can we start?
yeah.
Okay, sure.
So
So,
we
guys, we'll
like
be starting. Yes, Monica, you can share your screen.
Hi everyone, I'm Monica, and today I'll be speaking about unit testing made easy with MockK. I welcome you all to this session.
Monica, can
So
you
before,
enable your camera if
yeah,
that
just
works?
a moment. So
go to
Maybe
the
you don't have to use
go
it.
to the Jitsi, and you have to. So whenever you no, not settings. It's yeah, here enable the camera.
yeah, it's already enabled.
Share the screen and then enable the camera. Whenever you share the screen, camera is
Okay.
visible by default.
Yeah.
Just a minute.
I think you have already enabled. So you just have to go. Yeah. And press the camera button on the bottom right. Like not bottom right, in the center bottom. Yes. Yeah, all good. Yeah, go ahead.
Okay.
Thank you.
So before we start on the session, I want to tell a bit about myself. So I'm Monica. I'm an Android engineer. Currently, I work at Walmart IDC, which is also known as Walmart Labs, and I have over 6 years of experience in mobile application development. I'm a regular Android and Kotlin speaker. I read code, write code, and speak about code. And last but not the least, I share my birthday with Java, and my Twitter handle is at Monica underscore Jethani. So after the session, you can reach out to me there for any queries. So we'll have a look at the agenda of the session. So first, we'll go through the limitations of Mockito, and then I'll cover MockK in depth, and then I'll give a glimpse of code coverage with MockK. So moving on to the limitations of Mockito. So most of us who have been working in Android have worked quite a lot of time with Java. And while working with Java, Mockito has been our favorite mocking framework. But as we transition to Kotlin, we notice that there are some of the limitations in Mockito. First one, that Mockito was not, it was built for Java, but it was not a good fit for Kotlin, in the sense that it cannot mock Kotlin final classes. Like every class in Kotlin is a final class, and we were not able to mock classes or spy classes with Mockito. It was not possible with Mockito core, and there were certain solutions which were proposed, like making our classes as open or using interfaces, which were not recommended. And then there was a solution brought in for using incubating feature of Mockito, which is having a certain Mockito extensions file in your resources folder, and it needs to contain a mock maker class, and that worked. And with that, we were able to mock Kotlin final classes. And in the meantime, there was also Mockito for Kotlin, which came up, which is a Kotlin wrapper on Mockito. And even with that, we were with the first version we weren't able to mock final classes, but with the second version we were able to mock the final classes. So basically, when you use Mockito with Kotlin, you need to have a setup. And one other limitation of Mockito is that because it's not built for Kotlin, there are certain Kotlin components, like, for example, objects, which you cannot mock by default with Mockito. You need to write some boilerplate code. Like if you have objects, you cannot mock them directly with Mockito. You need to improve your code. You need to change your code design, and then you will be able to mock it. And third limitation of Mockito is that it does not support mocking of private and static functions. So to overcome that, Power Mock is used in conjunction with Mockito, but Power Mock is well known for its reduced code coverage. So these are some of the limitations of Mockito which were considered, and then came a new library, new mocking framework, which is known as MockK. As evident from its name, MockK is a mocking framework developed specifically for Kotlin, and so you can see the second K stands for Kotlin. And it provides a first class support for Kotlin features, and there's no setup or boilerplate code required except for adding the dependency. And unlike Mockito, which uses subclassing for mocking, MockK builds proxies for mocked classes, and it has a DSL style syntax which gives it a Kotlinish look. So you can get started with MockK by including the MockK dependency. The latest version is 1.10. And with MockK as well, we follow the same principle of testing, that is arrange, act, and assert, the 3A principle of testing, wherein first we arrange what we require to do the test, then we make the method call, and then we assert and check whether the actual result matches our expectations. So consider you have a MVVM structure in your project, wherein the view model calls a repository and repository calls a database for getting the data. So if you are testing your view model, you need to test your view model only. You should not be testing your repository and other external classes. So in that case, you need to mock the dependencies which your view model has. In this case, like the repository class. So if you have the repository class like the one listed on the screen, you can mock it using MockK using the following. Like you can mock it using MockK keyword, or you can use MockK annotation. And when you use annotation, you need to use MockK annotation initialization method, which you need to call in setup. So this is similar to the Mockito annotation.init mocks method, which you use for initializing your mocks when you use it with Mockito. So let us consider a second example. So if you have a class which you want to test and it has a dependency, so when you write your test class for your class under test, you should be testing only your class under test and not your dependency class. So in that case, you need to mock your dependency class. And with MockK, this can be achieved in this way. So first you create a mock of your dependency class, and on your mock you mock a particular method. So that is achieved in MockK using every construct. You specify the method you want to mock, and you specify the mocked result to be returned with the returns keyword. And then you create an instance of class under test with the mock, and you do a call, and then you verify whether on the particular mock a method has been called or not using the verify construct. So verify is used to verify whether the verify is actually used to verify all the calls on your mock. And then you can perform your assertions and use confirm verified. So with confirm verified, you pass in a mock, and it verifies, it checks that all calls on your mock have been verified using the verify construct. So with every, you basically arrange and mock the method, and you specify the result, then you do a call, and then you verify using verify construct and confirm verified. So the purpose of confirm verified is to ensure like none of the method calls are missed in verify construct. So moving further, let us consider another example. So here we have a class data service, and it has two methods: get data from database, which returns a string, and another method for doing some operation, which again returns a string. So when we have to mock the data service, we again mock it using the mock keyword, MockK keyword, and then we mock a particular method which is get data from database. We use an expected parameter, and we also specify the mock result for the method call. Then we make the method call in the act step, and then we assert we verify the result, and we also verify the method call has been done on the mock using verified construct. So moving further to MockK annotations. So here you can see we have a class inject test service, and it has two instances of data service. And in MockK, we can even use the annotations just like we have in Mockito. So for data service instances, we use MockK at MockK, and because these are injected into the inject test service, we use at inject mocks for the inject test service. And then like as those who have been working with Mockito might be knowing this, whenever you use annotations, you need to have a initialization method in your setup. So same here with MockK as well. So moving further to spy with MockK. So spy is your actual object, but it's like you want to mock certain methods, but not all the methods. So spy can be achieved with MockK using spy-k. You use spy-k and the class name, and then you mock a method using every. So your mocked method will return the mocked result, but the methods which have not been mocked, they will return the actual result. So here you can see that first time I mock a method and I get the result, the mocked result in first result. And the second time I make a call to a non-mocked method. So when I make a call to a non-mocked method, it returns me the actual result. Now moving further to relaxed mocking with MockK. So all mocks are by default strict. Like if you make a call to a method on a mock which has not been mocked, you will get a IO mock exception. So to avoid that, we can perform relaxed mocking with MockK, and that is achieved using add relaxed MockK annotation, or you can use relaxed equal to true when you declare a mock with MockK keyword. So here you can see I have created a mock using MockK keyword, and I have used relaxed equal to true. So on this data service mock, I have not mocked any method call. There is no every construct here. So the moment I do method call service.getData from DB with a particular parameter, it gives me a result. So in this case, when you do a relaxed mock, the method returns the default value of the return type. So I have not mocked get data from DB. So I have used a relaxed parameter here. So when I do a call, it will return default value of string, because the return type of get data from DB is a string. So in this case, the result will be an empty string. So moving further to relaxing unit functions. So you can relax unit functions by using relax unit fun equal to true. You can, when you want to relax it for a particular mock, you put it in put it in the curly in the round brackets for a particular annotation. And if you want to relax unit function for all the mocks in your test class, you put it in the initialization function. So you can see here in the code snippet that when I'm putting relax unit fun equal to true, I'm putting that for data service instance only. And when I want to relax unit functions on all the mocks in a particular class, then I pass it to the initialization method. Now moving further to mocking objects. So object is one of the Kotlin construct which maps to Java statics. So it can be mocked in MockK using MockK object. So you can see there is an object which has a particular method get data from DB. So to mock it using MockK, I use MockK object and pass the object name. And then so your mock object will basically behave like a spy. So whenever you have a method on which you mock a result and you call the method, you get the mocked result. And for those methods wherein you haven't mocked the method result, you get the actual result. So here you can see when you mock the object using MockK object. After that, when you make a call on a not mocked method, you get a result, and that is the actual or the real result. And when you mock it using the every construct and then you make a call, you get a mocked result, and then you can go ahead and verify or do your assertions there. So one more thing which I would like to point out here is you can notice the mocking to get data from DB. It takes as parameter any. So any is a way to achieve your argument matching. It was there in Mockito as well, and it's there in MockK as well. So moving further, here I would like to do a comparison between Mockito and MockK when mocking Kotlin objects. So I showed you this object here in Kotlin. So when you want to mock it using Mockito, you cannot directly mock it. So the way you can mock it using Mockito is you declare an interface with the same method, and your object should implement that interface, and it should override that method. And then you can mock the interface, and you can mock call to the interface method. So this is how it is achieved using Mockito. It cannot be directly achieved, but you will need to make some changes to your code, and then you can achieve it using Mockito. Unmocking objects. So unmocking objects can be achieved using unmock all or unmock object. So with this, you actually revert your mocked object to its regular state. Now moving further to mocking enums. So here you can see we have an enum which is Mars API status, and it has 3 states: loading, error, and done. So you can mock enums in the same way as you mock objects. You can use MockK object and mock the enum state, like here Mars API status dot error or dot loading or dot done. And similarly, if you have an enum for pizza sizes, say small, medium, large, you can mock it in the same way using MockK object, pizza sizes dot small or dot medium or dot large. Now moving on to capturing parameters. So this can be achieved in MockK using capturing slot or mutable list. So you use capture slot when you want to capture the value of argument passed to a method, and you use mutable list when you want to capture and store all argument values which were passed for all method invocations. So let us have a look at the code snippet for capture slot. So here you can see I have created a mock of data service, and I have created a slot of type string. Reason being, because get data from DB, it takes the string argument. So hence the slot is created of type string, and then you mock call to service method get data from DB, and then you even capture it, and you mock it, and basically you make the method call, and then you can get the argument which was passed in using slot.capture. That is you get the you basically capture all the arguments in method calls in your slot, and then you can retrieve them, and you can compare it with the expected values using slot.captured. And now moving on to mutable list. So here you can see like mock is created for a data service, and then a mutable list is created again of type string, because the argument type is of type string. And then you mock a call, and even you want to capture it in your mutable list. And then when you make calls with different parameters, you can retrieve the calls, you can retrieve the arguments which were passed in those calls to your list. So when you do list.size, you get 2, and this will give you the parameters which were passed. Like first, I passed expected param 1, and second, I passed expected param 2. So through your list, you can get those values, the parameter values which were passed. Now moving further to mocking constructor with MockK. So you can mock constructor with MockK using MockK constructor, and then you pass the class name. And so this way, whenever you create an object, the object created in this way will be a constructed mock. So you can refer to that using any constructed keyword. So you can see when I mock the method, I'm saying that for any constructed means every object of data service, when a call is made to a method get data from db with parameter, then return a mock result. And then you can do a method call with the parameter, and you can even verify that on that particular data service instance has the call been made using the particular parameter. So moving further to argument matching. So you can, in your mock calls and in your verify calls, you can pass your regular arguments, or you can pass argument matchers like EQ, which stands for equals, or any, which stands for any argument. And this is similar to Mockito. Even Mockito had this, and even Mockito had this functionality of capturing and replaying arguments using argument capture. And moving further to mocking and verifying chaining calls. So here you can see I have a mock object of a class known as car, and I have basically mocked the method by writing in a fluent style. So fluent style means like if you have a instance of a particular class, say A, and you can write it, you can write your method calls in a way like a.method1.method2. So here we are mocking the chained calls, or you can say fluent calls. So for every call to car.door.window state, the particular mock result should be returned, and then we do a method call, and then we verify. So we can verify the entire chained call as well. So this was supported in Mockito as well. Moving further to mocking the hierarchy. So here you can see that there is an interface address book which has contact, and contact is again an interface which has name, telephone, and address. And address is again an interface which contains city and zip. And when you want to mock address book, mock of address book will be a mock of mocks. There'll be nested mocking here, because when you mock address book, you are mocking contact, and when you mock contact, you will have a mock of address. So here you can see that there is a mock of address book, and it contains a mock of contacts. So there are 2 mock of contacts, and then in the first mock for contact, you can see that address is mocked parameter wise. It is mocked property wise, like address.city and address.zip. And in the second mock, you can see that address is a mock in itself. So nested mocking can be achieved both the ways, either by mocking the properties or by having a nested mock. So now we move on to verification to a number of times. So we can verify the calls for at most, or exactly number of times. So like first line, you can see verify at least 2. So here we are verifying whether the call has occurred at least twice, like that is 2 times or more than 2 times. Then we are verifying at most 2, and then we are verifying exactly once. And these were present in Mockito also. You can use times there, and you can specify the number of times. And there was one more interesting construct in Mockito, which was verify no more interactions. That is, you don't have any interactions with a particular method, that is method call hasn't taken place. So that can be achieved in MockK using verify exactly 0. So that states that there has been exactly 0 call to a particular method. So now moving forward to verification order. So verify all specifies that all calls have happened without actually checking the order. Verify sequence specifies that calls happened in a specified sequence. Verify order specifies that calls happened in a specific order, and was not called specifies that mock or list of mocks were never called. So here I would like to point out the difference between verify sequence and verify order. So in verify sequence, the calls need to be in a specific sequence. In verify order, you can skip some of the calls. So in this example, you can see like there is a spy of data service, and there have been the method mocking has been done, and then there have been three calls. First to get data from database, second to do some operation with parameter param, and second do some operation with parameter param2. So when I'm verifying all, I'm verifying whether all calls have taken place. So you verify all will verify that calls have taken place regardless of order. So you can interchange the sequence in your verify all construct. In verify sequence, the sequence needs to be exactly the same the way they have been called. And in verify order, you can have your calls. They need not be in the same sequence. Like you can skip one of the calls. Like here, I have three calls, so I can skip first or second or third. Still, my tests will pass. But I cannot do the same thing with sequence. Sequence needs to have all the calls in that particular sequence in which they were called. Moving further to verification confirmation. So that is done to ensure that all calls were verified using the MockK verify construct. So it is achieved using confirm verified. So here you can see that a mock has been created for data service, and the method get data from database has been mocked, and the particular mocked result has been specified, and then the call has been done, and verify construct verifies that the call has taken place with a particular param, and then you can perform your assertions, and you can even do confirm verified on the mock. So when you do confirm verified on service mock or on data service mock, it will check whether whatever calls you have done in your test method have been verified using verify construct or not. So if there are certain calls which have been made but not verified using verify construct, then it will throw an exception. So to exclude less significant calls, you can use exclude records, and you can pass in your mock object and the call with the arguments. Moving further to mocking functions which return unit. So here you can see I have a class which has a method sum which returns unit, and to mock it I use the same every construct, but in place of returns I use just runs or returns unit because the function returns unit, or I can also use answers unit. So I'll be talking about answers later in this talk, but it's similar to returns. Moving further, mocking extension functions. So extension functions is one of the best features of Kotlin, and whenever we talk about testing for Kotlin, we need to have a framework which enables us to mock the extension functions. So MockK is one such framework. Here you can see I have a test object and I have an extension function to it, and I can mock it using MockK, and I can mock the method call to an extension function and specify the mock result. And the verification part is same as verification with MockK. So one thing which I wanted to point out here is mocking of extension functions was not supported in Mockito, but it is supported in MockK. Now moving on to mocking top level functions. So suppose you have a file code.kt and it has a function lowercase. So if you want to mock it, you can mock it using MockK using MockK static, and you need to pass the package name of the file, and then you can mock the method using every construct. You specify the method with the parameter and mock result. Moving further to using answers. So answers is similar to returns. It is used in conjunction with every. So here you can see every call to our method, you return something. You return something, but you can use answers, and with basically answers is meant for when you want to return a lambda or when you want to return a complex result. So answers expects a lambda. So here you are returning the same result, but because it's with answers, you return it with a lambda. And moving on to MockK statics. So if you have Java classes in your code and they have static methods and you want to mock them, you can mock them using MockK static. You pass the class name and then you can mock the method, the static method, using every construct and specify the mocked result. Then you can verify the call to mocked method. Now moving on to mocking private functions. So here you can see in the class, in the test class, I have a private function method too, and I want to mock it. So mocking private functions with MockK is done via dynamic calls. So first I've created a spy, and then for every call to method 2, I return a mock result. So here you can notice in the every lambda I have my mock and I have my method name within square brackets. So one thing which I would like to point out here is the method name needs to be exactly same as your private method name. If it's different, you'll get an IO mock exception. And then you can verify your call in the verify sequence. So again, you use the mock and your method name within square brackets. Also, I have used record private calls equal to true, because by default private calls are not recorded. So if you want your private calls to be verified in your verify construct, you need to use record private calls equal to true. Moving further to mocking varax. So here you can see I have an interface with a method which takes varax type of argument. So this can be mocked with MockK with the MockK keyword, and then for every call to mock method you return a result. Now you can note that when you do a method call in your every, then you can specify the different permutation of arguments. Like you can specify like 1 2 3 or 1 2 3 4, or you can specify one starting with 1 and then any length of variable length arguments and ending in 4, or starting in 1 and then variable length arguments, integer variable length arguments which are less than 5, or starting with 1 then 2 and then variable arguments which are greater than 5 and ending in 9, and then you can specify the mocked result. Moving further to mocking coroutines. So you can mock coroutines with MockK using the same every, verify and answers constructs, but here you need to use co-every, co-verify, co-answers. So you need to have the test dependency, and you can see here in the snippet. So I'm mocking the method call to a suspend method in co-every, and I'm returning the mocked result in co-answers. So as I told you, answers is meant for some complex mocked result or a lambda. So here you can see we have a result returned from in the form of a lambda. So when you are mocking your calls, you can also make sure that calls happen within a particular time limit, like say for 2 seconds, 3 seconds, and you can verify the calls happen within that time limit using verify with timeout. So here you can see there is a timeout period set for 3 seconds. And moving on to mocking suspend functions. So here you can see I have an interface with two suspend functions. First one returns a result and second one returns a deferred result. So for mocking suspend functions, I use co-every and I mock the method call and return a result, and then I make the method call. So because it's a suspend function and suspend functions can happen in another suspend function or in a coroutine, it is enclosed in run blocking, and then I verify the method call using co-verify. And then I can also If I have to return some complex result, I can use co-answers as well in conjunction with co-every for mocking. And now moving on to mocking default functions. So for default functions, you need to return a mocked result which is of type completable default. So here you can see I'm mocking the method call using co-every, and then for the mocked result, for returning the mocked result, I use returns, and then mocked result is basically of type completable default, and then within the round brackets I'm returning the value. And then I'm doing the default method call in run blocking because it's a suspend function call. And when I do that call, I even wait for the result using await. This is because when I want to do any assertion, I want to be sure that the method call has completed, and then only I am doing the assertions. Otherwise, my verification or assertions will fail. So after the method result is obtained in status, I do an assertion. I use assert equals to match the actual and expected value. Now moving on to a demo of MockK with code coverage report. So before we have a look at demo, I want to point out one thing, that when you were using PowerMock for mocking private and static functions, there was a significant reduction in code coverage, and PowerMock is known for that. But MockK is not like that. Like, you can mock private and static functions, extension functions, objects, and you get a good level of code coverage. So if you are testing your class properly, you'll get 100% coverage. So there is no reduction or degradation in code coverage with MockK. So now I would like to show you a code snippet. So here you can see I have a presenter class, and it takes the view and repository as input, and then it has a method fetch data, and it calls the repository method fetch data, and when it obtains a result, either it will call view on result, or if it's an error, it will call view error. So when I want to test this main presenter class, first of all, with MockK, I need to include the MockK dependency, and then for main presenter, I need to have the mocks of view as well as the data repository, which I create with at MockK annotation. And then in my setup, I initialize, and I'm even using relaxing unit functions to do. And then I'm creating the presenter instance with the view and the repository. And now I'm testing the fetch data method, my presenter fetch data method with an with an empty result. So for this, first, because I know that presenter calls the repository method fetch data, I'm mocking repositories method fetch data here with the every construct, and I'm returning an empty list. And then I'm calling main presenter fetch data, and then after the call, because it will be successful, empty list will return in view.onResult. So I'm verifying whether view.onResult has been called exactly once, and I'm even capturing the parameter which was passed. And then with the captured parameter, I'm checking if it's not null and if it is empty, because I have passed an empty list here. So moving on to the second test method, testing fetch data with an exception. So here I mock the data repository.fetch data with an exception, and then I make a call to presenter method, and because it will return an exception, it will not come in the on result, it will come in view.on error. So here I'm verifying that there has been exactly 0 call or no call to view.on result, and there has been exactly 1 call to view.on error. And moving forward to testing fetching data via callback. So here I'm mocking repository fetch data method, and when I mock, I want to capture the argument which was passed. I'm capturing it to a slot, and then I'm assigning the mock result with answers, and I'm assigning basically a list here, a list of one item, and I'm doing the presenter method call. And then because I know that I have passed the mock result here, it will obviously come in view.result. So I'm verifying whether there has been exactly one call to view.result, and then with the captured argument value, I check if it is not null, if it's not empty, and if it equals some value. So here like I know the value which was passed was value 1, so I'm matching if the actual value equals the expected value, which is value 1. And moving forward to fetching data via callback with an error. So this is same as the above, only except mocking it with a mock result, I mock it with an exception. So when I mock it with an exception, I verify that it comes in the error block and not in the result block. And now moving forward to fetching data with Rx with an empty result. So all the steps are same except when I mock it with a single dot error. So I pass a error result, error mock result, and that I return it using return single dot error. And then when I make a call, I capture the argument as well, and I make sure that it comes in the error only, and that's what I'm verifying that there has been one call to view.on error. And moving further to testing fetch data with Rx with a result. So because I want to fetch it with a result, I give a mock result to it, and that is, in this case, it's a list which has one item, and I return it using single dot just, and then I make a call. I capture the arguments, and because here I'm actually passing a result and not an error or an exception, I verify that it comes exactly once in view dot on result. And then I can do some assertions on the captured argument, like verifying it's not null, it's not empty, and verifying the actual and expected values. Okay, so this is how mocking can be achieved using MockK, and I'll show you one instance of spy as well. So here you can see that in your fetch data method, you have a log method which gets called. So the purpose of this method is to log messages. So to test the log method, I create a spy of presenter, and then I basically mock the repository method, because the moment I mock the repository method and I make a call to presenter fetch data. So when fetch data will get called, I'm pretty sure that log will be called. So then I verify whether the log has been called exactly once. So I'll show you the code coverage with this test class. So you can see here, main presenter, it's covered 100% for class, method, and line. And I'll also show you the Jacoco report. So coming to main presenter, you can see that all the methods have been covered 100% in Jacoco report as well. So now moving on to the second demo, which is with Kotlin coroutines. So here you can see that I have a view model, and it has it takes place this get repositories use case class as a dependency, and then in coroutines it calls this get repositories use case execute method. So because it's a suspend method, it's being called here in the coroutine. So when I'm writing a test class for main view model, I want to mock this get repositories use case, and then even mock the call to this get repositories use case execute method, so that I can test my view model class only. So in the test class, I mock get repositories use case, using MockK annotation, and then I construct my view model with the mocked object, and then I mock the method execute, which is a suspend method. I mock it using co-every. So you can see I'm mocking it. I'm using co-every for mocking, and this method actually returns a list of repositories. So as mocked result, I'm returning list of some mocked repositories, and then I make a call to view model method. And after doing the call, because uh, because after this call the live data will get updated, so I make sure that live data has a value which is not null, and when the live data result status is success. And second test case which I've written is where I mock, again I'm mocking execute method, and then I return, uh, instead of using returns I use co-answers, and I return an exception. And then when I call the method, I make sure that the live data contains a not null value, but in this case the status should be error because I'm mocking exception as the result. So again I can run and show this to you. And also I've not used run blocking here in the test because fetch repositories is not a suspend function. So you can see the Gradle view model test is running. So while it runs, I would want to show you the repositories use case test. So here you can see that in the repositories use case class, GitHub repository is a dependency. It's being taken as an input, and then we have suspend function execute, and it returns a list of repositories. And basically on our GitHub repository class, we call this method fetch repositories. So when we are writing test case for a GitHub repositories use case, we should be mocking this class GitHub repository, and we should be mocking method called fetch repositories. So here you can see main view model tests with MockK have completed successfully. And now we'll have a look at get repositories use case test class. So here, as I said, that GitHub repository has been mocked with the MockK annotation, and then you use MockK annotations initialization method. And then when you create an instance of GitHub repositories, you create it with a mocked instance. And then to test the positive and negative scenario, you mock it using co-every. You mock fetch repositories method and you return a list. Now because your get repositories use case execute method is a suspend method, so hence this is run inside a coroutine run blocking. And after running, you can verify the result using various assertions. And then you can even test the negative scenario, wherein you mock it using co-every, and instead of returning a mocked result, you return an exception, and you can make a method call and verify that the response is an exception. So again, when I run this, you can see the tests have passed and the code coverage is 100%. So MockK is actually a mocking framework which is built for Kotlin, which provides a support for Kotlin language features, and it gives good code coverage as well. So moving forward to the next slide. So this code coverage I have covered. And this is the end of the presentation. So thank you all for attending this presentation, and thank you Pawan and Rivu for giving me this opportunity to present. And for questions, you can write to me at my Gmail ID, or you can even message me on Twitter. So thank you everyone for attending this session. Thank you so much.
Thanks, Monica. Guys, we will be back in a while. We will take a short break and then we'll be back. Thanks for joining. Thanks, Monica. Really good session. Do you want to take some questions as well?
Yeah, I can take them.
Okay, let me just check if we have got some questions. We don't have any such question related to testing, but I'll let you know. I'll probably share the links. Okay.
Okay.
Thank you so much. And guys, we will be back in a while, around 6:30. We have a session with for Flow, and Akshay will join us. So keep watching.
Hi everyone, I'm Ayush Sharma. I'm the lead at DSC, and this is my DSC Solution Challenge project called the Help Desk. So, it is a platform where people will get help in anything in their life, from learning something to do any particular task, in order to save their time and money and a bad experience. So, I see people when people start something new, they don't have any guidance apart from the internet, where you will see plethora of things which are not like easy to find the good thing. So there will be someone who can help them in finding a right particular resource in order to save the time and money. It would be a great idea. So I come up with an idea to solve this problem called the help desk. So let's sign in. There's a sign in and sign up feature where you can sign in with Google or email and password. So I just sign in with Google, and here's the helpers desk view, where you will see a list of people who are right now available at helping in the skill set.
Live streaming is on.
Hi everyone, welcome back to Understream Day. And now we have with us Akshay Chordia. He's another GD from India. He's right now working as an Android engineer in Clue and lives in Germany. But still, he's from India, and I have worked with him, like not worked with him, but in committee we have discussed a few things, and I have for a few books I have worked indirectly with him. So yeah, over to you, Akshay.
Thank you. Hey everyone, welcome and thank you for joining. I hope you're wearing waterproof clothes because it's Kotlin flow time. I'm Akshay Chordia. I'm based in Berlin, Germany. I'm originally from like Pune, India. So I work as an Android developer at Clue here, which is a female health company. So and I'm also a Google developer expert for Android. So today, like we are going to talk about something which many people are excited about, that is Kotlin Flow. The goal of this talk is to tell you why Kotlin Flow was designed, show some of the basics, show what makes Kotlin Flow so special, and how you can migrate to Flow if you want to, and how you can architect like Flow and super important, like that is the testing. So before we begin, let's rewind a little bit and look at what Kotlin gave us, that is coroutines. So coroutines, like they simplify asynchronous programming in general, and especially on Android. Let's take an example. So here is an example of a synchronous function called showUser, which internally loads the user from the database. When this function calls loadUser, it blocks the current thread and waits till the user is loaded from the database. This blocking is bad because at this moment the whole UI is frozen, making the user unhappy. And then once the data is loaded, loaded from the database, the render function is called, which renders the user data on the UI. So there are like multiple ways to tackle this synchronous code. So let's look at like how we can like tackle this problem using coroutines. So let's take the original synchronous function showUser. First we need to mark the showUser function with the suspend keyword. Of course, we will need to mark the load user function as suspend too, since we also want it to run on the background thread. You can see that by just marking it as suspend code, the code will already run in the background thread. But there is a problem. The render function needs to be called from the UI thread since it's touching the UI, touching the view hierarchy. So we can use the with context function, which allows to switch the thread inside the suspending function and change the thread to main and call the render function. And that's it. Like that's pretty much how you can convert a synchronous function into asynchronous using coroutines. So let's look at how it works internally. So we start by calling the showUser function. Since it's marked as suspend, it will switch to a background thread or the thread specified while launching the coroutine. And then the user will be loaded from the database on a different thread while the main thread continues to go ahead without waiting for anything. That is not freezing or blocking the user experience at all. And then it will switch back to main thread because of the with context and then call the render function on the main UI thread, main or UI thread. So one key thing to remember is a suspend function can only be called from another suspend function or from a coroutine scope. A coroutine scope is basically a scope of the coroutines. So each coroutine, when you want to run a coroutine, they need to be associated with a scope. And when the scope is destroyed, all the running jobs inside the scope are like stopped or cancelled. So this scope, coroutine scope, is generally associated to the lifecycle scope for simplicity. For instance, on Android, each activity has a lifecycle. So we could associate like the coroutine scope with the lifecycle of the activity and vice versa. So let's look at an example to help understand this better. For example, in order to call our showUser suspend function from a normal function, we would need a coroutine scope. And on Android, these scopes are already implemented for us. Like the lifecycle scope here is it's a part of lifecycle KTX library from the Jetpack component. It is provided to use coroutine functions like from activity or fragment. So it's a coroutine scope which is tied to the lifecycle of activity or the fragment. So basically, this provides the magic of automatically clearing or canceling all the jobs in the specified scope when the activity or fragment is destroyed. The launch function here is used to start the coroutine. As soon as the launch function is called, it will immediately start the coroutines. That means the coroutines are hot in nature. And this is also one of the reasons why coroutines are not like one-on-one replacement for reactive streams. So basically, a coroutine scope is kind of a subscription management system, but it is associated to the lifecycle. This concept is called as structured concurrency, and this is what makes Kotlin coroutines so powerful and also helps developers helps prevent developers from leaking the job or the subscription. So let's come to the important question, like why should you even use Kotlin Flow? So why did it came in first place? So with the growing usage of Kotlin and the love for Kotlin coroutines, people expressed a lot of interest in having a pure Kotlin implementation of RxJava to leverage all the amazing features which Kotlin provides. But the confusion was like creating some sort of a magic on top of RxJava to leverage Kotlin or to build a whole new library from scratch. Like, should we do like Rx Kotlin or like build a whole library from scratch? In case you don't know, Rx Kotlin does exist, but it doesn't really leverage all the Kotlin features. So the decision was like they made it from the scratch. To me, it's important that any new library raises the bar compared to any existing library out there, and is not just a replica with slight improvement. And Kotlin Flow does raise the bar. So let's look at what's special in Kotlin Flow to raise the bar. So Flow provides null safety in the stream. That means you cannot send null values in the stream. This is not something new. RxJava 2 has it too. Second is the interoperability between other reactive streams and coroutines. This is the key thing. Flow provides an easy API to convert Flow to any reactive stream like RxJava Flowable or Observable and the reverse. And you can also combine Flow and coroutines. We will see this later. Also, Kotlin Flow supports Kotlin Multiplatform. So you can actually use coroutines and Kotlin Flow on any of the Kotlin supported platforms like JVM, JavaScript, or native, or you can use it put it in the common code or the shared code for Kotlin multi-platform projects. Also, like there is no special handling for back pressure. There is like literally like no operators or like very minimal operators for handling back pressure, because this is magically handled by suspending nature of coroutines. Also, like there are like fewer and simple operators. This is because of Kotlin's how Kotlin is designed, because of extension function and because of coroutines. A single function can be used for both like synchronous and asynchronous operations, and that's why there are less operators in Kotlin Flow overall. Plus, it has the perks of structured concurrency, which we saw just before. Okay, so what is Kotlin Flow? So Flow is based upon the reactive stream specification, similar to RxJava and other reactive libraries out there. You can think of a flow very similar to a list of a collection, or a collection. So similar to a list or a collection, it also has a lot of operators like map, switch map, etc. Plus, it's like built on top of coroutines. And lastly, it's like cold in nature. So let's look at some of the basics of Flow. Essentially, there are like two components, that is emitter and collector, where emitter emits new values and collector receives these values. So here is an example of an emitter, which returns flow of string, very similar to how you would return a list of string. So there are various ways of creating a flow using something called as flow builders. So these are the functions provided by Kotlin coroutines library. So they internally create the flow for us. We will come to this later. Since flow is cold, nothing inside the flow builder block will be called until there is a subscriber or a collector observing the flow. Okay, and let's look at the collector. Here we have a main function which gets the flow inside the run blocking function. For people who haven't used coroutine, run blocking function is a blocking coroutine scope. That is, it blocks the current thread until everything inside it is completed. We need the coroutine scope since the collect function is a suspend function. So is emit. We will see ahead why they are a suspend function in first place. So let's understand like how things are working internally. Initially, the main function calls the stream function, and this will immediately return the flow. Then we call the collect function on the flow, which essentially means we are subscribed to the emitter. And then the emitter starts emitting the value sequentially, and the collector receives them and prints in this case. And then the same loop happens emitting the next value. And this goes on till the emitter has no values. That's when the execution moves out of moves out of collect and is complete. So let's dive a little bit deeper and see how things are working internally. As I mentioned before, flow is based upon two components, essentially a collector and an emitter. So they are basically just interfaces. The following represents the interface for collector, which exposes the collect function, and the emitter interface, which allows emitting values. The key thing to note over here is both the functions are suspend, which allows the magic of interoperability with coroutines. And this also allows using structured concurrency, which is provided by coroutines. The funny thing is the whole mechanism of flow is essentially emit and collect function calling each other. So that's basically it, like in a very simple fashion. So flow loves coroutines also because it's built on top of it. So let's say you have a function which loads data from database. Since this function takes time to perform, you would ideally want to perform it on the background thread by marking it as suspend. And the funny thing is, you can just directly call any coroutine function inside the flow block. That's because the flow block accepts a suspending lambda, and also because both the collector and emitter are suspending function, which is just great. So let's look at a core ideology of flow and how they make our life easier as a developer. With flow, you can define or switch the thread by using the operator called as flow on. So this operator takes in a dispatcher, which in this case is IO. So whenever you use this operator, it will set the specified thread only upstream. That is, anything above the flow on operator will run on the IO thread. And also with this code snippet, the map operator, which is below the flow on, will run on some different thread, which is not IO. This concept of preventing context from leaking is called as context preservation, where the context is encapsulated and it's never allowed to go downstream. There is only one way to change the context of a flow. If you compare this to RxJava, where it's like super confusing, especially for beginners, to understand which thread the code is going to run on. In the example above, you can see that only the first subscribe on is applied and the other one is ignored. Combined with another operator to change thread, that is observe on, and which adds a different behavior, it's like a facepalm moment. And it's like super confusing, especially for new people who are like using RxJava. So exception transparency is the second principle or ideology of flow. So flow implementation never catch or handle exception that occur in the downstream flows. They catch only the upstream exception. This is again due to context preservation, which we saw a moment ago. And there is only one operator to catch error, which is just catch operator. Let's look at an example. So let's take the previous example of a flow, which tries to get the value from the database and emit. As you can imagine, anything can happen while loading from the database, and the database might throw any sort of exception in between. So very similar to a try catch block, flow has a catch operator which will catch any exceptions thrown above. You can even use the classic try catch block. It will behave exactly similar to the catch operator. But I would recommend to use the catch operator. But there can be use cases when you want to use the simple try and catch block. But just during those times when you use the plain old try catch block, just make sure to ignore the cancellation exception because you don't want to emit an error when your flow or coroutine was cancelled. That which can happen when your activity is closed or something. This is pretty much how the catch operator works internally. Or you can, like, the other way is like you can specifically handle the exception you expect to see. For example, in this case of database operation, you know that there is always going to be there will probably be only IO exception, so you can handle that specific one. The value emitted from the catch is received in the collect block. That means there is only one single place to handle all types of cases. That can be either success or failure. And this makes it like super transparent to handle all the cases at one place. I would recommend to toss in seal classes so you always cover all your cases. At this point, it might be confusing to understand when to use flow and when to use suspend. So use suspend for the general rule of thumb is to use suspend for one-shot operation, like inserting into database or doing a network operation, and use flow when there is a stream of data involved. For example, getting data from the database, and in this case where you want to like continuously listen for update and update your UI whenever there were changes in the database. So let's look at channels. So channels are communication primitives. They allow to send and receive data between different coroutines. The idea is to use the idea of channels is to use communication for sharing information instead of sharing a mutable, instead of using a shared memory to avoid all the errors. So basically what happens is like the coroutine sends, so the coroutine which sends the information is called as producer, and it sends it through a channel, and the receiving coroutines are called as consumers. And the channels are hot in nature. Hence, they are not always the best candidate to use. Also, channels are low-level primitives. And Kotlin Flow internally is built using coroutines and channels. Generally, you should try to use Flow as much as possible for your use cases. Just because with channels, you need to be a bit careful with its hot nature and cancellation and some other setup stuff. But that doesn't mean that you shouldn't use them. It's just like prefer using Flow more than channels, and also try to whenever you use channel, try to expose those channel as flow to your other parts of your code. So to understand channels a bit better, let's take an example of a search application where the app needs to show some results after the user enters the search query, for which we will use a conflated broadcast channel. It's a very mouthful name. So this conflated broadcast channel is basically a broadcast channel, or you can call it as a send channel. That is, it allows to broadcast or send values. And conflated means only recent values are emitted, and every subscriber which subscribes to this channel will immediately receive the most recent element. And somewhere from your activator fragment, you would write the code like where the text, where the search text changes, you would call the send function on the channel, which will emit a new value to its observer. On the receiving end, you can convert the channel to flow, do some map operation to get the result for the specified search query. And you could throw in distinct until change to just filter the unique results. And at the end, finally, you would render the result on the UI. But like I said, channels are very low level, and you should try to use flow as much as possible. And Kotlin team is working on this, and they're trying to cover more and more such use cases in terms of flow. One such class available to us is Stateflow. So Stateflow is a new primitive. I think it was just launched in previous 2 versions back or something. So it's a new primitive, and it's designed to emit updates to its collectors, and it's meant to eventually replace conflated broadcast channel, which we just saw. So let's take the similar example, and you would see that there are state flow and mutable state flow. The difference is the mutable one allows setting the value to the flow, Make sure to always expose state flow outside to other parts of your code to avoid the side effects of mutability. So similar to our previous example, when the text will change, we will set the value to the flow. And whenever this value is updated, the collectors will receive it. And then, like every other flow, we can just directly collect it and listen to the updates. So one key thing to remember is the operator distinct until changed is automatically applied for state flow. The IDE will warn you if you forget, so that's a good thing. Okay, migrating from legacy to flow. A lot of code bases are stuck with legacy code, either callbacks, RxJava1, loaders, or other old asynchronous programming APIs. Sorry, and it's totally fine. If it's working, it's great. But the problem lies with slower and hard code maintenance and refactoring when there is a new requirement. So this slows the efficiency and the velocity of developing the new features. So there are like two major things to do whenever you want to migrate. First is setting up the process with the team, and this is actually really important. So the whole team works towards a single goal of migration. And there is no rule of thumb over here. These are just my recommendations, which have just come up at Clio. So the first order of business is to discuss within your team and try to figure out what alternative to pick, and such an alternative that works for your team and the use case you're trying to solve. I would recommend doing something as followed to get started and decide what other tools suit the best for your code base. So first, like set up a meeting with the team and list out all the possible alternatives for migrating your legacy asynchronous code to probably either RxJava2, 3, or Flow. Discuss the pros, cons, and advantages of all the options. It's also best if the team gets to try out and get comfortable with the option which you all decide during the meeting. So this might also include doing a very small sample app, giving an internal presentation, article or talk, etc., so that the whole team is comfortable with Flow or whatever you have decided. It's also important to evaluate how hard the migration of certain option looks like for your code base. So for instance, we at Clue migrated from RxJava1, actually are in process of migration from RxJava1 to Flow. And at that time, we had to evaluate RxJava2 and 3 for our code base. And it would have been, during our steps, we found out that it would have been like super hard for us. And that's why we also liked Flow a lot, and everyone felt comfortable with it. You should also evaluate the learning curve for the new joiners of the team, so that it's easy to get them on board. At the end of this, you and your team will have a common goal in mind. For example, migrating from RxJava1 to Kotlin Flow. So setting up the foundation is very key to the whole migration, because that's what will motivate the team to write the new code in Flow or whatever is you decided upon. You don't want any developers to start thinking to write a new feature in Flow and then realize that there is no testing framework or something like that, which will make the developer go back into their comfort zone, since all of us are like humans, right? So to set up the foundation, start with setting up the guidelines, where you can write all the standard practices of how this can be again decided within the team, a set of standard practices on how to use Flow or coroutines throughout the code base. And then second step is set up the necessary base classes for your code base, and to work with your architecture, including the dependencies, all the base classes. Like if you have any presenter or something, set up the presenter to work with Flow or coroutines. So things like that you would do in this step. Third is setting up the testing framework or the utilities for testing. So it's easier to get started and do testing. So this can include setting up the dispatchers, etc. So the fourth one is super important. So each code base has some APIs which are commonly used by a bunch of features in the app. So for example, getting the username or user details like password or something like that. And It's ideal if those base APIs are exposed as flow equivalent functions. So let's take an example of this. So let's say you have this existing function which exposes an observable of user. One approach is to convert this function to return flow or coroutine, which is great if it's possible, but it's not always feasible, right? So another approach is to duplicate the base API and expose the duplicated API as flow or coroutine. I would recommend to also mark the legacy function as deprecated so that everyone uses the new function and avoids the legacy one. And eventually, with time, as everyone uses the new function, you can remove the legacy function at some point. And then also, like I would recommend to try to extract the business logic between the two functions so that the existing function and the new function share the same logic, so that you don't need to update at two places when there is a need for updating the business logic. Now that we are super motivated to write Kotlin coroutines and flow, safeguards will force actually the team to write more and more code in Kotlin flow or coroutine, and also convert the legacy code. So each code has some base APIs. Oh, wait. Yeah. So first step is ensuring that the new code is so you could set up a safeguard something like this, where during the PR reviews, ensure that that the new code is always written with Kotlin coroutines or flow, and it's not using the legacy asynchronous API which you have in your code base. Second safeguard would be like ensuring that whenever the legacy code is touched, the developer has tried to convert it into coroutines of flow. Another one is really nice, like you could do a monthly or quarterly check of progress of how the gradual migration is going, or if there are any hiccups in there. This will also keep you motivated. And the other ideas which will pop into your brilliant minds. So again, interoperability. So the key to success of Java Kotlin migration was interoperability and ease of using one function from another. So ease of using one from another, which opened the doors for gradual migration of Java and Kotlin. Similarly, like having this ability allows to quickly interop between the legacy code and the Kotlin flow or coroutines. And this can dramatically change the landscape. And Kotlin Flow provides an amazing API to convert any legacy callback-based API to Flow. So let's say you have a function which has a listener, and this listener is triggered each time the document is updated. And also, like, you need to make sure that this listener is removed when the component is destroyed. For example, when your activity is destroyed, remove the listener. So Flow provides an easy API called as callback flow. So where you can write the legacy listener, that is aka callback, and whenever like the callback is triggered, the legacy code, like the callback of the legacy code is triggered, you call offer, which basically means emit this value each time the document is updated. But now you might be wondering, what about removing the listener? We need to remove it at some point, right? And for that, Kotlin provides await close function, which is called when the flow or coroutine is cancelled. And this is a really nice, or like you can say a safe place where you can remove the listener. Finally, with the code comments, it looks something like this, which I think a lot of people forget to write. I'm just reminding over here. So let's look at how you can migrate from RxJava to Flow. So the goal here is to not tell you to go next moment and migrate your code base to Flow. I mean, that would be great for your own projects, obviously. Okay, so Flow and Rx follow the same reactive specification. So in theory, it's very easy to convert data streams from Rx to Flow and the reverse. So there are like two ways to convert. So first one is like just refactor, go in there and like take your RxJava implementation and convert it to use Flow. but that's time consuming. And sometimes you just want to switch types so that you can gradually migrate to flow. In that cases, you can use the asFlow extension function to quickly switch the type from flowable or observable to flow. The same can be done to convert flow to observable or flowable when you need it. So these extension functions of conversion are available in the Kotlin X coroutines RxJava 2 dependency. So here is a quick comparison of terminology between both the worlds, like the RxJava and the coroutine flow world. And this is something which I stole from Clue's documentation. In my defense, I created this table at Clue, so I think I can use it. So use this chart as a reference when you are new to coroutines world or working on migrating from Rx to coroutines or reverse. You can see that we have covered pretty much all the things mentioned over here. Yeah, I think, yeah. So let's look at something really fun. So the asFlow function, which we saw just a moment ago, to convert the observable to flow, actually uses callback flow to convert the flowable to observable. And this is so cool. So let's say if your code base is stuck with RxJava 1 and you want to move away, I would recommend to migrate to Kotlin Flow rather than migrating your RxJava 1 code base to RxJava 2 or 3. Since RxJava 1 bindings are not officially supported, I have created this really brand new library for all of those who need it. It offers the same API which we saw before for similar to RxJava 2, where it allows you to convert flow, like an observable to flow and a flow to an observable. Now to everyone's favorite topic, that is testing. Testing flow or coroutine is pretty easy. So let's take a simple example of a string and write the test function. And we will use the run blocking coroutine scope because we want our test to wait till the coroutine is completed. Like I said, flow is similar to a list or a collection. So you can use take one operator to pick the first value from the string, and then convert the flow to list so you can easily assert it. Or you can use this extension function, which I again stole from Clue code base, to assert the items. With the extension function, which I just showed, it would be something like this, which is like much cleaner, where you can just assert the expected items. Okay, conclusion. Here's a quick summary of what you have learned today. So we revisited Kotlin coroutines. We saw why Kotlin Flow came into the picture and what makes it so special. We saw basics of flow, that is the emitter and the collector and how they work internally. We also saw the principles of flow, that is the context preservation, exception transparency, and how they make our life easy. And then we saw channels, and then we saw how to convert RxJava or any legacy code for that matters to flow. We also saw how to test a flow, and then put some pro tips along the way. Okay, here are some final thoughts. So Kotlin Flow actually raises the bar and introduces like a really easy React stream. That said, it's work in progress and a lot of exciting things are coming soon. For example, shared flow is one of the things which is still work in progress, and a lot of things in the Kotlin Flow library are still experimental, which is fine, and you can use it in production, and we are also using it in production. So here are some further resources for learning Flow. So the first is like the news app. So this news app shows you how to use Kotlin Flow and coroutines. So I might be a bit biased over here because these are my apps and my resources over here. But basically the app shows you how to use Kotlin Flow with the whole Android architecture. Yeah, go ahead and try it out. And there are some other articles which I wrote about Kotlin Flow and how you can migrate from legacy code to Kotlin Flow. And thank you. Make sure to scan the QR code or hit the link below to give the feedback on how the talk was. And yeah, that's it. Thank you. I think we finished way too early.
No worries, Akshay, and it was a great session. Thanks for that. So we have a few questions. Yeah, we have some time to take the questions. So I will be asking you those questions.
Mhm.
Yeah. So the first question is how defined is a stream flow compared to Haskell's IO monad?
Oh, I actually have no experience with Haskell's IO monad, so I'm not pretty sure of how it would compare.
Yeah. And okay.
Really good question, though.
Yeah, like I myself will look into it.
Yeah,
How actually, yeah, that, wait a moment. Uh, yeah,
yeah.
that was only questions in the Slido. And another question was uh, okay, that was by Sam Edwards. No, okay. So Sam gave the answer in the comments.
Ah,
Okay, uh, so cool.
lovely.
No more questions, and thanks for taking your time joining us today.
Thank you for having me. And if in case anyone has more questions, they can reach out to Twitter on my Twitter handle in the slides, or watch this talk again. So yeah,
Yeah. So yeah, thanks so much, and we'll have Sam in next 50 minutes. And
Yeah,
as
we'll be back.
yeah,
Live streaming is on.
Hi everyone, welcome back to Android Stream Day. Now we have with us Sam Edwards, who is a fellow instructor at Caster.io and Android developer at Capital One, Google dev expert for Android and Kotlin, and yeah, a lot of things. So Sam today will talk about, wait a moment. Yeah, Kotlin actors. So yeah, over to you, Sam.
Cool. Thanks so much. Can you hear me okay, Rivu?
Yeah, it's perfect.
Okay. All right. Let's get started then. I'll do a screen share. And then I've turned the video on, right? All right, here we go. All right. See, can you see my screen now? Let's preview. All right, yes. I'm assuming you can. All right,
Yes.
cool. So these are some screenshots from Akshay's talk. So Akshay did an amazing talk about using Flow with Kotlin. So I'll go in that in a second. But first of all, big shout out just for Android Stream Day in general. It takes a lot of work to put something like this on. So thank you, Rivu. Thank you, Poan, very much for putting this on. It's really cool to be able to do it. And thank you for letting me share some knowledge. So let's look at the slides so it looks more like a presentation. Okay, so today I'm going to be kind of building on what Akshay did when he talked about Kotlin flows. Kotlin flows are part of the Kotlin coroutines framework, or library that's available. So that allows you to do a lot of things like background tasks, multi-threading, and actors is one piece of it that's related to channels. So if you get to see that talk, it's going to be pretty related. This is actors are like, they're usually on stage in a drama or something. So the joke here is no drama concurrency because it's actors, but I'm not that funny, so that's fine. You can follow me on Twitter on HandstandSam or my blog handstandsam.com. Thank you very much for the awesome intro, Riva. I'm just going to, we'll get back here to these screenshots from the last talk. All right, so concurrency. What is concurrency? Very small, it's all these things, but let's zoom in. Let's use Keynote, let's make it look pretty. Okay, concurrency is the ability of different parts or units of a program, algorithm, or problem to be executed out of order without affecting the final outcome. So you got all these things happening, but the final outcome is always gonna be what it should be. And what this allows for, like with coroutines doing all this background work, allows parallel execution, which means if things are running in parallel, meaning there's multiple things running at once, it can improve the speed of the system because it can be split across many things. And this can let you leverage things like coroutines or multi-processor systems like we have multi-cores on there. So concurrency basically allows for us to do all these things, but then at the end of the day, make sure that we don't affect the final outcome of what we're trying to do. Welcome to Android. I know this is Android Stream Day, that's good. This is very much a Kotlin talk, but it very much applies to Android. The reason why flow is so important and why coroutines are so important and actors are because Android as a platform is very asynchronous. So reactive programming allows you to tie in all these asynchronous events. And this diagram is one I like a lot. It's stolen from a talk from Jake Wharton from a few years ago. But basically in the very middle with the little brackets is your code. At the very bottom is your phone you're holding in your hand. And so if you went ahead and use your phone, as you tap on things, the code is executing. Then the code might also be talking to the disk on the left to read from a database or shared preference. And then those updates are coming back. And then on the right, you're calling APIs on the cloud. So you're getting data, it's coming back, you're processing them. And then at the top, you're listening to things like Bluetooth and other things on your phone, network, Wi-Fi, everything else. And so all these things combined are all things that don't happen in an order. They all happen out of order in parallel, and you must react to them. So it's important to have reactive code on Android. And one of the things Jake said in the talk is once you have one thing that is asynchronous, you can't do imperative programming. So once you have one thing that kind of happens in the background and goes everywhere, you need to program in that method. You can't program in imperative method, which just means one thing at a time. So reactive programming is essential on Android. And so the Kotlin coroutines library allows us to do that. Cool. And so the answer of how you do that back in 2017 was with RxJava. So you'd manage this reactive role with that. Akshay talked about how he migrated his team from RxJava 1 to Kotlin coroutines. If you talk to the people at Google now, they officially recommend Kotlin coroutines as the asynchronous framework to use for background work. So no async tasks, no RxJava, they officially recommend coroutines. So just like Akshay said, I would recommend going to that. A lot of the code I've been writing on uses coroutines, and it's fantastic. Of course, 1 month later is when Kotlin was introduced as the language that we could use in Android. So that's why he was talking about RxJava here. All right, what are Kotlin coroutines? We've talked about it a little bit. Dive in more. I'm gonna try to explain it in one side. It's not probably gonna work out that well, but let's see if we can kind of dumb it down, or make it simple enough so that we can understand. So a Kotlin coroutine is a function with a suspend keyword that signifies that it must run within a coroutine. So you see there's a yellow suspend block, and then you have your code saying go do network requests. So what that means is it's going to run inside of a coroutine and return back a result. Second of all, suspend functions must be run within a coroutine context. So coroutine context kind of says when you're able to start or cancel. Basically, it manages the running of it, and you can run that on a dispatcher. The dispatcher is very much like the thread pools that we had. So it's the default one, which is for the background. There's the main one for the main thread. There's ones for IO and so forth. So basically, you take the suspended function, you run it in a coroutine context, and then it runs in coroutines. That's how it works. So essentially, coroutines are lightweight threads. The way that they're different, though, is coroutines don't block an entire thread. You can have hundreds of coroutines or thousands of coroutines running inside of a single thread. So coroutines just have a really nice way of, when it's not doing work, it allows another coroutine to or another piece of work to leverage that coroutine to go ahead and run code. So coroutines are a really nice way to do background processing to let you really do tons and tons of things at once. And like we said, they must be launched in a coroutine scope. So how do we write concurrent code with Kotlin coroutines? We talked about how concurrency means that you can do all these things in the background at many points in time, but at the end, you have your expected result of processing these things. Here's a link. I'll share these slides later, but here's a link to the Kotlin docs to basically talk about how we can deal with these things. What they mention is a few solutions that you could use. First, to do concurrency, you can use a mutex. And each one of these, I'll show just a really quick snippet of what these are. You can use a mutex. You can use a thread-safe data structure, such as an atomic integer, which will block the thread anytime you're doing a write. You have thread confinement, which means you're really forcing imperative programming, right? Everything must run on the same thread, so it must happen in order. So really, if you ran everything in the main thread, then it would be fine, but your application would be really slow, and it wouldn't work the way you'd want it to. It wouldn't be fast. And then their other recommendation is actors, which actors can run in their own coroutine. They're a subclass of a channel, and they allow you to do concurrent code. So that's what I'm really going to be talking about today, how we can write concurrent code with Kotlin coroutines and leverage actors. So I said I'd show a little snippet of each one of those options. The Kotlin coroutines documentation said of things that you can use to do concurrent code. One of these things is called a mutex. And so what you can do with a mutex, it's kind of like the synchronized piece that you have in Java, or you can leverage in Kotlin as well. But basically, you have a mutex, which is this object. When it's locked, nothing else can execute until the mutex is unlocked. So in this case, we're going ahead and we're locking the mutex, we're incrementing the counter, and then we're done. So basically, that means when this is locked and it's executing, only one thread at a time can go ahead and do that. And that way, it is thread safe and provides concurrency. The thread safe data structures they recommend are things like atomic integers. The example here on this would be, atomic integer.increment or .decrement or get the value. And inside of there, they're taking care of making sure that everything is thread safe so you can provide concurrent code. So I talk about integers here, but there's other data structures that they have for that. Thread confinement, kind of like I was talking about, where if everything runs on the same thread, like maybe the main thread, then you'll have concurrency, but it's not a practical thing on a system like Android where everything is asynchronous. So if you wanted to run something on the main thread or have it execute on the main thread, you could create a coroutine context for the main thread itself. And so what that means is when that coroutine executes, it's going to be executing on the main thread. You also have this thing called run blocking. So whatever coroutine context whatever thread you're currently on, if you call run blocking, what it means is it'll just take that thread and run everything on it without actually doing anything in the background. So that is really useful for testing, actually. So if you do run blocking, then you can go ahead and make sure that your test runs everything and then finishes, because you don't want things to happen in the background, right? If you have a test that goes and makes a network call, if you're not waiting for that to finish, your test is just going to finish and be done. So you basically want to block the thread and say, wait until this networking request is done, and now finish the test to my assertions. So, you know, the smart person would say, hey, concurrency, you said I could just run everything in the main thread. I'm good to go. But as Jake mentioned in the talk, once you have one thing that's asynchronous, so that's happening, you know, in the background thread or whatever, then the whole way you have to think about programming changes. And on Android, this is not a practical solution. And so it's definitely not recommended. Welcome actors. So this is the last option they mentioned in the Kotlin documentation for concurrency. Let's talk about how that's going to work. So actors are a single coroutine. So actors are coroutine. They process messages that come in. So actors are waiting there. They have messages come in, just like when you saw like kind of the atomic integer increment and decrement. Those are kind of like messages coming in. One message saying, please increment this, please decrement this, please get the value. So it's kind of that idea, but you get to define what those messages are that are coming through the channel. Actors are backed by a channel. So actor actually extends channel. And so what this is nice for is the fact that you get to process, I think, so Akshay just said channels are like primitives in Kotlin coroutines, and they allow you to communicate between coroutines in a way that's safe. That's the only way that you can talk between them. And finally, actors are concurrent, because what they're going to allow you to do is, while all this background work is happening, when they're going to be processing the messages internally, it's going to happen in order, which means that you can have all this stuff happening in the background, but as long as you give it to the actor at the end, then it will make sure it processes it one by one. So here's my visualization of this. I created this, I was drawing it, I was like, this makes sense to me. And then I stepped back and I said, this looks a lot like a marble diagram. And I know the first time I saw a marble diagram, which is typically used to like explain reactive flows, or reactive code. I saw this for ArcJava many years ago. My brain just kind of melted and I said, oh my gosh, like these things are so confusing. What's going on? So I'm sorry that I created something like a marble diagram, but I guess these are good ways of representing it. Anyway, let me explain what I did in here, and maybe that'll help you. Let me see if I can, because I can't use my mouse. So what's going to happen is an actor is a single coroutine, and that imperative programming thing is going to be this line that's in the middle. So it starts it's a for loop. It's going to be running, and it's just going to process things one after one. So that middle line, the for loop, that's all we're looking at. It's an actor coroutine that processes messages. So what's happening is on the top and the bottom, messages are coming in at various points of time. So they're going to get processed in order, like it's literally in a for loop, and we'll see the code, so that we get a message, we process it. And that's really all an actor is, and that's how it's able to enable concurrency. So like we said, it can process incoming messages or intentions. A lot of the code I've been writing uses the MVI, or model view intent, kind of way of developing UIs. And so I really like the term intentions. You can send in messages, but I'm going to be mixing the term messages and intentions. Basically, a message can be whatever you want. In this case, I'm going to call it an intention. I'm just calling that out because it might be confusing here if I don't explain that. So in this case, you're going to have these messages coming in, the intentions. And in this case, we're actually going to be modeling it based on an app that I have. So these examples, screen. So this is my device here, if you guys can see it. I'm a Pixel 4. So on here, I've got this app. It's called Shopping App. It's open source, and there's links to it in here. There's actually a PR, and we'll be writing code for this on what we did. So we can go into vegetables. We can go down to like avocados, and then we can add a bunch. Oops. Yeah, add a bunch. On the top right, you see there's a little a shopping cart icon. If I go ahead and click a few more times, you see it updates. If I go into there, I have 17 items in my cart, 11 avocados, kale, and roses. Let's say I don't want roses, so I can delete. And as I delete, everything kind of updates because it's a reactive stream where I delete one item from the roses. It then, notifies our data store, our shopping cart, what's going on. And then I have a reactive listener at the items and cart thing on the top that actually listens to it. So I'm going to delete another white rose and it'll go to 14 at the top. So this is the example we're using here to, to show off why we need something reactive and how it displays. And then we'll be going more into the example of how we can implement this using actors so that you couldn't actually have two people interacting with a shopping cart in the wrong order, or two messages coming in the shopping cart at the wrong time, because then it might, cause a problem or an error. Okay, so that's the basic use case there, and I wanted to show that because the code that's within our example here does use these sort of things. So in this DAO, and DAO means like a data accessor object. It's just a way that you call basically a database in code. So inside of there, we're going to have a few actions we do. We have find by label, we have upsert, which means insert or update, remove, which means delete, and then empty. So all these things can be done. If I actually show over in my code itself, and I didn't do a good job, so we're going to go ahead and bump this up to a better appearance. See, size, use custom font, size 24. Hopefully this will be it. If not, I will update it. Okay, that's not exactly what I was going for. Okay, so let's not do that. Apply. I'm sorry about this in the middle, but let's see, font. It is a lot better if I make it bigger now. So let's see here, general, editor, code editing. Apologies again. Let's give it one more minute. If I don't figure out where it is here, then we can go ahead and we can just do something else. Kotlin. Anyway, I can use presentation mode. I just really like to do it in here, and I wasn't smart enough to do this before our presentation. All right, so we'll figure it out here. We'll go ahead and kind of blow it up. But what I wanted to show you is we have this interface called a shopping cart DAO. So I'm going to go ahead and just use appearance full screen mode. Is in presentation mode. Cool. So this way everybody will be able to read it. These are the things that I'm trying to model. So first of all, there's going to be a flow which emits the items that are referenced in the shopping cart, right? So whenever you see that number on the shopping cart increment, or like you're in the shopping cart and it changes, this is the flow that's being emitted. So as Akshay said, anytime you have a reactive stream of things that are being published, always try to expose it as flow. Then we have these four methods that are there. There's suspend functions because they happen in the background, or at least they're causing database writes, so you don't want it to be, you want it to be suspended, so it happens in the background. So the operations we can do are find by label, where you send in the label, the upsert, the remove, and the empty. I just wanted to make sure I showed you this because when you see the sealed classes that represent that, then it makes a little bit more sense. So each one of these intentions would then be sent into one of those. And we'll actually be writing the code for this a little bit later. One thing that's interesting here is one of them sends in a completable deferred. That's because this is the only one that actually does a find and then returns back an object. So we'll go a little bit into that, but that allows us to wait for the result and then pull out what it would be, because we actually want to find something. We're not actually just making sure it goes in order. So yeah, we'll write this on our example, but what we're doing here is we're creating a completable deferred for this item with quantity type. We're sending it into the actor, and then we're going to wait for it to finish and then pull it out. So we'll write code for that. But what's going to happen in this actor when we implement it for this use case is we have an actor that processes those intentions. So we saw that sealed class. There are 4 different types representing the kind of actions that we wanted to do here. Those come into the actor because the actor is a channel, and it's going to process those one by one. So each one of those intentions is going to process in the channel, and then it's going to find the intention it is and complete the code. I wanted to call out here that an actor actually extends send channel, so it is a channel itself. So you're able to send things into the actor, and the actor is able to emit a value, which is on a channel itself. The actors are concurrent because it's a single coroutine processing messages sequentially. So it's a for loop processing each one by one. All those messages that are coming in are queued up and processed. So one of the things you might be saying is like, well, what about like basically back pressure, right? So if you have like 1,000 messages waiting, so there's things called capacity that you can give to an actor, where it could even say just like only allow one, or maybe allow any unlimited amount. So you have the ability to kind of specify what that would be for that queuing mechanism if you have a lot of things coming in at the same time. But if you look at the documentations for actors, you might say, oh my God, OMG. It says obsolete coroutines API. Like, why, Sam, you're Kotlin GD, why are you talking about actors? They're obsolete. Like, we shouldn't use them, right? So let me go into why I'm actually talking about them. So actors do have the obsolete coroutines API on it. However, it's not to be that scary. What it means is it is obsolete. They know that something's kind of wrong with it. And so maybe they have a replacement in the future, but not right now. So if you look at this, let's see here, it will be redesigned in the future, and there is no replacement yet, but they cannot be deprecated right away. So they're not going away, but still it gives you that weird feel of like, hey, like, what am I going to do? Like, what if they do go away? But there's a thread on complex actors on the Kotlin coroutines framework. Roman Islerov is the lead designer for coroutines. He's the second answer here. And what he ends up saying is, we're not getting rid of actors in the near future. We plan to introduce a more convenient API for writing actors. The existing actor function will either integrate to the new API or be deprecated with some clear replacement. Old code using it will continue to work. We don't have a complete design on the table yet, so it's subject to change. So what this is saying is, actors as they are, when they were designed, that they want to do it in a better way. So what actors do and the way they are now, like, don't worry about doing them. There will be a small migration path to a complex actor when that even gets designed, right? So there's been no update on this to say that that's been there. So an actor is not something just in Kotlin. An actor is just a way of doing concurrency. So there's implementations in other languages. So what they'd be doing is updating the Kotlin coroutines framework to make it a complex actor, which can still support these basic use cases. So actors, yeah, they're not going away. They're just maybe going to be slightly changing. So if you implement them and use them now for these use cases, if it's appropriate in your project, that's totally fine. So I actually got to ask him the question because I saw that in the channel, but then we had an opportunity to talk with him on a Google Hangout. And basically, these are the notes I took after asking, like, oh my gosh, are actors going away? You said it in this thread. He said, you know, they're not deprecated, they'll remain. But original actors were designed pre-structured concurrency. However, like, they're not going to drop the use cases of simple actors, and they'll support them. So anyway, this is just my whole, like, I wanted to make sure everybody was clear that, like, yes, while they might change, the whole concept isn't going away. You can still write out like this, and you're going to be okay. But then I actually talked about, like, you know, channels and the completed broadcast channel, how you can send things out and how those work. But they really are more primitive. So when we want to expose reactive code, we want to use flows. And one of the new things that are out there is Stateflow, like you talked about, which is really good for emitting things like state, like the state of our shopping cart. So yeah, I thought you'd never ask. So I brought this up because if I am talking about actors and I'm not talking about flow and stuff, like this example really does lead itself to Stateflow, but underneath the hood, actors is a really good way to make sure it's concurrent. So they're really going to blend together here and be friends. And we'll see that in our coding example as well. So what's a Stateflow? I actually talked about it a little bit, but it's a flow representing a read-only state that can be updatable. But like, yeah, only immutable state flow, which is one that you can use internally, can be updated. Otherwise, a state flow just is a flow that emits values, or you can grab the value just once itself. Yeah, the mutable state flow, like you talked about, is what you'd use internally to be able to set a value on it. But when you expose it to a client, you'd want to make sure that it is a regular state flow so that they can't actually change the value themselves. So here's where it comes into the live coding. So what's great about this presentation is, and why maybe things were a little out of order, is when I did this previously, I just showed this code that I ended up writing it in the PR here. So really, I kind of went through and it didn't make that much sense. So what we're going to do this time is we're actually just going to live code this because we have the time today. I'll do a time check real quick. So yeah, we're only 23 minutes in. So we have time to do this. So instead of explaining it here, we're going to literally rewrite we're going to look at the version I did to do an in-memory version of the shopping cart DAO. And then we're going to go ahead and change that over to be one using actors and one using mutable state flow. So let's check it out. So what we want to do is we want to do an implementation of this that uses actors underneath the hood and then exposes a mutable state flow as a flow. So I'm not that great at going in and out of presentation mode, but let's see if we can do it. Can I just do this? Yeah. So in memory shopping cart DAO. Yeah. Awesome. So right now, the version that you saw, so let's see if we can do this. So the version that you saw of the shopping cart DAO is our in-memory implementation. So that means if you go ahead and you kill the application, you open it again, it won't remember what's in your cart. I've used this same presentation to talk about the differences between SQLite and Room, which are both actual SQLite database implementations that you can use on a device. So there's actually an implementation in this code base that'll use Room if we turn that on. So it'll actually use a Room database. And then finally, there's like a SQLite version that'll take the SQL database. I'm going to just operate today, just for simplicity's sake, on the in-memory version. So I want to walk through you now, like what I had originally implemented for an in-memory version. So first of all, the data structure here wasn't ideal, but basically what we want to expose is just like we had in the app. So it would be like the name of the string would be avocado, and then it would have, it's a map. So the item with quantity would then be the item itself as well as how many. So this is what this is going to allow us to do is look up these values by label, which is this first thing, and then get the item itself. So it's going to be inside of here, like an item is, you know, avocado with the image of the, you know, the URL and then a link that went out to it. So if we look at this in-memory version, this is really the data object that we have backing everything. So we have the items in the cart and we want to go ahead and update that. And then we want to emit the new values with this channel. So this is older code that didn't use flows. So it just uses this completed broadcast channel to emit the latest value upon subscription of our item with quantity. So in the very beginning, I actually just emit an empty list because I don't have a value. But then I go ahead and this is the in-memory version. If we went ahead and we did an upsert, what it would do is it would go ahead and find this value in the cart and it would set it in. So it basically just adds it into the map. And then I'm going to send manually out to that channel, hey, here's the new sorted list of items, go send it out so that, you know, everybody listening in the code can get the new version of it. So that's pretty much how it's going to work in here. Like if you do a find, we don't have to go send an update. We literally just look in the map and say, hey, give me the item for this label. So find me avocado. Otherwise, when we actually modify things like updating a value, here we'll do a remove for that item. And then after that, we'll actually go ahead and then do a send to the channel to send a new value going out. And empty does the same thing, clear. So if you see the commonality here, anytime we modify the data here, here, and here, we end up doing a send to the channel. So we send out that new sorted list, we send out a new sorted list. And so what that's going through this channel that everybody's listening to, and they can go ahead and consume it. Now, I did make this private because I did do a little bit of migration to Flow. As Akshay said, you don't really want to expose these. I had originally, but since I did update this, I actually now expose it. I override that initial interface and I expose a channel as Flow. So this is an operator they give us so that people can subscribe to it as a Flow itself and use all the operators with it. So yeah, well, underneath the hood, it's using a channel, but it's doing this. Now let's take this and let's actually go ahead now and implement it with a, let's implement it with actors in Stateflow. So I'm going to go ahead and go back to the normal view so I can copy a file because I don't know how to do it from here. We'll go ahead and project. I'm just going to do a copy paste of this in-memory version. So we're going to call it an actor shopping cart, actor Stateflow shopping cart down. All right, so let's go ahead and make this a full screen again so everybody can see it. Appearance and enter presentation mode. All right. So this is an actor version. I'm just going to leave. I know he said make sure you write comments, but in this case, I'm going to move that so that we can read this a little better. We still are going to have everything backed by, let's see here. All right, let's get started. What I want to do first, and this, I'm going to move this stuff to the bottom so it doesn't get distracting. All right, so we have these four functions that we want to be able to do, or four things that we want to be able to do. We're going to find, upsert, remove, and empty. Like we talked about before, we want to like send in messages to this actor. So I'm going to go ahead and create an intention. So I'm going to call it field class intention. And this is live coding, so forgive me. Field class intention. And then what I can do inside of here, I can say other things. So I can do like an object, and I'm going to call one. Actually, I'll start with the top. So find by label. So we'll do a class, find by label, and inside of there, we'll send in a val of label, just like we have down there, which is a string. And then we'll end up sending in a deferred. So let's leave it like this for now because it gets a little complex to do it. The next class, we'll do an upsert. So right now, what we basically did is this is now replaced by this, or will be. Then now we're doing an upsert with an item with quantity. So really, we could just kind of copy this if we wanted. So this we want to call an upsert because it's a sealed class. And instead of here, we'll make it a val item with quantity. The important thing I'm going to do if we're subclassing a sealed class or creating one is you have to make sure you extend it. So if I go ahead and do that, I'm extending the intention. So now for the sealed class, I have two different types. So we'll keep going. We have remove and empty. So remove takes in, actually this is gonna be super easy. We'll just do this. So remove, I'm just gonna do it this way. And then finally we have empty, and then we'll just do object empty, extends, and this is going to extend intention. All right, so remove, let's finish cleaning that up a little bit. That's going to be a val item with quantity, and that needs to implement intention. All right, so now we have 4 intentions, and I'm just going to call this, we could also call these messages. All right, so these are the messages that we're going to send into this actor so that when we modify the data, we're going to go ahead and do it concurrently. So one thing that I'm going to do, instead of having this items and list being a map, I'm going to go ahead and change this, and I'm going to make it a mutable state flow. So let's go ahead and take all these 3 things, put them up top so we can see them. All right, so let's see the order that we have here. All right, so at this point in time, we have this hash map, a mutable hash map, or mutable map that takes a string and item by quantity. We then have a channel, which is the way of publishing new reactive changes to this. And we finally have all items, which we require because we're overriding it from that interface to expose the flow. So what I want to do now is we're going to go ahead and just like replace a lot of these things. So I'm going to drop this. It's going to make errors in the code below, but that's okay. Actually, yeah, we'll do that. And then what I'm going to do here is I'm actually going to go ahead and make all items. I'm going to go ahead and actually just assign it to a mutable state flow. So we'll do a mutable state flow list item with quantity. And I think, oh yeah, and then we have to initialize it with a list of. We'll import that. And this is like a really nice way of doing this. Mutable state flow is not a flow. However, we're overriding this value. Sorry, it extends flow. So at the end of the day, a mutable state flow will end up going ahead and actually extending flow. So when this is exposed to clients, it's actually exposing it as a flow itself. So anyway, I think Akshay was definitely saying don't expose one of these directly, but from the way the client will see it, or consumers of this will see it, will be a flow. So we go ahead and have that. So now what's really cool about this is a mutable state flow. We go ahead and we just set a value on it, and it'll automatically emit. So you saw it reduces the complexity a lot of what's happening. But now is when an actor is going to come in to be helpful to process the intentions that happen, and then use the mutable state flow to emit those values. So we'll just say here, emit changes, and allows us to set values internally. Cool. So that's what the mutable state flow is for, but it exposes the flow. So now down here, we have all these methods that are here. Now I have to implement these the way this interface works. So what I can do though now is I'm going to go ahead and comment out. Actually, I just dropped the current implementation completely. What we're going to have to do now is go ahead and implement them through an actor. So all right, let's write the actor first now. So we're going to say private val actor equals scope.actor. And actually, we need a scope. So private val scope equals coroutine scope dispatchers.default. Make sure we get all that imported. So we have that. Android Studio, thank you for the import. So now we've got a scope, and I can create an actor inside of a scope. And like we talked about with the coroutine, you need to have a scope that you run in, a coroutine scope. So inside this actor now, I can basically say an actor is going to process the intention. Intention. And then after that, I can just go ahead and create some brackets. So an actor, I can import it. It imports the actor, and I guess I should spell actor correctly. That's it. So an actor is going to take intentions that come in, and it's going to process them. So inside this actor, what we want to do is we want to have that for loop. So we're going to say for intention. In, let's see, channel. Oh, yeah. So the channel, so an actor is backed by a channel. So channel is actually, if we clicked in, it's just part of the actor itself. So for each one of these, we want to go ahead and we want to do a processing. So we're going to say when, because a sealed class is really nice to be able to do when statements to make sure that you actually, process everything, all the different variations. So we're going to say when intention, and then we can process each one of these. So first one is going to be is fine. So we're going to go through each one of these intentions and make sure we handle it. So first one is fine by label. Then what we want to do is process it. You got to make sure that's imported. Okay, intention not fine by label. So let's keep doing this as we go down. We're going to do upsert, and then we're going to do remove, and finally empty. So what this means is this actor that we've created will take intentions coming in, and then using a for loop. So like it doesn't matter. The channel is the way that we're able to send messages across coroutines. So all this background work is happening. You're passing them in via the channel, and then inside the actor, we're actually just going to process them one by one, and we're going to process them, sequentially. So I'm going to format my code. So all right, now we're going to process these. But we're not sending these intentions in the actor yet. So let's step back and do that. So down below, we already have these functions that I must implement. So what I want to do is, and we'll make this one a little bit later because that has the deferred part, which is harder. We'll start with empty because that one is pretty straightforward. So with an empty, what we're going to do is we're going to go ahead and we are going to do, actually I have to create my, so okay, down here, actor dot send, I send in my intention dot empty. That's pretty much it. So when somebody calls this empty function, I'm going to tell my actor, hey, here's an intention called empty. That'll go ahead and then call this block in here. Now we don't have a data source block, backing this. We used to have a map before. So I'm going to go ahead and actually put it inside the actor. So I'm going to put it inside of here. I'm going to do a val items in cart. Mutable. I guess I could have copied this over. Mutable map string an item with quantity. And then equals mutable map of. Cool. So now we have this item in the cart. So this is going to, it's typically not great to have something mutable, but if it's inside something protected like this, it's fine. Actually, like one of the things you could do, which is kind of nice, is you can actually write vars inside of here. With functional programming, you really shouldn't be doing this, but if you wanted to, you could use a var inside of an actor because the scope is only going to be within here. It's not going to be touched anywhere else, so it's going to be processed or interacted with in an imperative way. All right, so now we have this item in cart thing that we have backed. So what we can do in the empty is, just like we did before, we can do items in cart dot clear. Cool. Right. Yeah. Cool. So we can go to that. The next one then is going to be upsert. So with this one, we have a new value coming in. We actually want to do an update. So same thing, actor dot send, and this time it'll be intention dot upsert. And an upsert requires this value, so item with quantity, and we sent it in. So now up here, when we're processing upserts, we want to go ahead and say items in cart, and then we're going to do upsert. So it's going to be the item. So we're going to use the intention. So intention dot item with quantity, and because you're using sealed classes, it knows what type of I'm operating on one of these. So it's really nice in Kotlin. You get to do that. Item with quantity, I'm going to do the item.label. This isn't like the best, cleanest use case or whatever, but this is a pretty simple example I had that I could show you in this. And so what I want to do is I'm inserting and updating at this part in the map. So I'm just going to go ahead and say intention dot item with quantity. So what's happening is I said I want to do an upsert. It's basically getting the key, which is the label, and then it's going to set the value inside that map. So now this is what's backing it. All right, so we're modifying the map here with an upsert. We're modifying the empty down here with a clear. Let's go ahead and do a remove. I'm going to do a copy and paste because it's pretty similar. The difference here is going to be remove. Remove. So this time you're sending the actor, I want to remove it. So what we're going to do is we're going to say items in cart dot remove, and then we send in the key, which is that same really long key. That one. All right, and then the last one is find by label. I saved this one for last because it uses a completable deferred like we talked about. So if we do find by label, inside of here, we want to go ahead and send this in first. So we send it in. This time we have a label. So we're saying, I want to find this item in a database. Here's the label that I'm looking for. So first, we want to do a find. We're going to say, hey, I want to find this by label. The problem is I want to return back this value. All the other ones that we've done before don't need a return value. So an empty doesn't, an upsert doesn't, and a remove doesn't. But this one actually wants you to return this. So if we just send something to the actor, we don't have anything to return back. It just says, oh, I sent something in the channel. What we want to do is we're going to create a completable deferred. So we can create one of those. Let's call it deferred equals completable deferred. Boom, of type item with quantity, because I need to return an item with quantity nullable. So now I have this deferred object. I'm going to go ahead and send in label, and then we're going to do format. So I'm going to add one more item into this, which is a completable deferred. Format. So find by label right now only takes the label. In order to get something back out and to wait for it, we need to send in a deferred object. So we'll send in the completable deferred of type, item with quantity, question mark. So we send that in. What we're able to do now is down here, I'm now sending the deferred object is deferred. And then I want to return the value. So at the very end of this function, when I need to do a return, I can say return deferred dot await. So hopefully that wasn't too confusing. What we're doing here is typically in the actor, we can just send messages and say, go, 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 go. And it'll make sure it processes those in order. In this scenario, we want to do that. However, we want to wait and get the result back from this. So in order to do that, we're sending this thing called a completable deferred, which is basically a handle that it's going to wait until we've provided a value to it. And when it's kind of like async await on JavaScript. But we're going to go ahead and wait for a value to be set. Once the value is set or it's completed, then this will end up executing and it'll return back. So let's see how that's going to work up in our implementation. So in this case, we want to find by label. So we're going to say item in cart. We're going to look up by the label. So it's the same long thing. Get the label off. Oh, actually, no, it's not. We already just have the label primitive. So it will just be intention.label. And that's because we were nice enough to just say label on this one. And then what we want to do is we want to find this. So really, it would just be kind of returning this. But yeah, so we want to return it. So we're going to take that deferred object. So intention dot deferred dot complete. So that's how we did it. So let's see here. So we have our deferred object that got sent in with the intention. And when we say complete, what that's going to do is tell it, hey, here's the value you were waiting for and you're blocking for. What that's going to do as soon as this code is completed, the one that's awaiting will let it keep, it'll let it continue on, right? So it's completed, it'll take that completed value and return it back to this suspended method. So I think we have most of this implemented now. So let's go up. The thing that we're missing in all of this is this, the ability, okay, let's talk about what we have first, and we'll talk about what we're missing. So we have a bunch of intentions that represent the sort of things that we want to be able to do to modify the data. We have an actor which processes those intentions. And so what it'll go through, it'll find the intention, which type it is, perform the action on our data source, and therefore be able to operate on it. The thing that we don't have right now is the ability to take the new values, or sorry, the new data object, and then emit that out. And we went ahead very early on and created this mutable state flow so that we could actually do that. What we want to do now is we want to emit these out every time a change happens. So the way it works is down here after the when block, we know we process things. So what I can do is I can say, I guess it's called just items in cart. So yeah, it's a mutable, all items, dot. And so what's nice here is we can go ahead and just assign a value because it's a mutable state flow. And we could say equals items in cart, dot. And I have a function to do this, toSorted list. Yeah, toSorted map, there it is. Just, I think this is, all right. I might have to go to my other file here to see. So in memory shopping cart DAO. What was, oh, as sorted list. So that's the function I was looking for. It's an extension function that just takes this this map and then converts it over to the list that I needed. So it's going to go ahead and internally get all the values and then sort them by the label. And that way, like everything's going to like stay the same way in the UI when I display them. I want to make sure that they're sorted that way. So what this is going to do is every time we process, so we're going to wait for messages coming in on the channel. So we wait for messages coming to the actor. Each one of them that we're going to process one by one. Hey, what kind of intention is this? Is it a find by label? Is it an upsert? Is it remove? We're going to then execute the logic that's inside of those. And then as it's all done, we're going to go ahead and tell our state flow, which is what everybody's listening to as a flow. We're going to say, hey, here's the new values of the sorted list. So that really should do it. I'm going to be really dangerous here, and we're actually going to see if it works. So I think this is session graph impl. So I have this, anyway, this is a manual dependency injection in this. Don't get too much in here, but I'm going to replace the in-memory shopping cart DAO that we have now with our new actor. Let's see, actor, is that what we called it? Yeah, actor flow shopping cart DAO. So I'm going to use one of these instead. And what this is going to do is the DAO that we're going to use in the application is actually going to use this now. So let's see, run app. Let's see what it's looking like. So we'll see it flash here in a second if Gradle's, see how it's doing. It looks like it's building now. So let it build. But we'll dig back into our code. So when we run it now, it should use our version of things. I don't know how to see progress in this view, but I don't think it should be too long. I'm going to go back out of this view just so I can make sure we know what's going on with our build. Yeah, Gradle build running. We can look at the build here. Everybody loves Gradle builds. Okay, it's assembling. It's all right. We can go back now to our app, and it's published it. Yay! So now, is it going to work? I don't know. Hopefully, it will. Gala Apple, add to cart. Yay! So you see the top right here. As I add the items to the cart, 3, 4, 5. So it is working. It's emitting the new value with the state flow. Pineapple, go ahead and add a few of those. It went ahead and added them up. And then we'll go here to the cart and we can see them. Now, I want to prove to you it's actually this code running. So what we're going to do is inside of our code, we'll go back into that presentation mode. So inside of here where we're processing things, I'm just going to put the value that we're emitting. So this is really our new, I'm going to call it new value. And then I'm going to do val new values equals this. And that way we can just print it out here. So we're going to do just like a log.d, we're going to call it actor, and then we're going to print out new values, .toString. I have to import the Android logger. Done. And then once we do that, then we can go ahead and run it again. And so every single time, actually, let's get the intention going too, because this will actually be pretty cool to see that. Copy it. And so for each intention that's coming in through, we're going to print out what the intention actually is. So actor intention. And then down here, it's going to be actor, or I'll call it new values. Sure. So if I go ahead and do that, let's run the app again. And then let's look at the actual logcat that's going to be there. So I'm going to go back to the view because that's the only way I know how to do it instead of presentation mode. Next time I do a presentation, I'll make sure I put it in large font so I can do all these things at once, but I was not smart enough this time. All right, so logcat coming up. So shopping app, here we go. Gradle build running. That's a lot of stuff happening. Let's see when the Gradle build ends, and then we'll be good to go. All right, packaging, yay. All right, app initialized. Cool. All right, so now I'm going to clear logcat. I guess you can see this if I put it on the side. We'll put this on the side of my screen so you can see it. So this is the phone I have in my hand that we're using logcat for. I'm going to click on vegetables, and I'm going to click on kale, and I'm going to hit add to cart. So let me, before I do this, I'm going to clear, I'm going to add to cart. And you can see here it says actor intention. First of all, there was a find by label. And then I guess it's not a data class, so it's not going to print out in really nice. Let's see if I can make it a data class, because that actually might look a little bit better. Data. So one thing I love about Kotlin are their data classes, because you can then, it does a really nice toString. If I run this again, we'll see it. But you did see, like, it went ahead and got an intention, and the new values were nothing. Then it got a new intention saying an upsert because we added it, and then it has one value now. So intention was just fine, nothing, and then we added one, and then we had new value. So it might be because I'm doing 10 things on this computer why it has slower builds today, but it's almost done. There we go, and we'll clear this out. So it should relaunch here in a second, and we'll check out that we're actually getting everything we wanted. All right, so now we have our app running. I'm going to clear all this stuff out. We're going to go to seafood this time, and we're going to get some shrimp. So you can, let's see here. So now I'm going to say add to cart. There we go. So I hit add to cart. First thing it did was it found by label shrimp. The label shrimp coming in and a completable deferred. There's nothing in the cart to begin with. That was just what it needed to display this page. The next thing is, and I'm sorry, this is really small. Again, I wish I could probably make it bigger. Can I? All right, we're not going to go into that. But the next thing that's there is, I'm just going to add a few of these, and then we'll add, and then we'll go back, and then we'll add some lobsters, add. So what I'm going to do here is a tricky thing. We're going to take this output, and then we'll go back to presentation mode, and then I'll show you the output there. Let's put it in the top of this file. Boom, yay, it's big. Okay, so we'll move over. There we go. So we have it going through. Oh my gosh, it looks horrible. We'll comment it out. There we go. Yay. All right, so we go through. The first thing it needed was display the page. It needed to say, hey, give me the information on shrimp so I could show it. So we went through, label was shrimp. They returned back. I had that completable deferred so we could say, here's the value. Then we did an upsert every time we hit add, because it went ahead and said, oh, here, actually, I want to update the value to say we now have the quantity of 1. So I hit it again, quantity 2, quantity 3, quantity 4. And so now you can see at the end of this, the new values that I'm going to emit out are going to be for label shrimp. I have a quantity of 4. So that's what got put out. That's why the shopping cart item got updated and everything. And then we're going to go down. And the next thing I see here is a thing called a find by label for lobster tail. Because remember, we went back and then we clicked on lobster tail. So it actually had to go in and load that screen. So it said, hey, I need that data for that to render that screen, return it back with the completable deferred. And then after that, I start hitting the add button. So the shopping cart values at that point in time were just the item with quantity. So this is just what was already there, sorry. But after we do an upsert where we're adding a lobster tail, you can see lobster tails go up 1, 2, because I had 2 of those. But in the actual shopping cart itself, you have now the lobster tail with 1, and the shrimp is 4. So anyway, you get the idea, right? Let's go ahead and take this code back out because it's not really code, just my hacky way of showing you some stuff. All right, so what we've done here is we've done this beautiful marriage of like all these cool Kotlin coroutine features. We're using an actor in this case, and this is a pretty trivial case, but it was kind of a little bit easier to understand. We have an actor. Main thing is messages come in. We've called our messages intentions. They process them in a for loop so that we get concurrency. or they process them sequentially, and that way, like, our data is always processed in the order that we want it to. That intention that comes in, it's a sealed class. That's awesome. I can have different types coming in. So I can have a string on this one. I can have an item with quantity on this one. I can have all these options. And then when I go and process it, I process the data, and finally I emit it. There's one thing that's kind of cool that you might want to do, because every single time it was emitting new values. This is even if it went and it just found something, or it would go find something and emit new values, find something and emit new values. And what's not good about that is you're not actually modifying the data, but we're still publishing all these events. So something you could do is, I guess Akshay did talk about, and it's something I didn't know before, I think he said state flows only emit distinct by change. So it actually might be all right in that regard. But if that wasn't the case, what you could do is you could say if all items is not equal to new values. So it's actually not all items, it's going to be all items dot value. What this is going to do is say all the items that are currently there, let's compare it to the new values we computed. And if that's the case, then let's go ahead and set it. What this is going to do is make sure that it's kind of distinct until changed by, honestly. It's going to compare, is this a new value? Is this distinct? If it is, then go ahead and set the state flow, mutable state flow, which will make it emit. So same kind of thing. But yeah, thanks Akshay for that tip earlier about state flows only emitting distinct items. All right, so I think we went through the example pretty well. You have a good idea. If you want to, there is a link in the slide that goes out to this PR and pretty much implements the same thing. Going back to the slides, I think we're just wrapping up now. So, oh my gosh, state flow, you told me to use that now. That's experimental coroutines API. Man, this Sam guy and Akshay guys, like, they don't know what they're talking about. What are they doing? You know, the thing with Kotlin coroutines is it's fast evolving. And so they add these annotations on to say, like, hey, this is not completely stable yet in some cases. Like Flow, they've migrated to be good now, and they'll continue to do that. But what experimental coroutines API means is that, roughly speaking, there's a chance it might change a little bit in the near future, but they're going to provide a way that you can go ahead and migrate to that. So I previously in the past, in the team I'm on, we used channels a lot in the beginning because we didn't have Flow. But we wanted to do something reactive, so we used completed broadcast channels a lot. And what we would do is, when those things got deprecated, or some of that functionality got deprecated with receive channels and things, we went ahead and we migrated more to Flow. So there are definitely ways to do migrations there, but just there might be a little overhead on some of these things as you go forward. So the example I showed really showed how you can take an actor and a state flow and marry them together for something beautiful. Now, what I did in my example, I exposed the state flow as a flow, so that's only going to be exposed that way. But anyway, they can work really well together is the idea. An actor is not meant to replace a state flow or a completed broadcast channel. An actor is there to take messages that come in from different coroutines and process them sequentially so that you achieve concurrency. And then the state flow and flow objects and channels and things are ways of broadcasting those reactive events and things. So they're beautiful because they're complementary to each other. They can be used together. The actor provides that thread safety, which is needed for concurrency. And state flow is a nice data container. So it allows you to emit a flow or to describe data from it. But it's a nice way to contain that value object that we are modifying. So that kind of wraps it up. Thank you very much. Yeah, I'm Sam Edwards. Feel free to follow me online at @HandSandSam. And thank you so much again, the organizers of Android Stream Day. This has been really fun. Thank you.
Yeah, thanks, Sam. That was an awesome session and like pretty awesome stuff. So today, actually, in Understream Day, all the sessions were back to back on Kotlin. So first, there was Monika talking about MockK, and then there was Akshay talking about Flow, and then you, Actor, and then Yury will talk about Multiplatform.
Nice.
So, great. So yeah, thanks again for taking your time and talking to us.
Thank you. Appreciate it.
Thanks,
the
Sam.
computer's kind of, yeah, no worries. It's kind of slow, so I'm trying to stop screen sharing and things. But I think it's because my disk, I'm recording this locally, is like gotten really full. That's why.
That is totally fine.
Cool.
That's totally fine.
You have so many fans, man.
Oh no!
Everyone is loving your talk.
Awesome. That's great. Thank you. I'll try to get the recording out here if I can get it saved correctly. So if it's still sharing my screen, I'm sorry. I'm just like making sure I save this because I've had other times when it doesn't save or crashes my machine and I feel so sad.
That is totally fine.
All right, cool. Actors, cool. And then I'll make, this will probably make my machine go a little faster once I save it. So.
Yeah, okay. So that was Sam. And now we will move ahead for our last speaker of the evening. And he is Yury. And his talk will be after half an hour. So we will play our last quiz. And then we will move to our last session. So are you guys ready for the quiz? If yes, then write yes in the comments right now. I'm waiting for next 1 minute. So I'll be back, okay, with the quiz. Okay, guys, so I'm back. And let's see if you're ready for the live quiz. Quiz number 3, #3. And pretty much excited for it. And I want more of you to join as soon as possible so that we can start the quiz. And there's some problem, I guess. I'm not visible. Yeah, let's take it. Take a look what's happening. Okay, so if you're already there listening to me and interested in the quiz, then please join ASAP. We will be starting. I'll share the link of the quiz right now in the comment section. So be here. I'm sharing the link very, very soon. And let's see if you can. Am I not visible? Is that's what happening? Okay, I should be visible now, I guess. Let's see. Okay, I'm waiting for more people to join for the quiz. Come fast, guys. And this is probably the last quiz because after that we have the last session of the day. Thanks, Sam, for joining us. And we will be waiting for Yury. Sam is gonna join the quiz, but I don't think he's gonna answer because otherwise it won't be fair enough. I don't know if you guys can see me, but I think there is some issue with my camera probably. Let me try again if I can make it work. One second. I'll be coming back. Okay, it's fine even if you cannot see me. I'm actually here, but somehow this thing is not working properly for me. And so should we start the quiz? Okay, I can So I just sent the link of the quiz in the comments, and it's there. We have only 10 minutes to fill the quiz, so 10 minutes to go, and then we'll see who wins. So the link is already in the chat, live chat. So please check it out, and yeah, the 10 minutes, only 10 minutes, and then we will take a short break before we go for the last session for this Android Stream Day 2. And also one quick information, Android Stream Day 1 is now available to watch with all the timestamps. So I know most of you requested that you want to see Android Stream Day even after this live stream, so that whatever you have missed, you can cover that up. And we are listening to you. So that's when we thought about providing all the timestamps as well, so that you can go to a specific talk and you can watch it. And similarly, Android Stream Day 2 will also be available in the same fashion. So all the timestamps will be there. So yeah, pretty much excited for it. And now let's see who is filling the form for the quiz. Pretty much excited for the quiz. And please, if someone already knows all the questions, are you gonna join it? Please don't join. Okay, you can join. I mean, it's totally fine. It's not a challenge. Everyone can join. Anyone can join. And it's all for fun. I haven't got any response yet, but that's fine. It's 10 questions. It might take some time. So yes, guys, 10 minutes, and we have already 2 minutes gone. So only 8 more minutes to go. I can see 15 people are here or 20 people are here. So all the 20 people should play the quiz. That's what I am looking for. But at the end, it's your call. And I'll be back just in 2 minutes. And in the meantime, let me just check what's wrong with my camera. And once I back, I want all of you to fill all the responses. So I'll be back in just 2 minutes. In just 2 minutes. Okay. Okay, guys, so I am here again, and I hope all of you are already filling the quiz. We have got only 2 responses yet, and we don't have that much time. We have just 5 more minutes to go, or maybe 7. So 7 minutes, and yes, I want all of you to participate, and even Sam, you can participate if you want. Yes, I am back with the video. That's why I took a break for 2 minutes so that I could check what's wrong. And sometimes what's wrong is just refreshing. So that's what was wrong. So pretty much excited. Thanks Sam, Nate, and all of you guys in the comments for joining. I know it's Sunday. I know it's kind of this COVID situation. People are so much stressed. People are so much kind of working for different things. So that's totally fine, and that's why we made sure that you can watch all this stream even later, and you can again reach to us. So we'll definitely do more such sessions in the future. That's the plan, and I think that's where all these speakers, you can see how much hard work they have done. Like, they are from different time zones, and really thankful to all of them, and to all of you as well. It's not easy to be here for all the day, for like 2 days in fact, for the live stream. So thanks for joining again, and there's one more session to go, so don't go anywhere as of now. And before that, there is a quiz to take. So quiz is already live, and I can see not many people are filling it. I have just 2 entries, one from Sriharsha, one from Shreyas Patil, and I'm still looking for more responses. I think people are taking some time. Don't cheat, because this is not a competition. This is just for fun. And yes, only 5 minutes to go, not more than that. And then we will take a small break, and then we will be back with the last session of the day. And guys, if you want to support us, you know how to support. Like the video, subscribe to the channel, share with your friends, even after the stream, because this stream is gonna be here forever. I mean, at least till the time everything becomes obsolete. So we will be back with season 2 with all these great speakers as well. That's our promise, but you have to show your support for that. And also, if you want to support us, you can also donate to this channel using patreon.com/mtechviral. You can also join this channel and become a member to support us. Or you can do one more thing, and that is you can use super chat while you are chatting with us. So I see number of users have gone for break. Maybe some people are having their dinner, because it's I think it's 8:45 in India in the night, so that makes sense. But yes, be here before 9, because our session will start at 9. Okay, so just 2 more minutes to go, guys, and still waiting for responses. I know that's not the greatest time to take quiz, but fortunately we are able to take it. So still the quiz link is there in the chat. You can still go and you can fill the quiz. We still have 2-3 minutes, and it hardly takes 3 to 4 minutes. And see, we got a donation from Napping Geek. He's so kind. Please check out his channel as well. He has a channel, tech channel, and yes, he's the same guy who has done all this setup which you are seeing here. So thanks to him, and thanks for his donation of 4K for this channel. And follow him, follow his channel as well, guys. Napping Geek. He is a tech enthusiast. Everything related to hardware, you can go to his channel, and he is the one who made this possible, this entire setup. It's not it's not like what we used to have in previous streams. So again, shout out to him. So let's see how many people have filled the quiz. Oh, it's still, we are waiting for responses. Only 2-3 responses are here, and to be honest, there are only, there's no 10 of 10. So yes, keep them coming. And 2 more minutes, and then we will take a short break, and we will be back with Yury Camacho. He's the GD for Android, and he will be talking about Kotlin multi-platform and using an example. So That's a pretty good thing. If you are interested in cross-platform thing, multi-platform thing, Flutter, Kotlin, all these things, definitely attend his talk. And he will be here in next few minutes, next 5 to 10 minutes. Apart from that, what else is there is the quiz. And thanks for joining. Keep supporting, like the video, subscribe to the channel. That's what we want. I'm like waiting for 1 more minute and then we will move to the next session. I know many people think that's a tough quiz. It's not tough actually. 1 or 2 questions are tough for sure. But yes, we got 1 more response. That's pretty good. We are waiting for more responses. We just got 4 to 5 response yet. How many people are there? 15 people are here, so at least 10 to 15 responses should be there. That's what I am targeting. Then guys, I'll leave you after this last session, so don't be in a hurry. We are also waiting for Yury and his great session on Kotlin multi-platform. So let's see. 1 more minute, guys. Last 1 minute. Please fill the form and then I'll share who won. Okay. And I think someone took full of his time. Maybe he Googled or maybe not. I don't know. But someone has given all the 10 answers correctly. So that's good to see. And we will organize separate quizzes as well in the future. So let's see how it goes. Anyone else filling the form? And also, guys, later we will share you the feedback form as well so that you can share your feedbacks. Also, we will share all the slides and all the details which we will get from the speakers. So you can follow us on Twitter. Every link will be shared on Twitter, and you can follow us on Instagram if you want to see some behind the scenes pictures. And also, there will be this particular video separate from the last one, like which we did yesterday. So both videos will be available by tomorrow with full timestamps, so you can check all the all the talks separately, individually, and you can watch anytime. It's totally fine if you are busy. It's totally fine if you want to watch it maybe while working. So yeah, it's all your choice. Okay, we got 1 more response, and okay, I'm stopping it so that we can take a break and then we will be back. Anyone else feeling? If yes, then you can write in the comments right now in next 10 seconds, because we have a latency of 10 seconds. That's why. Oh, so Sam is just sharing his views that he got only 6/10. Okay, that is totally fine. Okay, so I am now stopping the responses. Thanks everyone for participating, and now let's share the questions and let's see what could be the answer. Okay, so the first question was, Android doesn't support which format? MP4, MPEG, MIDI, or AVI? So the answer is AVI. And shout out to our volunteers for preparing these questions. This is not me who has prepared it. This is not Rivu who has prepared it. This is all volunteers who has prepared it. What parameters specifies the Android API level that Gradle should use to compile your app? Minimum SDK version, compile SDK version, target SDK version, या test SDK version. So the answer is compile SDK version. True or false? A scroll view can contain only one view or view group as a child. True or false? The answer is true. To make your Kotlin code more seamlessly callable from Java code, functions with parameter have a default value, must use the annotation. And what is that annotation? Add JVM static, JVM field, JVM name, or JVM overloads. I think most of the people get stuck into this. Yeah, there is one wrong answer. So the answer is JVM overloads. This one was answered by everyone. You can create an emulator to simulate the configuration of a particular type of Android device using a tool like AVD Manager is the correct answer. Everyone answered it. Which construct in MockK can be used to mock Kotlin objects? It's mock, which with extra K, mock object, spike, none of these. And most of them answers mock with extra K because that was one of the sessions as well. But the answer is mock object here. So yeah, that's where you are wrong. The next one was also very interesting. Can mock be used to mock suspend functions? So there was yes, no, none of these, all of these. I don't know why those two options are there. It could be just yes, no. But yes, two people said yes, two people said no, and the answer was yes. You can do that. What's a way to restrict the direct access of some of an object's field? Encapsulation is the answer. Live data is not the answer. Who is the founder of mock? And the founder is Alexei, and this is a very difficult to pronounce, but I'll try. Penko. Yes, something like that. Not Rivu Chakraborty. One guy answered Rivu Chakraborty, so not Rivu Chakraborty for sure. In which directory the XML layout files are stored? All of you are correct. It's res/layout. Okay, so that's more or less about it. I forgot to tell you who won the quiz. The person who won the quiz is suyambhu.vps@gmail.com. I don't know his name, but he can definitely let us know in the comments that, okay, I'm that guy. Okay, I know you didn't Google it. Don't worry. I was just kidding. So thank you so much for joining. I'll be back with Yury in next 5 to 10 minutes. So keep That's totally fine. Hello, people. We are here for the last session of Android Stream Day, day 2. And guess what? We have Yury with us. He will be talking about Kotlin multi-platform by example. And if you are already the fan of multi-platform, cross-platform, then this talk is for you. Yury is basically Android GD as well, and he gives a lot of talks in Spanish, I guess, right? And it's one of his English talks, and he's kind of nervous, so make him feel that he's at the right place. So yeah, pretty much excited, Yury, to have you, and thanks for joining us. Over to you. Go ahead.
Thank you for accepting me. Thank you for having me here. So I don't know. Let's talk about multi-platform. So my name is Yury Camacho. I'm a Google developer expert for Android. I work on a Rappi company, is some delivery application. And I love Android. That is the reason why I am, I don't know, I always giving talk about Android. And this is my Twitter account. If you have some questions, if you talk to me about Android, about multi-platform, about anything, or just say me hi, this is my Twitter. Just ping me, send me a message, and everything will be fun. Let's talk about something like this. By example, we have a small application that we need to just show the current weather and the forecast for Android and iOS. And we have many things that are different, right? The first thing is the operating system. We have for one side iOS, for the other side we have Android. We have language. For iOS, we have Swift and Objective-C. For Android, we have Java or Kotlin. The UI UX components of the UI, they are very different. The handling error is different too. The libraries is different. By example, if you want to do some HTTP request for Android, usually we use Retrofit. If we want to do HTTP requests for iOS, we use Alamo Fire, by example. And the APIs is different. If you want to, I don't know, get the location or access to the Bluetooth or camera is very different in Android and iOS. And the architecture is different. We have for Android MVP, MVVM or MVI. In iOS, usually they have MVC or Viper. There are many differences if you want to build applications like this. We have options. Yeah, we have many options in the market. Native Stream, React Native, you build something, you write your code in JS and this transformed to native code. We have Ionic or PhoneGap, that is WebView, using WebView with web page. We have Flutter, this other option for do application for Android and iOS. Xamarin 2 is something like almost React Native script, but you write your code in C#, right? But we have other option. This is Kotlin. If we love Kotlin, we just want to write code in Kotlin. And Kotlin has this idea that is Kotlin multi-platform. Just thinking about build an application for all platforms, right? For Android, iOS, web, backend, or embedded devices, we need to learn many languages, right? Because I need to do something for Android, I need to learn Java, Kotlin, for iOS, Objective-C, Swift. For web, I need to learn JavaScript. For backend, Go, Python, I don't know. And we need to learn many languages. The idea behind this is not, you don't need to be an expert in that all language. You just need to use a Kotlin multi-platform. What is Kotlin multi-platform? It's an experimental feature language, but even it's experimental, but I know a lot of companies are using this feature in production. And so it's not that so experimental because there are many companies that are using Kotlin multi-platform. Kotlin multi-platform allow runs Kotlin and Android, iOS, web server, etc., and allow share code between platforms. This is very important because you don't write in code and making some transformation for executing in all platforms. The idea behind Kotlin multi-platform is share your code, trying to isolate your business logic and share and build this in Kotlin and share this business logic in many platforms. Something like this. I have my business logic written in Kotlin, and using for in all other platforms. How it works? I write my business logics in Kotlin, and I use some plugins for transformate for share in other platforms. By example, I have my shared business logic in Kotlin. I'm using Grail in Kotlin JVM for using Android. If I want to use Kotlin multi-platform in iOS, I'm using Kotlin native, using LBVM, is a compiler that Kotlin use for transform your code for native code for each platform. In this case, in the web, you need to use Kotlin JS plugin. If you build something for backend, Kotlin JVM, and if you build something for embedded devices, LVVM2. One end, this is a concept that I manage. One end is, let's see again the first picture that I want to build an application for Android and for iOS. This is all the difference that I have when I'm trying to build these applications. And there are many things that never will change. The operating system always will be iOS or Android. The UI UX never change because the users for iOS, they love the iOS ecosystem. They love the components, the buttons, the labels. They love his whole ecosystem. And the Android, they have no problems, but they usually use his own buttons, his own labels, his own components, UI components. And the APIs never will change. If you want to build or access to the GPS, by example, is very different and always will be different. But if you use Kotlin multi-platform, you can get something in common. By example, the language will be Kotlin. The handling error will be the same. The libraries will be the same. By example, I want to do some HTTP requests. I will use Ktor, and Ktor runs on Android and iOS. And the architecture, right? I'm going to tell the architecture later, but the architecture will be the same. So one end is because you have one code base to write, you have one code base to test, you have one code base to maintain, one code base with business logic. If you have some bug, you have one code base to fix. And you have one team maintain this code base, business logic code base. And you have any UIs. The idea is something like this. I have my business logic, but every platform has his own components, and the users don't feel weird when they see, okay, this is iOS, and this, okay, it's iOS, and I have all my UI components in the application. Did the same with Android. Let's talking about the architecture. I was reading, searching about the best architecture, and personally, I love this architecture. It's clean architecture, and I can apply clean architecture with Kotlin multi-platform. The idea behind this is, okay, I have my presentation layer, I have my domain layer, I have my data layer. Right here. And what happened here? Usually, my domain layer and my data layer, I can share with other platforms. By example, again, I need to do a HTTP request for get some data. So I will use Ktor for make the HTTP request. The repository will be the same. I have my repositories, I have my use case for get the data, and in my presentation layer, I have the presenter or view model. This will manage for each platform. And if I want to get some data, I just need to instantiate my use case and say, okay, give me, I don't know, the user list, give me the current weather, by example. Kotlin Native. What is Kotlin Native? Kotlin Native is a LLVM backend for Kotlin compiler. Runtime implementation and native code generation, and it's designed to allow compilation for platforms where we don't have the JVM, the Java JVM. How it works? I write my code in Kotlin, this generates an intermediate representation, and LLVM transfer in the native code. Let's talk about Kotlin multi-platform keys. Source set. My source set is this will contain my code, my common code, and my specific implementations for each platform. I'm going to share later an example about this. Target is, okay, I will build my Kotlin multi-platform application, and the target will be Android, will be iOS, or will be JS, or will be, I don't know, Mac OS. I need to put here which, what will be my targets. The preset is the preset for, I don't know, runs in, I don't know, by example, in iOS devices, in Android devices. And platform specification is something like interfaces, but more strong. By example, I have my application, and I need to know when Kotlin is running in Android or iOS. So I will have in the common package, I will have a class with platform name, but I write in a spec keyword spec here that that say, okay, I have the platform name, and each platform need implemented this method or this this function. Here, when the application call, okay, create application screen message, and Kotlin rocks on, platform name will be called to the Android or iOS, depend that where the application is running. Let's see, this is the spec and this is the actual. In the Android main package, I will have this implementation with actual keyword, platform name, return Android. So if I run in Android, maybe in the screen will appear Kotlin rocks in Android. In the iOS case, is something like is a similar thing, because I have the actual, I have the platform name, and it's returning iOS. So when I run this application on iOS, in the screen will be appeared Kotlin rock on iOS. So let's see the example. The project example is this. I need to show in the screen the current weather and the forecast, and I will use Open Weather Map for do this implementation. The tools, what tools I need? I need the IntelliJ IDEA or Android Studio, app code if you want to write something in Swift using the JetBrains tools, and you will need Xcode for write code in Swift. Libraries. We have in this moment a lot of libraries. By example, Ktor is for make HTTP requests, serialization, for map your JSON into objects. SQLite is a database that runs in Android and iOS. Coroutines, multi-platform settings or multi-platform preference is something like user default in iOS or share preference in Android. You have Corin, Corau for audio, Kisme for security, Kotlin, that dependency injection, and Clock for manage the timing. And here in this URL, you have a lot of libraries that supports multi-platform. How it works? I have my common code. This will be using Kotlin JVM for Android, Kotlin native for iOS. This is one thing that I not mentioned before, is when you execute your your build in Android Studio for iOS, you generate iOS framework. You need to import this into the iOS project, and you can use all the common code in iOS. And Kotlin.js, but in this example, I will not use Kotlin.js because I don't know nothing about about web. So this is the project structure. I have this project. I have the app, will be the Android app. Core, this is the common code. This is a module, it's like a library. And iOS weather, this is what is the Swift code. Usually when you create a new project, you don't have this iOS weather. I create in Xcode and move here just for upload to the GitHub. In the core build grade, you need to apply two plugins. The first in the main plugin is Kotlin Multiplatform, and the other is Kotlin serialization, just for use the serialization library. Use your targets. You need to set your targets where your application will run. In this case, I'm selecting iOS. If I want to make some tests in the simulator, I need to set this preset, that is iOS x64. If I want to run this in real devices, I need to use this preset, like iOS ARM 32 or 64. The targets. Source sets, that here is where the code will be contained for each platform. I had common main here, Android main, and iOS main. So if I'm using some libraries, by example, in this case, in the common main, I will use Kotlin's coroutines core common library. I'm using other implementation for serialization, and I will use Ktor, the client, Ktor, for make the HTTP request. For iOS, it's the same. For Android, it's the same. So I have a diagram, a big diagram for this core application. I have my domain package. Inside this, I have my actions, the models, and the forecast. This is something like use cases. I have my data layer, where is my repository, my forecast repository, current weather repository, and the network package, where is the APA.kt for implement Ktor. The more important thing is Android and iOS will need to instantiate these classes, get forecast and get current weather, for use all these core module. Let's see the model. The model is, I have a current weather, it's a Kotlin data class. I'm using serializable here because I need to transform the JSON into this class object. And the network. In the network, I will use Ktor. I have this class. This class is APA.kt. I'm instantiating the HTTP client. It's a lazy client. And here I have my class that will get this data and transform this JSON into the object. Let's see, it's a suspend function, because it's an HTTP request, and I need to manage in another thread or another coroutine the request, and I will receive a name. This name is city, and this method will return current weather. I have my URL here, open weather map, blah blah blah, and my key. And here I'm using the client and get the data, making the request. This returns me a string. This string will be transformed or parsed into the current weather object. And that's all. This method returns me a current weather. Platform specification. Each platform will manage his own thread, his own background task. So in the common main module package, I will have one class named dispatcher.kt. This will be an expect. It will get or receive get coroutine dispatcher. So Android will need his own coroutine dispatcher, and iOS need to manage his own coroutine dispatcher. Let's see what happened in the Android side. So in the Android, I have here the actual, because I'm implementing this expect method. I will use the default dispatcher, the default that Android will use, and there is no much thing here. And here is the big thing. Sorry, because here I need to do some stuff, like I have a class, NSQ dispatcher class, who will receive dispatcher queue. This is the manage. This function returns or manage the asynchronous in iOS. This will return a coroutine dispatcher, and this implementation is using platform Darwin. This is Kotlin, but it's using implementation or methods from iOS. So let's see the repository. The repository, I have one repository, current weather repository. This repository will receive, this method will receive the city, the success, and the failure. This is a higher order function. If everything is good, we'll return the current weather. If we have some problems, we'll return a trouble. I'm using global launch coroutine, and here is the application dispatcher. So if I will run this application in Android, this will call to this function, manage the default dispatcher. If I will run in iOS, maybe it will execute this part of code, right? And so here I'm making the call using the Ktor, the Ktor, and everything is good. I apply in success. If I have some problems, okay, I will execute the failure part. And the use case I have this class, this get current weather, where have a method. The same, I have the city. I need to pass the two higher order functions, success or failure, and execute the repository, and this will return the current weather or failure. Consumers. So I have my core, I have my business logic in Kotlin, multi-platform, and I need to use this. For Android, we'll generate a JVM or a jar file, or I can import just like a project. Let's see the example. In the app part, I need to add this implementation project path core, but the name of my Kotlin multi-platform is core. And I have my forecast view model. We're receiving current weather. I'm injecting the current weather. And the only thing that I will need to do in this part is just make the call to this method, get current weather by name, passing the city. If everything is good, I have a key live data. I'm going to post value the current weather. If I have some errors, I have a method to handle this error, and that's all. In the iOS side, this Kotlin native plugin will generate an iOS framework. So I need to add this framework and add to Xcode. I'm going to show later this part in the code. And so I have a view controller. This view controller is in Swift. So in Swift, here I have the method get weather by city. I pass in the city, and here I'm instantiating this current weather, and I'm making the same call, get current weather by name, passing the city, and if everything is good, I'm setting this value, current weather, with the result. If I have some problems, I'm just printing in the console empty error. So let's see the code. Give me 1 second. I'm going to show my font. So that I said, I have here my project. This is Android Studio. I have the app module, core module, and the iOS. Let's see the core module. I have here Android main, common main, and iOS main. This is my source set. I have my Grail file. Here is the plugins, multi-platform plugins and serialization. What more? I'm using Ktor version 1.14. I have here my targets with my preset. In this case, I'm using just for Android and for iOS. Then I have my source sets. Common main is the same like here. Android main is the same here, and iOS main is the same here. The package here. I am using coroutines core command. I'm using the serialization runtime command. So I'm using Ktor client core. And that's all from here. So let's see a little bit the code. I have here my data package, domain package, and shared package. Here is the dispatcher. Here is the coroutine dispatcher. Here is the spec. And I need to implement this in my other package, my other sources. By example, iOS. I have here a dispatcher for iOS, and I'm implementing here all my NSQ dispatcher for manage the background threads. And the same in Android. Sorry. The same in Android. So I'm using the default dispatcher. Now let's see a little bit the code here. So I have the data layer. I have my network that I show. I'm creating the HTTP client, so I have some commented code here. Don't pay attention on this. I have here my methods for get the HTTP request, fetch current weather by name, fetch current weather by location, and passing the latitude and longitude. I have here my fetch current weather by holding by name. I have a lot methods here that these methods are making the HTTP request. I'm using Ktor. I have here the call to the Ktor to the request, to HTTP request. Here I'm mapping my response into current weather. I have here my repository. By name, I'm receiving the string, the city, the higher order functions. I'm executing the HTTP request with the API class, and here is the dispatcher. If I put this, is pointing to the common main class that name is dispatcher, right? So when I run this application in Android, maybe it's call this and then execute this dispatcher, right? The same in iOS. So, so I need to use this core in my Android application. So I need to make some things in the build grade in the application. The first thing is this implementation project path core, because the name of this module is core. And that's all. That's all that I will need to do just for get the data and use the Kotlin multi-platform project. Here I'm injecting the current weather. This current weather is generated here. There's the current weather consumed from the core project, and I just need to execute in the coroutine with coroutine scope, and here I'm calling to this method get current weather by name, passing the city, passing the high order function for successes and failures. And it's calling to this, and this method is into the core. Let me find this. Actions, current weather, and it's here. Current weather by name. And now let's run this application. So here I'm using Android and everything is good or almost good. Oh. Everything is good, and I will hit the emulator. I don't know. London. So it's working. So how I build this thing for iOS? First, I need to create the iOS framework. So I have here, Grail will help me with this. I'm going to core project, task, build, and build dependencies. And it's running and it's creating the iOS framework. See what happened. And there are many options for do this. This is the best option for me. And I need to go to the core, Rebellion Finder, here, core, build, bin, iOS, and I have here two folders. I have here a debug framework and release framework. I will use debug framework. I have core.framework, and I need to import this into the iOS project. In 1 second, I'm going to. I have here Xcode, and I need just no, it's not generating. Let's do it again. It's running. It's running. It's running. So the idea is generate here the debug framework and add into the Xcode and just using in Swift. By example, I have here import core. I'm importing the library, the iOS framework, and I need to just use here. What is here? Here I am instantiating get current weather. This is a class, and just need get the current weather, passing the city, in the high order function. Is everything is good? I'm setting the current weather, the result in this current weather variable. And if so, I have some error, I just print in the console empty error. Let's see. Yes, now it's generated. Yeah. Let's add this. And oh, it's not working. So sometimes I need to do some configurations in the project. I don't know, make some changes in the build settings. Oh, wait, here. See, everything is good. So let's see. Oh, it's not working. It's weird. Well, I need to add some stuffs here. No. Well, something happens. The idea was try to add this. Usually when you add this core framework here, you just need to put play and it's working. I have all the code in repository if you want to try to fix this, because I don't know what happened in this project. You can help me with that. But as you know, you just need to import the library and use it. Creating the classes and making the calls, and that's all that you need to do for build these Kotlin multi-platform applications. Let's see, presentation here. This time no lock for iOS, but for Android, yeah. So the idea was build two applications with business logic, and each platform with its own UI components. This is the repository. If you want to check the code, add something, get better this code, to get better the application, please do it. And thank you. I think that's all.
Okay, here we go. Thank you so much, Yury, for this amazing talk on Kotlin platform, multi-platform. And yeah, that's it. That's the last session which we were in, and now we will just wrap things up. And before we do that, we have, I guess, a couple of questions for you.
Okay.
So I don't know if it's really something which you can answer, but the question is, could we be able to use Flow in Kotlin multi-platform, or it's just for Android?
Flow? I don't
Flow.
know.
It's a library, I guess.
Yeah. I don't know. I never tried Flow in multi-platform.
Yeah, actually, there was a talk on Flow before you.
Yeah.
So
yeah. But
that's
I
what
don't know.
I guess. Okay.
It will be good to try something like this, right? See if it's working good.
Yeah.
Maybe next time. But it's
Next
good.
time, for sure.
It's my homework now.
There's one more. Although I don't know if I can explain you properly, but the question is, is there any option to share view model as the same as the use case? I don't know what's the use case here.
Yeah. I saw many examples in the internet about sharing view model or presenter. But in my case, I'm implementing this in my job, and in my case, I use the use cases like a services, right? Because you just need to create the object and make the call for, I don't know, by example, for get the user list or get some other data. It's the dependency is not so strong. You just need to inject this class and make the call to the use case and get the data. Sometimes I don't know, create a more hard, strong dependency, creating with the view model in that. You can do that. But in my case, usually I use just an use case. I need to inject the use case in my view model or on view controller. I make the call and that's all. But
Awesome.
we can do that. We can use in view model or presenter.
Got it. No worries, fun. Maybe in future we will again call you for some amazing stuff like this. Maybe with more experiments, because I think it's gonna be a long journey with Kotlin multi-platform as well. It's just started. So yeah, thanks again, Yury, for joining us.
No, thank you. Thank you for having me. Thank you.
And
thank you so much.
Yes, that's how we are gonna end Android Stream Day 2. So yeah, it was really amazing to see you guys joining for 2 days continuous streaming for 8 plus, which is like 16 hours of streaming. We did around 11 hours in Flutter Stream Day. Okay, so before we go, I just want to give shout out to all the speakers. Please go to our website stream.mtechviral.com and check out the links, follow them, and we will also share all the links to slides very quickly, maybe tomorrow. And as I told you earlier, our like these streams are available to watch as well. So you can watch day 1 right now with all the timestamps. So you can choose your speaker and you can follow the schedule on stream.mtechviral.com. Okay, yeah, so that's about it. Now about shoutouts. Thanks to all the speakers who joined us, and maybe yesterday as well and today as well. Thanks to all the volunteers who helped us in preparing all of these things like the quizzes, the app selection for Apps Mania, and all these things. And I'm having Ribu with me, who is another co-organizer for this Android Stream Day. And Ribu, if you want to share something, go ahead.
Yeah, thanks everyone. Thanks so much for joining us. Thanks to the speakers and thanks to the audience. So, like we had a really interactive audience. Audience continuously supported all the talks and asked a lot of great questions. And without that much interactiveness, the conference wouldn't have succeeded. So yeah, thanks everyone for joining, and volunteers also supported a lot. They tweeted and shared in different social medias. They actually accumulated the questions for the quizzes. So yeah, thanks to everyone.
So yeah, we were a very small team, and we didn't think that we will get this great response from you guys. Also, I want to give shout out to some of the audience which were really consistent, and they have been following us since yesterday, tweet like asking questions, active in the chat. So the first guy which I definitely want to mention is Shri Harsha Chilkapati, if I'm pronouncing is correct. Thanks so much for supporting us in this particular stream day thing which we are experimenting. And people like you is definitely give us confidence that we should host such events in the future as well. The second guy I want to shout out is Hitanshu Dhawan, then Ayush, Shivesh, Aniket, Santosh Bhandari, Fadi Chalab. So all these guys who has been very much active. So thanks to you as well, and all the other audience. I might have forgot few names here, but yeah, really thankful for that. And yes, people want to say something.
Yeah, no, you can continue. Thanks to Nate as well for being interactive in the chat.
Yes.
We hope to get him in next Android Stream Day.
So yeah, we'll try. I guess we will try back to all the speakers as well as all the people who were in the comments to be a part of Android Stream Day next time as well. And having said that, just want to tell you that we are also planning to do Web Stream Day next, so that might be coming very soon. Depends on your feedback and your response for this. Also, thanks for supporting. There were kind of donations which also happened during stream days on both days. We saw many people donating, including Sam, Napping Geek, and all the people. So thanks for doing that. And you can still do it using patreon.com/mtechviral. And you can also become a member of this channel. Please let us know in the comments what your views, because this video is gonna be here. All the timestamp will be there as well, so that you can watch it later. Also, one thing to mention is that if you feel that it is useful for you, or there's something which you learned, then definitely share with your friends as well, and also let us know your feedbacks. We'll definitely share the feedback links as well for all the registered people. So yeah, I think that's more or less about it, and we are now wrapping up things.
Yeah, and thank
Thanks
you
for
Yury,
joining.
again.
And yes, we will see you soon again with another season of Android Stream Day or any other stream day. So thanks for joining and see you soon. Bye bye.
Bye.
Good night. Take care.